A business can have thousands of customers, millions of transactions, and years of data. But none of that matters if they can't answer simple questions like what is data actually telling us? Why are sales going down? Which customers are most likely to leave? Which products are performing best? And most importantly, what should the business do next? These are not just business questions, they are data related questions, and answering them is what data analytics is all about. A data analytics takes raw information and turns it into insight that businesses can actually use to make better decisions. That's why data analytics has become such an important part of almost every industry today, from banking and healthcare to e-commerce, manufacturing, and technology. Hello everyone and welcome to Data Analytics full course by Intellipaat. In this course, we will take you through the complete data analytics journey step by step. You will learn how to work with data using Excel and SQL, analyze it using Python and statistics, and turn your findings into interactive dashboard using Power BI. But this course isn't just about learning tools. We'll also understand how data analytics approach a real business problem, from collecting and cleaning data to analyzing it, finding patterns, and presenting meaningful insights. Whether you are a beginner, a working professional planning a career switch, or someone looking to build practical data skills, this course will give you a structured path to get started. By the end, you will have a clear understanding of how raw data is transformed into insights and how those insights can drive better business decisions. So, without any further ado, let's get started.
Also, if you're someone who wants to upskill in data analytics and build a strong career in this field, then you can definitely check out Intellipaat's data analytics program in collaboration with iHub IIT Roorkee. This course has multiple learning paths depending on your choice, including certification programs, executive PG programs, and even advanced certification programs in collaboration with top universities and IITs. One of the biggest advantages certification from Microsoft and iHub IIT from institutes like IIT Roorkee, IIT Madras Pravartak, and IIT Guwahati, which adds strong credibility to your profile. Moreover, the curriculum is designed and taught by industry experts and IIT faculty themselves. So you're not just learning tools but understanding how things actually work in real world scenarios. That's not all. They also provide dedicated placement support with a network of over 3,100 plus hiring companies. You get complete assistance with resume building, interviews preparation, and job opportunities. So if you're serious about upskilling and want structured path instead of figuring everything out on your own, this is definitely something worth exploring. I have provided the details in the description below. Check it out now. Before we get into the tools and the code, we need to settle one thing. What is data analytics? It might sound a little technical, but the idea is very basic. Data analytics is all about taking raw data, which is usually messy, scattered, and hard to understand, and turning that raw data into meaningful insights that actually help in making decisions. Think of it in this way. The moment you interact with a product or scroll through social media or even use Google Maps, what you're doing exactly is you are generating data. You are leaving signals behind. And these signals capture your behavior in detail. Let's understand this from a marketing point of view. Let's say you're working as a marketing analyst at a company like Nike. Now, your job is not to just run campaigns, but to understand how people are interacting with your products online. When users visit the website or app, you start tracking their behavior. You observe which product people are clicking on the most, which one they are spending more time on, where they pause, where they scroll past, and what they ignore completely. You also track which products are added into the cart and which ones are left behind. Individually, these actions might not mean much, but when you look at this data at scale, clear patterns start to appear. You might notice that a particular shoe is getting a lot of attention. People are clicking on it, zooming into images, and spending time on it, but very few are actually buying it. Now, this is where data analytics comes in. Instead of guessing, you start asking the right question. Is the price too high? Are there not enough size option available? Are users dropping off after seeing delivery charges? Is this happening more on mobile compared to desktop? Now you're not just looking at data, you are understanding behavior. And once you identify the actual reason, you can take action. Maybe you will adjust the pricing, improve the product description, or fix the checkout experience. And that's really the whole idea. Data analytics is the process where raw data turns into clarity. And that clarity helps in making better decisions. And once you start looking at things this way, you will realize every product, every app, every business around you is constantly using data to improve itself. And that's the whole point of data analytics. Now let's explore where data analytics is actually applied in real world industry. See, we don't have to look far. It's already influencing the decisions you see around you every single day. One of the major use case of data analytics is in e-commerce. On platforms like Flipkart, the product you see are not random. That's an algorithm analyzing your viewing history to predict your taste. Another major use case is in streaming platforms like Netflix or Amazon Prime Video. The shows and movies recommended are based on what you watch, how long you watch, what you skipped, and even what you rewatched. Then comes ride sharing platforms. In apps like Uber, pricing is not fixed. It changes based on demand, location, time, and all driven by real time data. Another important use case is in banking and finance. Analytics constantly monitor transaction to detect unusual activity and prevent fraud. In healthcare, patient data is analyzed to improve diagnosis and treatment decision. And even in content platform like YouTube, the content you see is carefully recommended based on your watch patterns. So the idea is simple. No matter the industry, if there is data, there is analytics deeply embedded in decision making across almost all the industry to improve decision and outcomes. Now let's move to the next part, that is role of a data analyst. In order to understand what a data analyst does, let's think of a data analyst as a professional translator. On one side, you have business leaders speaking the language of goals, revenue, growth, and on the other side, you have raw data that speaks number. Now, analysts' work is to sit right in the middle and connect the two parties. In most cases, the work starts with data that is messy and unstructured. So, the first step is to clean it, organize it, and make it usable. Once the data is ready, the analysts start exploring it to find patterns, trends, and any unusual behavior. But the most important part of the role is not just doing analysis, it's their communication. A data analyst looks at number and tries to understand what they actually mean for the business. After that, they present these insights in a simple way, usually through dashboard or report so that even non-technical team can understand them. And finally, the most important part, they help in decision making. They answer questions like what is going wrong, what is happening, and what should be done next. So, in simple terms, a data analyst act as a bridge between the data and decision. Now, let's start with the demand. We are currently in 2026, and the scale of information we are dealing with is almost huge. Right now, the world is generating over 402 million terabytes of data every single day. To put that in perspective, that's about 2.5 million terabytes every hour. We have reached to a point where 90% of all the data that has ever existed in human history was created in just the last 2 years. Every company from a bootstrapped startup to a global giant like Google is droning in information. They have the data, but they are starving for insights. Now, at the same time, everyone is talking about generative AI. There's a lot of hype, and that is right as well. But here's what most people miss: AI runs on data, and someone still needs to understand that data, clean it, analyze it, and make sense of it before any AI system can create a value. In fact, data analytics is not getting replaced, it's getting stronger with AI. Today, analysts are not just working with data manually, they are using AI to speed up analysis, automate repetitive tasks, and generate insights faster. And that's something we will also explore in this video: how data analytics is evolving with AI and how you can actually use it for your advantage. If I talk about job demand, in India alone, there is a projected shortage of over 11 million data professionals this year. This is not just a job trend, it's a global shift. If you have these skills, you are not just looking for a job, you're solving a massive high stake problem for a business. Now, let's talk about the part that changes lives: the salary. If you are a fresher starting out today, a realistic entry level package in India ranges from 5 to 9 LPA, but it scales faster than almost any other career path. Once you hit that 2 to 4 year of experience mark and you have proven you can solve real business problems, those numbers grow. Mid-level analysts are easily getting packages between 12 to 22 LPA. And if you decide to specialize, if you become an expert in fintech, healthcare, or AI driven analytics, the ceiling basically disappears. Senior analysts and analytics managers are crossing the 30 to 45 LPA mark. So the bottom line is this: companies are desperate for refiners, the people who can turn raw data into meaning. In a world where AI is changing every industry, being a person who understands the data behind the AI makes you virtually recession proof. Next, we have types of data analytics, and it's usually divided into four types where each type answers a different kind of question. Let's say Amazon Prime launches a high budget series. The trailer performs really well and large number of users start watching it on day 1. But after a few days there's a clear drop in momentum. The show is getting views but engagement is not building. People are not continuing beyond the first few episodes and the platform is not seeing the expected growth in watch time. Now, the first thing they will try to figure out is what exactly is happening. And this is what descriptive analytics is. They analyze the data and see that while the show has a high number of initial clicks, the completion rate is low. Most users are dropping off within the first two episodes, and average watch time is lower than expected. Once they know that, the next question is, why is this happening? This is where diagnostic analytics comes in. They dig deeper and analyze viewers' behavior. They analyze that the first episode is not engaging enough, or maybe the storyline is slow at the beginning, which causes users to lose interest early. Now, the next question becomes, what is likely to happen next? Here comes the predictive analytics. Based on past trends, they can estimate that if this pattern continues, the show might fail to retain audience attention and overall engagement for the platform could drop. Finally, the most important question: what should be done? This is where prescriptive analytics comes in. It suggests actions like improving the show's promotion, highlighting better parts of the content in trailers on pushing repeat, or pushing it into the right audience through personalized recommendations. So, if you look at it as a flow, it moves like this. First, you understand what happened, then why it happened, and what might happen next. And finally, what should you do about it? And this progression is what makes data analytics so powerful. Next, let's see the flow. Think of this as the journey every single piece of information takes before it actually becomes useful for decision making. It all starts with collection. This is the raw stage. Grabbing data from everywhere like website clicks, sensor reading, or customer survey. For example, when a user places order on a website or make payments, all of that gets recorded as data. But most of that raw data is a total mess. That leads us to the most famous part of data analyst job, which is data cleaning. You will often find missing values, duplicate records, incorrect data types, or incorrect entries. So, this step focuses on fixing those issues to make data reliable and ideal for the next phase. Here, your job will be to remove duplicate orders, filling missing values, or correcting the wrong formats. After cleaning, the next step is data transformation. Here, the data is reshaped into a more usable form. This can include creating new columns, changing formats, or combining multiple data sets. For instance, converting timestamps into proper date formats for creating a new column like total revenue by multiplying price and quantity. Then comes a very important step: data modeling. This is where relationships between different data sets are defined. Instead of working with isolated tables, you connect them. To understand this clearly, let's say you have three separate tables: a customer table, an order table, and a product table. And each one of them stores information related to its own purpose. The customer table contains details about customers, the order table stores information about transactions, and the product table holds details about the item being sold. Individually, each table gives you only a partial view. But when these tables are connected through common fields, they start forming a complete link. This is where we model our data. You will link these tables using common columns. For example, customer ID connects customers to orders, and product ID connects orders to products. When these relationships are defined, all the data starts working together. Now you can find out which customers are buying which product category is generating the highest revenue, or even which type of customer are contributing the most to sales. Next, we move to data analysis. This is where you explore the data to find patterns, trends, and insights. You start thinking like which product is performing well, where users are dropping off, or which region is generating the most sales. After that comes data visualization and reporting. The insights are presented using charts, graphs, or dashboards so that they are easy to understand. Instead of going through raw numbers, stakeholders can quickly see trends and make sense of the data. And finally, we have decision making and action. This is where actual value is created. Based on the insights, businesses take action, they fix problems, improve strategies, or optimize performances. So, every tool you learn in data analytics fits somewhere into this life cycle. Now let's get an overview of the tools that are commonly used in data analytics, and more importantly, why we actually learn them. Because each of these tools solves a different problem in overall process. First is Excel. Excel is used for initial data handling and basic analysis. It helps you clean data, apply formulas, and quickly explore patterns. It is simple, easy to use, and perfect for understanding how data behaves. That's why it is usually the starting point for most analysts. Next comes SQL. SQL is used to work with databases. Most companies store their data in massive databases, and SQL is the language you use to talk to those databases. Without it, you are just standing outside a locked room. We cover this so you can pull exactly the data you need without waiting for a developer to do it for you. So, the main purpose of learning SQL is to access and manage data efficiently. After that, we have Python or R. These are used for advanced analysis. When data becomes large or complex, Excel is not enough. Python helps you to automate tasks, handle large data set, and perform deeper analysis. Instead of spending 5 hours cleaning a file manually, you write a script that does it in 5 seconds. They are also used for predictive modeling and machine learning. So, the purpose here is to move beyond basic analysis and work at scale. Finally, we have Power BI or Tableau. These tools are used for data visualization and reporting. They help you convert your analysis into dashboard and visual that are easy to understand. The purpose here is to communicate insights clearly so that businesses can take action. Now let's talk about the skills you actually need to become a data analyst. Let's start with critical thinking. This is one of the most important skills. As a data analyst, you should not just look at data and accept it as it is. You should ask questions like, why did this drop happen? Is this pattern real or just a coincidence? Critical thinking helps you to go beyond surface level analysis and actually understand what's happening. Next is business thinking. Data is useless if it doesn't connect you to business goals. You need to understand how a company works, what drives revenue, what impacts growth, and what problems matters the most. Because your analysis should always answer a business question, not just a data question. Then comes statistical thinking. This helps you understand whether your insights are actually valid. Just because you see a pattern doesn't mean it's meaningful. Statistics helps you measure that. It helps you avoid wrong conclusion and make decision with confidence. After that, the next skill is tech literacy. Over time, you should start developing a feel for data. You should be able to quickly look at a data set and get an idea of what's normal and what's not. Also, being comfortable with tools and basic technical concept is important so that you can work efficiently. Then comes data storytelling and communication. You might have done a great analysis, but if you cannot explain it clearly, it won't create impact. You should be able to present your insights in a simple, structured way so that even a non technical people can understand and act on it. Now, before we start with the tools, let's do a quick quiz. Your question is, a company notices that a large number of users are dropping off at the final step of the checkout process. The analyst studies user behavior and identifies that the checkout page is slow, which is causing user to leave. Which type of analytic is being used here? Option A, descriptive analytics. Option B, diagnostic analytics. Option C, predictive analytics. And option D is prescriptive analytics. Take a second and think about it and put your answers in the comment. The correct answer is option B, which is diagnostic analytics, because we are identifying the reason behind the problem. So, how do you actually analyze data? To understand this, I want you guys to meet Alex. Alex is a data analyst. One day, his company noticed that the sales suddenly dropped in the last month. Nobody knew why. That's when Alex was asked to find out what went wrong. He started by collecting data. He looked at sales reports, website activity, customer reviews, and feedback forms, anything that could give clues. Before doing any analysis, Alex cleaned the data. He fixed mistakes, filled in missing information, and made sure everything was accurate. Clean data is important because bad data gives bad results. Next, Alex explored the data to understand what was happening. This step is called exploratory data analysis. He used Excel for quick checks, SQL to look through large databases, and Python to organize and visualize the data using tools like Pandas and Matplotlib. While analyzing, Alex noticed something strange. Many customers were adding items to their cart but not finishing the payment. Alex figured out that maybe the payment page was slow or confusing, and he quickly shared this insight with his team. They improved the payment page. This small fix could help increase sales next month. In the end, Alex created simple charts and a short report. He explained his findings clearly in a meeting. His job wasn't just to look at numbers, it was to tell the story behind them. Alex used two things to do all this: data and tools. And the best part, data is everywhere on websites, apps, surveys, and more. With the right tools, anyone can learn to work with it just like Alex. You also need to understand some core concepts like what makes data clean or messy, how to find patterns using statistics, and how to build dashboards or reports that others can easily understand. And don't worry, we're going to teach you all of this step by step, even if you've never written a single line of code before. So let's get started with our very first tool, which is Python. Let's begin with the most basic concept in Python, variables. They're like a container that holds information. You can use it to store a name, a number, or even something more complex. For example, you can write name equal to John, which stores the word John as a string in the variable called name. If you write age equal to 25, the number 25 is stored as an integer. And similarly, if you write height equal to 5.4, Python understands this as a decimal or a float. What makes Python really convenient is that you don't need to tell it what kind of data you're storing. It figures that out on its own. This makes writing code much simpler and faster. Now let's say instead of storing just one piece of data, you want to store a group of items. This is where we use something called a list. A list lets you store multiple values in a single variable. For example, if you write the information using commas inside a square bracket, you can use indexing starting from 0 to access any value. So if I write person and 0 in the brackets, I will get the output John. Similarly, person 1 will give the output 25. Lists are also mutable or changeable. That means you can update any value from the list using the indexing method. Lists are also flexible. That is, you can add new items to them or remove existing ones using simple commands like .append or .remove. Now, sometimes you might want to store multiple values like in a list, but you want to make sure that no one can change them later. That's where tuples come in. A tuple is very similar to a list, but once it's created, it cannot be modified. For instance, if you write comma separated values inside parentheses, you've created a tuple with two values, and they stay exactly the same. What this means is, if you try to change a particular value, Python will raise an error. Tuples are great for storing data that shouldn't change, like a fixed location, phone numbers, or dimensions. Moving on, let's talk about dictionaries. A dictionary in Python stores data in pairs, a key and a value, just like a real life dictionary where each word has a meaning. For example, if you write this piece of code, then name, age, and height are the keys, and their respective values are John, 25, and 5.4. You can get the value of any key simply by using its name like person and inside the square brackets, the key, name, which will give you John. You can also update the values or add new pairs anytime you like. Now let's take a moment to talk about loops, which are one of the most powerful features in any programming language. Loops help us repeat a task multiple times without having to write the same line of code again and again. In Python, we mainly use two types of loops, the for loop and the while loop. A for loop is useful when you know exactly how many times you want to repeat something. For example, if you want to add up the numbers from 1 to 10, you could either do it manually or you could let Python handle it using a for loop. Here, the loop goes through each number from 1 to 10 and keeps adding it to the variable called sum. On the other hand, a while loop is used when you want to keep repeating something until a certain condition is no longer true. Let's say you want to add numbers only up to 5. You can use a while loop that starts at 1 and stops when the number becomes greater than 5. This allows you to automate repetitive tasks easily and efficiently. Now that we've covered variables, data structures, and loops, let's move on to one of the most important concepts in Python, that is functions. This is a block of code that's designed to do one specific task. Instead of writing the same code again and again, you can just write it once inside a function and then use that function whenever you need it. Let's say you often need to add two numbers together. You could write the addition logic each time, or you could create a function that does it for you. In this example, we've defined a function called add numbers that takes two inputs, A and B, and return their sum. Once this function is created, you can use it anytime just by calling it. And with that, you now have a solid foundation in the basics of Python. These concepts will keep showing up as we move forward to data analytics. So feel free to pause here and try a few of these examples on your own. Next, we are going to look at NumPy, which is known as numerical Python. Now, if you guys find it difficult to follow along, I'd recommend you watch the full course on NumPy where I have explained everything in detail. But if you do have a basic idea, we will quickly revise the important concepts in NumPy. We will first import it using the NP alias. Now say you are given some sales data which you store in a NumPy array. This is your 2D or two-dimensional data. The first row represents the north region and the second row represents the south region sales. And the columns represent the months. Suppose you want to look at the east region's numbers. You can simply write sales and pass the index 0 in square brackets and it gives you the first row. Similarly, we can also check how West performed in March using multi-dimensional indexing, and NumPy will return the value 1300. Now let's say you're asked to calculate the total sales from both regions across all months. You don't need to write a loop or manually add each number. Using NumPy, you just need to write a single line of code, which is np.sum, and pass the region sales. Similarly, we can also check the average sales of each region. Here, axis is equal to 1 is telling NumPy to look across the columns, or in simple terms, go row by row and give the average of each. The result will show you the average sales for East and West. But what if you want to look at each month instead, across both the regions? You just change the direction, meaning now your axis will be equal to 0. Now let's explore another important property of NumPy, which is reshaping data. Let's say you receive a flat list of numbers, maybe 12 values, representing monthly sales for a region. This line of code creates an array from 0 to 11. It's a straight line of numbers, but you want to turn it into something structured, maybe 4 rows and 3 columns. All you do is reshape and pass the shape in the parentheses. And just like that, your raw data becomes clean and structured, perfect for analysis. You don't need to loop through anything or manually split it. NumPy takes care of it. Now sometimes when working with large data sets, and this is important, you might encounter missing or zero values. You don't want those zeros to affect your average, so you might want to remove them. With NumPy, that's easy. You now have only the months that had real data. This kind of operation would take several lines in regular Python, but NumPy makes it quick and elegant. Now here's another situation. Maybe you need to simulate or generate dummy data, something like 100 random customer transactions. NumPy has a built-in way to do that. This line of code creates 100 random numbers between 100 and 1000. Each one could represent a transaction value. It's incredibly useful when you want to practice or test your code without using real data. By now, you can probably see why NumPy is such a powerful tool. It helps you manage data in rows and columns, perform calculations instantly, reshape it however you like, and even clean or simulate it as needed. In the last section, we had covered NumPy. So before we move ahead with pandas, I want you guys to understand the basic difference or the basic requirement why we need pandas. Alright, so basically we saw in NumPy how we were able to perform various numerical as well as arithmetic operations on our arrays. That was basically a data given to us in the form of arrays, right? So why exactly do we need pandas, or what is pandas? Alright, so in order to understand that, I am going to go ahead and show you guys an Excel sheet. So as you can see over here, I have some data. So once you guys get familiar with data analysis, you guys will be able to tell me that this is something known as house price prediction data set. But we need not get into the details of that right now. So for now, all you have to understand is that there are different features or different columns representing the features of a house, right? So we have the square feet, that is the area of the house. We have the city, we have the state, we have the condition, we have the waterfront, which basically is telling us whether there is a waterfront. So basically 0 and 1 is how our data is being represented. Okay, so the number of floors, the price. All right, so we have all these features in our data. All right, now if I were to represent the same thing in a NumPy array, I would have my array something like this. Okay, so say I'm just representing two houses, and these two houses have two bedrooms, two bathrooms. Okay, and the other house has just one bedroom and one bathroom. Okay, this is what my NumPy array would look like. Okay, this is basically my house 1, my house 2, and this is my bedrooms, and this is my bathrooms. Okay, so do you guys agree with me or not? Would our NumPy array look something like this or not? Except we wouldn't have this information with us. We would just have an array that would look like this. So this is the major issue that comes in NumPy when we are dealing with data. Okay, so since we only have two columns over here, maybe we can try and remember that the first one is bedrooms, the second one is bathrooms. But in case we have 12 or say 50 columns, how are we going to remember what each and every column is representing? So this is where Pandas steps in. Pandas is nothing but a tabular format of data, just how we saw in Excel. It gives us a similar representation of data in our notebook. Alright, so before we go ahead and see the demonstration with Pandas, first we'll understand why Pandas. So here are some of the important features that Pandas provides us. So it gets very easy to import our data sets. It could be a CSV file, it could be an Excel sheet, okay? It could even be your SQL database. So you can import any sort of data set in your Pandas environment. I'll be using Google Colab in this video, but you can use Anaconda or even your VS Code. Alright. Then comes your data cleaning. So this is a very important step. Now what exactly does data cleaning mean? So when we say data cleaning, we are talking about missing values and majorly the invalid values. Okay. So when we talk about missing values, okay, let me go back to my Excel sheet. Okay, so this is the data that I have, right? So say in case of this particular value over here, 10500, what if I had a blank cell over here? That would represent my missing value. Okay, so that is basically what missing value means. So if we have a particular data set and some of the values in our data set are missing, so whenever we're dealing with that kind of scenario, we will be dealing with those missing values. Okay, we will be seeing how we can do that with Pandas. And the other case is invalid values. So say I have an age column. Okay, now we know our age can normally range from 0 to 100. Taking the worst case scenario over here, we have 100 or say 120. Okay, it cannot go above that and it cannot go below 0. Alright, so this is basically a standard age range. But what if I have a value say 200 in my age column? Now this is basically an invalid value, right? I cannot have an age that is 200 if it's for humans especially. Okay, so I would understand that there is some typing error or there is some mathematical error, and the common way of dealing with this invalid value would be dividing by 10, right? So 20 is a valid age, but 200 is not. Okay, so that is basically what invalid value means. Size mutability. So we can easily add and delete columns or rows. Okay, then we can reshape our data set, we can pivot our data set, we can efficiently manipulate and extract from our data set. And most important step is statistical analysis. Okay, so we can easily have all the statistical analysis of our data with just a few lines of code. Okay. Now moving on to the prerequisites to learn pandas. So you need to know any programming language, preferably Python. But if you know any other programming language as well, it's not an issue. Okay. And the next one is maths. That is basically you need to know some stats or inferential statistics. You need to have a basic idea like what is standard deviation, what is variance, what is mean, median, mode. So basically you need to have a basic idea of all those terms. So moving on to pandas, we have two primary data structures in pandas. First is series, second is data frame. Okay. Now what is data structure? Data structure is basically a collection of data types that provide the best way of organizing the items or the values in terms of memory usage. Okay. So series is going to be our one-dimensional data structure, whereas data frame is a two-dimensional data structure. Okay. Now series basically represents only a single column from the entire data set, whereas a data frame is able to represent the entire data set. Okay, that's the basic difference. So let's go ahead. Okay. So series we already discussed is one-dimensional. Why it's one-dimensional? Because a series would look something like this. So say I have a price column and these values would be represented by an index value by default. Okay. And remember our index is always and always going to start from 0. So this is our series. Okay. So over here you cannot say this is a two-dimensional or it has two columns. This is the index and this is our one and only column. Okay. So this is why series is a one-dimensional data structure, because it can accommodate only one column and you can extend it to as many rows as you want. Okay. So it is a one-dimensional labeled homogeneous array. Homogeneous array means it can accommodate only either integers or string values. Now, it's not that if I were to add, say, a string ABC, I would get an error. Rather, if I were to add a value like this, all of my integers would be converted to string. Okay. So, this is why series is called a homogeneous array, because if I add a single string value into my series, all of my integers are going to be converted into string, and my data type of this series would be object. Okay. If I were to have only integers, my data type would be integers. Okay. So this is basically what it means. And very important property is it is size immutable. Now what this means is I cannot delete a particular row from here. I can only remove it, and when I perform the remove operation, basically I am going to be returned a new string. That is, my string originally is not going to get manipulated, rather I'm going to be returned a new string where my values would look something like this. Okay. So this is basically what size immutability means. And even if we try to append a new element, we would be again returning a new series rather than manipulating or rather than changing the original series itself. Okay. Now moving on to data frames. It is a two-dimensional data frame because we can have multiple columns. So we can have a price column, we can have number of bedrooms, number of bathrooms, and so on. Okay. We can have unlimited, or you can say n number of columns and n number of rows. So basically it can be extended in this direction as well as this direction, whereas series was able to extend itself only in this direction. Okay. And this is going to be a size mutable tabular structure, and it can be heterogeneous type. Heterogeneous means we can have, say, integers in this column and a string, all the string values in this column. Okay. So we can have multiple data types supported in data frames, and it is size mutable means you're easily able to add and delete the rows and columns. Okay, so I hope the difference between series and data frame is clear. So let's go ahead and look at the implementation in our notebook. But before we do that, I hope you guys remember you are supposed to install pandas using pip install command. Let me just show you guys quickly. So you can go to your terminal or any command prompt, and all you have to do is type pip install pandas. When you run it, you're going to have a few lines of code run for you, and then finally you're going to get your requirement is satisfied, and then after that you can proceed with importing pandas as PD. Okay. So again, this is an alias. Just like we used an alias for NumPy, we are going to use one for pandas, which is PD. Okay. So I'm going to run it. And If you guys remember, I told you guys in the NumPy video that NumPy is going to be used throughout your data analysis process. So right now we are going to focus only on the pandas features, but when we come to real data sets, which I'll be showing you, I'll be importing a real data set also using a CSV or an Excel file, and then I'm going to show you how NumPy and pandas both are going to be used to perform various operations on that data set. Alright, but right now we are going to be only focusing on pandas, understand the features and the implementation. Okay, so as you can see, I have successfully imported my pandas, and the green tick over here basically represents that the operation was successful. Okay, so now what I'm going to do is I'm going to create a basic series using pd.series, and I'm going to do so using a list. Okay, now if I go ahead and print it, so you can see my data type is in64 because all of these are integers, and by default I got an index value of 0, 1, 2, 3 and 4. Okay, so as I told you, my index is always and always going to start from 0. And now if I were to add another element, say a string value ABC, you can see now my data type is object, and all of these that were integers earlier have been converted into a string form. Okay, so I am going to remove this for now because I want to show you guys some operations that we can perform in series. So I can go ahead and check the data type of my series. It's in64. Then I can go ahead and check the values of my series. Okay, so you do not need any parenthesis. So these are the values of my series data structure. So you can use s.index to check the index of your series. So you can see over here my starting value is 0 and my stop value is 5 and my step value is 1. Alright, so basically I have my index from 0 to 4. So here you can get an idea about your index as well. Okay, and lastly you have s.name. So it's not printing anything because it's none. So if I print s.name, you can see it's none because we have not given any sort of name or any sort of value to a column. Okay, in order to assign a value to our column, we can just say s.name, and we can assign a value to our column, say those are just numbers. So I'm going to write numbers, and if I print my series, you can see this is what my series is going to look like. Alright. So that was it about the random functions. Now we're going to look at an important topic called indexing. Okay, so you can do indexing using square brackets like we normally do for lists, and we have also done for NumPy arrays. So similarly, you can do it for your series in pandas. So if I want the first element, I'm going to say S0 and I get the first element, that is 10. Okay, so if I want multiple elements, all I'm going to do is S0 to 2, and you can see my ending index or my ending value is not included in my output. So let me just comment it over here, and then we have the step value. So we have done this indexing in list as well, and you guys are well aware that your starting value is always included, whereas your ending value is never included. Alright, so whichever value you want at the end, you give your stop value plus 1 to your desired value you want in the end. Alright, so say I want values at index 2 and 3. My syntax for that would be S2 to 4. Okay, so as you can see over here, I got my values at index 2 and 3. Alright. Now another way to perform indexing is by using a function called iloc, which basically does location based indexing. So what this means is it is going to use the indexes, that is the 0, 1, 2, 3, 4 that you have as indexes, and it is going to fetch the values at those particular indexes for you. So all you have to do is say s.iloc and value at 3, and I print it, and you can see I got 40. So at index 3, I have value 40 and it's giving me the correct value. Okay. Now if I want multiple values, all I have to do is s.iloc and use double brackets and pass all the indexes that I want my values at. Okay. So I want value at index 1, 3 and 4. So as you can see, I got my output just as I intended. So this was all about location-based indexing. Now another important feature in series is that you can change the index according to you. Okay. So instead of 0, 1, 2, 3, 4, these numbers actually represent the calories. Okay. These are the different calories. So you can see I have changed the column name to calories. And now I want these calories to represent the fruit. Okay. So I'm going to create a list of all the fruits that are present in my carries. So you can see I've created a random list of fruits and I've stored it in the variable index. Now what I'm going to do is I'm going to say s.index and I'm going to pass my index variable. And then I'm going to print my series. So you can see over here, I am basically trying to say my apple has 10 calories, banana has 20 calories, grapes has 30 calories, and so on. Okay. So this is how you can change your indexes according to the information you are trying to represent. Now do not comment that I have put wrong calories for the wrong fruits. This is just a random data that I have created just to show you guys how indexing works. Okay. So now if I try to access any value using my indexes, so if I want to find the calorie of grapes, I can just say S grapes, okay, in square brackets. Now can I use ilog function over here? Let's try it. Okay, so I get an error because this is not a location anymore, right? So when I had my numerical indexes, ilog was working absolutely fine. So I can still use ilog, but for my numerical indexes, right? The original indexes, that is, we have indexes in lists, we have indexes in NumPy, we similarly have indexes in series as well, okay? So we can do that by ilog, but again, how will we remember what is index 3, right? So that is why we have another function called log. This is label based indexing, okay? So using log, we can go ahead and say, and you can see I get my value, okay? Now another important thing you need to remember is in label based indexing, your start as well as stop value both are included in the output, okay? Now this is a very important thing that you need to remember because unlike normal indexing or the indexing that we do in list, numpys and all, whenever we are using a normal list, our stop value is never included. Alright, now say I want my calories of banana, grapes and orange. Okay, so what I'm going to do over here, so you can see my banana, grapes and orange. So all three of them, that is my starting value as well as my ending value, both have been included. I hope label based indexing and location based indexing, that is your normal indexing, the difference between both of them is clear. Difference between log and ilog is clear. Okay. So let me give you guys a quick recap. We learned how to create a series using a list. Okay. We saw the default indexes. We saw the default name, which is none of the column. Then we saw how to check the data type of the series. We saw how to check the values and the indexes of the series. Then we saw how to rename our column or the series. Okay. And then we went ahead and looked at indexing. We saw normal indexing. We saw indexing using ilog. Okay. Then we went ahead and changed the index of our series. We gave a different set of indexes to our series using s.index equal to the new index. And then we went ahead and performed indexing on our labels. That is, we used the new indexes to index the values. And then we also looked at the label based indexing, that is using log. Okay. Now, if I want to access multiple elements over here, multiple values, again, I have to give double brackets and I can say grapes and then I want apple and I can print it. So you can see I got my desired output. Okay. So that is all about indexing. Now let's also see how we can create a series using a dictionary. Okay. So I have already created a dictionary for you guys, which is basically fruit protein. So our keys are the fruits and our values are the proteins or the grams of protein stored in that particular fruit. Okay. So this is our dictionary. Now if I want to create a series out of this dictionary, all I have to do is say, I'm going to name it S2 because this is my second series, and I'm going to say pd.series fruit protein and I'm going to print it. Okay, so you can see, and by default the name of our column over here that is representing the protein is 0. So I can go ahead and say name equal to protein. Let's run it. Now my series is giving us a complete information of what our data is representing. Okay, and you can see the data type over here is float. Okay, again you can go ahead and perform the similar kind of operations on this particular series. I will be sharing this notebook with you guys in the description below so you can download it and do the necessary operations that we saw in our earlier series, that is our series S. So all those operations can be performed on this particular series as well. So I want you guys to pause the video, download the notebook and perform these operations. And if you guys face any doubt, comment it in the chat box below. I will respond to you guys at the earliest possible. Okay? Alright, so I'm assuming now you guys are done with the earlier operations. Now we'll be looking at something important and something new, which is called conditional selection. Okay? Now what conditional selection basically means is, now I want to fetch all the fruits over here that have protein greater than 1. Okay? I want to find out all the proteins that are greater than 1. So what I'm going to do is, I'm going to say S2 greater than 1. Now you can see over here I've got boolean values that are representing true and false. So wherever I have protein greater than 1, I got a true. And wherever it is less than 1, I got a false. Okay? But what if I want only those rows in my output that have the value greater than 1? So what I'm going to do is I'm going to put this conditional selection statement inside my series. So I'm going to pass it inside my original series and you can see I got the result. Okay, so all these fruits have protein greater than 1. Okay, so this is basically how conditional selection works. It is first going to provide you with a mask series, which is basically a series of boolean values true and false. And if you pass that masked series into your original series using square brackets as we just did, you get your desired output. So our next topic is logical operators. Okay. Logical operators, we have and, or, and not. So I hope you guys are clear with what is and, or, not. Okay. If you guys are not, let me just give you guys a quick example. Okay. So say I have two values. One is true, the other is also true. Now if I do a and between these, if I perform an and operator between these, my result is also going to be true. Okay. Now if I have a true and a false and I perform an and operation between these two values, my result is going to be false. Okay. Similarly, if I have a false first and a true later on and I do an AND operation, my result is going to be false. And if both my values are false, my result is again going to be false. Okay. So we need both our values to be true in order to have a result true. Okay. But in case of OR, any one of our value has to be true. This is going to be true. But if I have true or false, it is again going to be true. Okay. If I have false or false, then it is going to be false. Okay. So this is basically and or. Okay. Now let's see how it is used in a series. So say I want to give a range. Okay. I want to have all my fruits or I want to see all those fruits which are greater than 0.5 but less than 2. Okay. So all I'm going to do is S greater than 0.5 and S is less than 2. So this is the syntax that you have to follow. Okay. So you can see I got the true and false values. Now if I want to find only those rows which satisfy this condition, so you can see all these values are going to be between 0.5 and 2. Okay. I can say I can say less than or equal to 2. And now I have my fruits which have the protein value equal to 2 as well. Okay. So this is how AND is performed. So basically what happened there is wherever we had 0.5 and greater but less than 2, this range was passed to us when we use the AND operator. Okay. Now if I were to use the OR operator in this particular scenario where I'm trying to find this range, would I get this desired output? No. For the OR operator, my first condition would be greater than 0.5. So I would get all my values that are greater than 0.5. And then my second condition would be less than 2. So I would get all the values which are less than 2. That means below 0.5 as well. Alright, so as you can see over here, I have 0.3 and I have 2.6 as well in my output. So this is basically telling me that I have used an OR operation over here. Okay. So similarly, you can use and or and you can also use your not operation. So I can say I want all my values which are not greater than 1. Okay. So you can see all these values are smaller than 1. Okay. So this is how the logical operators like and, or, and not are performed. And then finally, we have a topic of modifying the series. Okay. So say instead of my calorie of mango to be 0.8, I want it to be 2.8. So what I'm going to do is, just like a normal list, I'm going to go ahead and say S mango and I'm going to say 2.8. Okay. So it's run successfully. Now if I print my series, you can see my mango protein has been changed to 2.8. Okay. So this is how you can modify your series. Okay. At any particular index, you can change the value. You can also change the index, but you will have to pass your entire index again. Okay. So this was all about series. Now we are going to move ahead with data frames. So I hope series was clear. If you guys have any doubt, comment your doubts in the chat box below. I will respond to you guys as quickly as possible. And do make sure that you guys have this particular notebook downloaded in your systems and you guys are working with me side by side. So that's going to make the entire process more fun. Okay. So far you guys have gotten a basic understanding of series and we have already covered NumPy. So I have a question for you guys. So basically I have a series and I want you to find the answer of this particular query. Okay, so if I say s dot not null and I say I want a sum of all the values that are not null, I want you guys to quickly comment the answer in the chat box and tell me what's going to be the answer in if we run this particular query. Okay. So moving on, let's look at our very next topic, that is data frame. So it is important and very interesting if you guys understand it carefully. So basically I have some data in the form of dictionary, as you can see over here. So I have some names, I have some ages, and I have some departments and salaries. Okay. And now I want to convert this particular, so if I print this data, it's going to look like this. Okay. It's not very neat and it's not very easy to understand. So what we're going to do is we're going to go ahead and convert it into a data frame. And let me just print the data frame for you. Okay. Alright, so I have this particular data set with me. So if I want to see just the starting values, I can just say df.head and say I want to see the first two rows. Okay, so I can do it using .head function. And if I want to see the last values, I can just say df.tail. Okay, so by default, the parameter over here is 5. But if we want, we can tailor it to our own needs. So I want to see the last three rows. So you can see 5, 4 and 3. Okay. So moving on, we can again use our log and ilog functions just like we did with our series. So say I want to fetch the first and second row of my data set. So what I'm going to do is I'm going to say df.ilog and I'm going to say 1 to 3. Okay. So you can see I have my first and second row and all the columns. Okay. So now in case of all these columns, what if I want only department and salary in my output? So what I'm going to do is I'm going to say df.log. So instead of ilog, I'm going to use log and I'm going to say rows 1, 2, 3 and I'm going to say I want columns age and department. So I'm going to have a comma over here to separate the columns. So you can see over here I have age and department and my 3 rows. Okay. So we discussed earlier, whenever we use the log function, our starting as well as ending indexes are going to be included. So I have 1, 2 and 3 rows instead of just 1 and 2. So if I want just the 2 rows, I have to say 1 and 2. Alright, so I hope this is clear. Okay, so we can use ilog and log in this manner. But if I wanted to include my first and second column in my ilog column itself, so you can see I have my first 2 columns in my output. Okay, so basically when we're using ilog for data frames, we have to pass our rows and our columns, and the range for these are going to be separated by a column. Okay, so we can do that using ilog and log. So we'll be using this a lot. Okay, direct indexing in a data frame gets a little complicated, so that's why we'll be only using ilog and log functions. Okay, so you can go ahead and play around a little with ilog and log and try to access different rows and different columns. So now we'll be moving to accessing only an individual column. Okay, now if I want to access just one particular column, all I can do is say df_age. So this is how I get only the age column. Okay, now if I want multiple columns, I have to add another bracket And I can simply separate my columns and say I want age and department. So you can see this is how I get my output. Okay. Now what if I want to drop this age column? Okay. So you can see I have a null value also over here. Now I want to drop this age column because I feel it's not very relevant to my data set. So how I can drop it is I will just say df dot drop and I will say age. Okay. And I will pass axis equal to 1 because I want this entire column to be gone. Okay. If I want a particular row to be gone, my axis would be 0. Okay. So it is a particular row wise operation. But if I want a column gone, I want my axis to be 1. Okay. So if I run it, now you can see my age has been disappeared from this particular output. But if I print my data frame, you can see the age is still there. Okay. So until and unless we use the parameter in place equal to true, by default in place is equal to false. Okay. So in place is basically telling us to perform the operation in the original data frame. Okay. So if we want the changes to be displayed in our original data frame, we are going to use in place equal to true. Otherwise, by default, it is going to be false and it is only going to return a new data frame and our original data frame is going to remain unchanged. Okay. So as you can see, it has been unchanged. Now this is a missing value over here, this and this. So we'll be dealing with these missing values later on. But first let's understand a few more functions. So we can go ahead and check the shape of our data set using df.shape. So this is telling us that we have 6 rows and 4 columns. Okay. 1, 2, 3 and 4. Okay. So again, the indexes are not counted as a part of a column, just like we did in series. Okay. So these are by default values over here. And we have 6 rows. Okay. So we basically have 6 samples. Okay. These are known as samples. This is the sample sets. Okay. So we can also go ahead and check the data type of our data frame. So we can also go ahead and check other information about our data set. So using info. Okay. So this is telling us that we have these particular columns: name, age, department and salary. Okay. And these are the data types in our column. So we have 2 columns having float data type and 2 columns having object data type. Okay. So name has object data type, age has float data type, department has again object data type and salary has float data type. Okay. Now over here we have a non-null count. Non-null count basically means that we have 6 non-null values, that is we have total 6 samples and all of these 6 samples are non-null. Okay. So basically in the name column we have 0 null values. Okay. And we move to the age column and over here we have 5 non-null values. That means we have 1 null value over here and over here also we have 1 null value. Whereas over here we have 0 null values. Okay. It is also displaying the memory usage to store this particular data set. Okay. And another operation that you can perform on your data set is describe your data set. So over here you get statistical information on your data. So over here we only have 2 data sets that are of type float or integer. Okay. So we can perform these particular operations, that is the count, mean, standard deviation, minimum value, and these 25%, 50%, 75% are basically the outliers in our data set. Okay. And the maximum value. Okay. So using the describe function, you get a basic information about your data, like you have 5 values in your age column and 5 values in your salary column that are present. Then the mean value of your age column is 28, whereas mean value of your salary column is 58400. Standard deviation is this. The minimum value of age is 25 and minimum salary is 50,000. Then you have other information about your data set. Okay. So in NumPy, we saw an important concept called broadcasting. Okay, we also looked at the rules for broadcasting. Now we'll see how broadcasting is performed in Pandas. Okay, so I have a salary feature over here. So our columns are also known as features. Okay, so these are our columns or our features. Okay, so if I want to say increase the salary of all the people over here, okay, of all these people, I want to increase the salary by say 5,000. All I have to do is say df salary and I will say df salary plus 5,000. Okay. Now you guys must be wondering, this is a scalar digit or an integer. whereas this is a one-dimensional array, right? If I just print df.salary, let me go ahead and print df salary. If I print this, you can see this is a one-dimensional array, right? This is basically an array having 5 rows and 1 column, right? And this over here is just a scalar value. Now I want to increase all these values by 5,000. So do you think if I perform this particular operation, I will get an error or will it successfully perform? So if you guys said it will successfully perform, you guys have understood broadcasting really well. So if I go ahead and print my salary now, so you can see it has been increased by 5,000. Okay. So what's happening over here is instead of treating this as a scalar value, it has been broadcasted to match the shape and size of this particular column. Okay. And then the operation has been performed over here. Cool. So moving on to the next concept, we have renaming columns. That is, we can rename the columns in our data. Okay. So if I want to rename a column, all I have to do is call df.rename and pass my columns. Okay. So I want my department column to be displayed as DEPT. Okay. And I'm going to say in place equal to true because I want this operation to be performed in my original data set itself. Okay. So if I go ahead and print my data, so you can see my department has been changed to DEPT. Okay, so this is how you can go ahead and rename your columns using dot rename function. So you can also go ahead and check the unique values in your data for a particular column. So I want to see all the unique salaries in my data set. So you can see over here, these are the unique salaries in my data set. Okay, I can check it for another column. So I can check the unique departments. So again, these are case sensitive. So if I check the unique departments in my data set, so I have 3 unique departments, that is HR, IT and finance. Okay. Now, if I want to see how many employees are in which department, I can go ahead and do the value count of these departments. So I will say DPT dot value counts. Now, as you can see over here, HR department has 3 counts, IT has 2 counts and finance has 1 count. Okay, so basically it's telling us that there are 3 people in HR team, 2 people in IT team and 1 in finance team. Okay, so this is how you can check the distribution of one particular column across your data set using value counts. Now, what if I want to create a new column called promoted salary? That is, I want to check the salary of all the employees after the promotion. Okay, so say some of my employees have been promoted and I want to create a promoted salary column in my data set itself. So if I want to do that, all I have to do is say df original salary, and after the promotion, their salary is going to be say multiplied by 10. Okay. So if I run this particular query and then print my data set, my data frame, so you can see the salaries have been increased in my promoted salary column. Okay. So they have been multiplied by 10. Again, this is a broadcasting rule again. Okay. So this is how you can go ahead and create a new column in your data set or your data frame. Alright, so now that we have learned how to create a new column, I think it's time to dive into data cleaning. So as you can see, we have a few null values in our data set. So I want to get rid of them because till I have those, I will not be able to perform some operations, plus it doesn't look very good. Okay. So first I'm going to check how many null values exactly I have. So all I did was I checked for my null values inside the entire data set and then I did a sum of all those values. So as you can see over here, my name column has 0 null values, my age column has 1 null value and my salary column also has 1 null value. And so does my promoted salary column. Okay. So I have a few options over here. I can either just get rid of all the rows that have these null values. Okay. So I can do that by using df.drop na. Na stands for null values. So I'm basically dropping all the null values. And if I just run this prompt, if I just run this without any sort of argument or without any sort of parameter, as you can see, I'm just left with 4 rows. Okay, so basically any row that had null value has been removed. And again, I have not used in place equal to true, so my original data set is still untouched. Okay. So this is basically just a new sort of data set that has been altered and returned so that I can see how it's going to look. All right. So by default over here, you can see my argument of how I want my null values to be deleted or dropped is any. So basically any row that has any sort of null value has been dropped. Okay. So if I run this using how equal to any, so again my result is the same. So we saw one sort of parameter in drop NA, that is how equal to any. Now the other parameter in drop NA is all. Okay. Now the other argument that drop NA takes is all. Now what this is representing over here is particular row. Okay. When we said how equal to any, we were just saying any row that had any null value. Okay. So whichever row had any null value was dropped. Now over here we are saying if all the values in a row are null, we are going to drop that row, otherwise we are not going to touch it. Okay. So we do not have any row that has all the null values. We just have this row that has two null values, but again we have three non-null values as well in this particular row. So again, none of my rows were altered and the data remains as it is. Okay. So this is one option when we are dealing with missing values. We can just get rid of those null values. Okay. The other way is to fill those missing values. Now how I can do that? So let me just find, okay, here is my null value, right? So I can either fill this null value with the most repeated value in this particular column. Okay, that is one option. Let me just write it down for you guys. Okay, so dealing with missing values is one of the most important aspects when it comes to a data set, because you will be dealing with a lot of unclean and messy data sets, and missing values is going to be one of them. Okay, so let me just write missing values. So one way of dealing with missing values is getting rid of them, which we just saw by using drop NA. Okay, and the next one is by filling them up. And for filling those missing values, we use the function fill NA. Okay, so this is the second method. Let us see how it works. Okay, so all I have to do is say df.fill_NA. Okay, and let me just run it. So I must specify a fill value or a method. Now I want to fill all the null values with say 0. So you can see this is what my data set is going to look like finally. Okay, but this is again a very noob method to perform on a data set, because I do not want my age to be 0 or my salary to be 0 just because it's missing, right? So instead what I can do is, for my age column, I am going to fill all my missing values with the mean. Okay, and I'm going to say, okay, let's not keep it in place equal to true, because I do not want to modify my original data. But if you guys want to, you guys are free to do it. Okay, so I'm just going to replace all my missing values in the age column with the mean of the age. Okay, so initially my third row had a missing value and now it has been replaced with the mean. All right. Similarly, for the salary column, what I'm going to do is, if I replace it with the mean, it's not going to be very technically or mathematically correct. So instead, what I can do is, I can replace it with the median, right? I can go ahead and replace my salary in my df column, and I'm going to say I want it to be filled with the median of my salary. So you can see over here, my fourth row was missing in my salary column, and now it has been filled with the median value. Okay, so this is another way that you can fill your missing value. Okay, now this is something that we can do mathematically, right? But what if I want to just randomly fill my value? So this was the missing value, right? So there is another method in fill NA. Instead of providing a default value, what we can do is something known as forward fill. So basically when we use fill NA, we have two methods, forward fill and backward fill. So in forward fill, what happens is we move from top to bottom, okay, and say this was our missing value. So when we use forward fill, 35 is going to be replaced in our missing value. Okay, and similarly when we do backward fill, 29 is going to be replaced for our missing value. Okay, so this is basically what forward fill and backward fill means. So let us quickly go and perform forward fill first. Dot fill na, and in our method we're just going to pass forward fill. Let's run it. So you can see 35 has been replaced in our missing value column. Okay, so it has been done using forward fill. Similarly, I can perform a backward fill. So you can see 29 has been replaced in my missing column. Okay. Now using these methods, backward fill and forward fill, can be a little tricky, and they can also give you errors in cases where your first or last value is null. Okay, so in case your first value is null and you try to do a forward fill, your first value will still remain null. Alright, and same goes for backward fill. If your last value is null and you do a backward fill, your last value will still remain null because there won't be any value before that to replace it with. Alright, so in cases like that, we go for statistical operations like mean, median, mode, alright, according to what's more technically sound. Okay, so these are some of the methods to deal with your missing values. Okay, so now we saw how we can deal with missing values. Now we'll look at another operation where we can say replace a particular value randomly. Okay, so say instead of Charlie over here, I want to replace this name with another name. So now, just because we did not use in place equal to true throughout our queries when we were dealing with our missing data, does not mean we have not already dealt with them. We have already dealt with our missing data, and currently we shouldn't have any sort of missing values in our data set. Okay, so moving on, I want to just randomly replace this particular name, say with Rose. Okay, so I want instead of Charlie, I want Rose in my name column. I just have to say df dot replace, okay, df in the name column. Okay, I have to specify the name. Sorry, I have to specify the column, and I have to say replace Charlie with Rose. Okay. So as you can see, my operation has been performed successfully. Okay. And again, if I wanted this change to be reflected in my original data set, I would have to say df name, and I would basically be storing the change in my original data set. And now I can go ahead and run it. So as you can see, I have changed the name from Charlie to Rose in my original data set as well. Okay. So this is how you can make your changes permanent. Okay. Alright, so let's look at the next concept when we're cleaning our data, that is dealing with duplicate data. Okay, so we already saw how we deal with missing values. Now we will see how we deal with duplicate values. Okay, so as you can see in this particular data set that we have over here, we have the entry Alice twice. Okay, and as you can see, the age, department salary and the promoted salary, they match for both these records. Correct? So how do we deal with duplicate values? So we already have an inbuilt duplicated function. So in order to check for all the duplicate values, all you have to do is say df.duplicated and pass it in the data frame variable. And when you run it, and your output will be your second repeated record in your data set. Right? So we are not going to consider this as duplicate. Rather, we're going to consider this as duplicate. So let's see how duplicated works. Okay, so say I have a record over here of different countries. Okay, so I have Italy, France, Greece, and then Italy again. Okay, so if I go for duplicated method, what happens is we work our way from the top itself to the bottom. Okay, so first I'm going to check for Italy. So Italy is not present. No problem. I'm going to simply add it to my list, or a list where basically I'm keeping a track whether an element is duplicate or not, right? Then comes France, so it's not there, no problem, I add it to my list. Then we come across Greece, no problem, I add it to my list. Then I come across Italy, which is already present in my list. So therefore, this element is going to be marked as duplicate. Alright. So this is basically how the duplicated method works by default. Alright. So basically we can pass a parameter called keep, and we are going to say keep first. Okay, so let's see what happens now. So you can see our first element is not going to be marked as duplicate. So this is basically by default the parameter that duplicated takes. Okay, if I say last instead of first, you can see my first element is marked as duplicate. Okay, so when we say keep last, basically we are going to work our way from bottom to up. Okay, so that's why this element is going to be marked as duplicate. All right, so I hope this is clear. So if we want to drop this duplicate value, all I have to do is, okay, so I'm not going to pass anything because I would prefer my second record to be deleted. So I'm just going to run it. So if I print my data set, you can see my duplicated record, that was the second record, has been removed or deleted from my data set. All right. Okay. So I hope the data cleaning process is clear. We have learned how to deal with missing values as well as duplicate values. Okay. All right. So let's see how we can deal with invalid values. Okay. So since I want to make the changes in my promoted salary column, I have simply written DF and promoted salary in the brackets. And now in order to do these changes in the column of a particular data set, I will be introducing you guys to a very important topic or an important function called lambda. So you guys must have studied this in Python as well, right? So all we have to do is promoted salary, and I will say apply lambda x, and I'm going to say divide that x. X is nothing but the records of my column promoted salary. So this is my input variable x and this is my output variable x divided by 10. But I have a condition: if x is greater than 6,50,000, right? Else, if it is not greater than 6,50,000, I'm simply going to return x. All right. So let me run it. Okay, so it has run successfully. I'm getting some sort of documentation, but I'm going to ignore it for now. Okay. So as you can see, the two records that I had that were greater than 6,50,000 have been divided by 10. Alright. So this is how you can deal with your invalid values using the lambda and apply function. Alright. So this is the syntax for that. So moving on, we'll also look at some string functions. So in this particular sample data set that I have taken, we do not have any sort of explicit need to do these string functions. Okay, so maximum times whenever you have a string input, okay, so say the names. Over here, I just have the first name, but in case I had a name like Alice underscore, say, Fernandez, okay. So in order to deal with inputs like this, all I would have to do was df, and I would create two separate columns saying first name and last name, okay. And then all I would do was df, and I would split my name column. So basically I'm using name as this name instead of my column name because I do not have any sort of input like this which I want to demonstrate to you guys. Okay. So even though this is not a column per se, this is just a variable that I've created, and I'm pretty sure I'm going to get an error. Okay. So I am going to split it using string dot split method. Okay. And I want to split it based on underscore. Okay, so wherever I have an underscore, I want to split my string. Okay, so in case instead of underscore all I had was a space, I could use an empty string over here. Okay, but since I have an underscore between my first string and my second string, I'm going to split it based on my underscore. Okay, and let me see if I run it, what's going to happen. Okay, so I do not have any column name, but again, this is how you would split your data set. So obviously this code is not going to run for me because I do not have any column called name, and wherever I have name, I do not have any sort of connectors between two strings. These are just single names. Alright, so I will not be able to split these particular strings over here that I have. So this is just a demo for you guys, that in case you have a column like this is how you're supposed to deal with it using string.split method. Alright. So now that we are clear with data cleaning, I want to show you guys a few more examples of apply and lambda. Okay, so because there will be instances where these methods are going to be very useful because they let you change the single entries of a column or a row, right, based on particular conditions. All right, so let me create another scenario where I want to multiply the age. Okay, I want to multiply all the ages by 2. Okay, so all I'm going to do is age, and then I'm going to call my age function age column over here, and then I'm going to say I want to apply. Now instead of passing lambda, what I can do is I can go ahead and create a function where I am multiplying my age. Okay, I'm going to have my input as x, and then I'm going to simply return x into 2. Okay, so instead of calling lambda over here, what I can do is I can say multiplying age and pass x. Okay, so it will not take any input. I'm sorry about that. So let me run it. Okay, so now if I print my data frame, you can see my values of age have been multiplied by 2. Okay, so let me bring back my ages to the original value. Now this time I will use lambda instead of creating a function by default. Okay, and I'm going to say apply, and I'm going to pass lambda, and I will say x, and I will say x divide by 2. Okay, now there are no conditions, there are no if else conditions. I want all of these entries in the age column to be divided by 2, so I'm not going to pass any if else like we did previously, right? So I'm going to run it, and if I print my data frame, my ages are back to the original values. Okay, so this is how lambda and apply functions are used, and you will be using them quite a lot. Okay, so moving on, I want to tell you guys about another very important concept, that is joins and merges. Okay, now in order to understand joins, let us go through a quick overview of what are joins. Okay, so consider this scenario where I have two data sets, A and B. Okay, now when you're dealing with large data sets, it's not necessarily that you're going to have all the columns in one particular data set. Okay, so if you guys remember, I showed you guys an Excel sheet of various columns or various features of a house, right? Number of balconies, number of bedrooms, the location, the state, and so on, right? Now I had all those columns in one particular sheet. But what if I had two sheets, A and B, where in one sheet I only had, say, the features of the house, that is, the number of bedrooms, the number of bathrooms, the balconies, and in another sheet I had the different features, say when the house was built, where it's located, what's there nearby, and stuff like that. Okay, so I had two separate sheets. Now I want to combine these sheets. All right, so there are different methods. So if we talk about joins, there is left join, right join, outer join, and inner join. Okay, these are the joins that exist. And another method is to merge. Okay, merge is similar to inner join. All right, so let's quickly see what left join would look like. So if we were to combine these two data sets on, say, a particular property, and we perform a left join, our left side of the data set, okay, whatever there is common between the two data sets is going to be ignored. Whatever exists in only data set B is going to be ignored. Rather, we are going to have something that is solely available with data set A, and this happens in left join. Okay, similarly in right join it happens the opposite way. We're going to have only the properties of B in our data set. Okay, and when we perform a full outer join, we're going to have everything of A and B. Okay, so each and everything that we have in A and B is going to be included in our outer data set, sorry, outer join. And when we perform an inner join, it basically happens over here. Okay, only the common properties between A and B. And when we merge two data sets, we merge them based on this particular common column, and whatever properties A and B have, both are visible in our merged data set. Okay, so let me say this is another data set. So let me just convert it into a data frame. So I'm going to call it df2, and I will say pd dot data frame, and I will pass my department. Okay, So let me just print my other data frame. So as you can see, this is my second data set. So now if I want to combine the information from this data set and the data set that I had earlier, I have something known as concat. Okay, so concat is going to let me merge the information from both these data sets. So if I use pd.concat and pass the two data sets that I have, this is the output that I'm going to get. Okay, so since in our second data set we have a location and manager, but we do not know which employees have this location and this manager, we have a null over here. Okay, so by default both my data sets are being combined in a horizontal manner, that is they are being stacked horizontally, right? So wherever I don't have the names, I am getting null, and wherever I don't have the location and manager information, I'm getting a null. Okay, but if I were to do the same operation column wise, that is, if I were to combine these two data sets in this particular direction, I would have to say pd.concat, pass my two data sets df and df2, and I would say I want it to be joined on axis 1. So as you can see over here, wherever I have department HR, my location and manager is for the department HR, right? So this is how you can combine or merge two data sets using pd.concat. Okay, there is another function called pd.merge. Okay, so you can pass your data sets df, df2, and I want it to be merged on my column department because that is the common column. So as you can see over here, my department is being repeated twice. But if I do not want that to happen, I can use merge, and as you can see over here, my department column appears only once and my data is managed accordingly. So wherever I have HR department, I'm going to have my location as New York and manager is going to be Laura. Okay, it is, you can see it over here as well, New York and Laura. All right, so this is also how you can merge or combine your two data sets into one. Okay. So these were basically all the operations that were there to know on data sets. The basic operations, obviously, as you go down the line, you deal with bigger data sets, your operations get more complex, but this is the standard basic base that you require to get started with Pandas. Alright, so now we're going to look at how we can import a complete data set file, that is an Excel or a CSV file, in our notebook. So since I'm using a Google Colab notebook, I cannot directly pass the entire path of my file or my CSV or Excel sheet. If you're using Anaconda or VS Code, you can do that. So if you're using those platforms, all you have to do is right click on your data set and click on copy as path and create a variable and just say pd.read underscore CSV because this is a CSV file, and all you have to do is pass the path inside the parenthesis as an argument. Alright, but since this is a virtual environment and it is not going to be able to access my local environment, what I have to do is I have to upload my data on Google Colab. Okay, so I'm simply going to select it. So as you can see, it's uploaded over here. Okay, so now all I have to do is, in quotes, I have to say data.csv. So you can see it's run successfully, and now I can do data.head. That is, I'm trying to get the first 5 rows of my data set. So you can see this is the date, price, bedrooms, bathrooms. So I can easily access all the columns, and I can go ahead and perform the basic operations like I can check the shape of my data set using data.shape. So I have 4600 rows and 18 columns. All right. So accessing such information in an Excel sheet would have been a much more difficult task. So this is why we use Pandas, which helps us gather information like this in a much more efficient and easy manner. All right. So I can also go ahead and check the information of my data using data.info. So you can see I have 4600 non-null values. That means I have 0 null values in my entire data set. I have 0 null values. Okay. So you can also check the data type of each and every column. Now you can see over here, this is an object data type, but date is supposed to be in a time format, right? You're supposed to be able to access the day, time, and year of a particular date in an efficient manner, but this is stored in an object manner. All right. So I'm just going to quickly show you guys how you can convert this date time from an object to a time. Okay, so this is the syntax that you have to follow. So I'm going to pass my date, and then I'm going to use pt.datetime to convert my date from object to, okay, so it is data. Okay, so as you can see, it has been executed successfully. Now if I go ahead and check my information of the data, you can see it is converted to date time format. All right, so this is how you can convert your date time features into the valid format using pandas. All right, so this is again only a one line code, but you should be aware that it can be done, and this is how you bring your data to the correct format. All right, I think we have covered almost everything there is to know about pandas, and I'm sure you guys got a basic understanding of how you guys can implement pandas on even a large data set. And I am going to give you guys this notebook link in the description, so you can go ahead and download it and practice on this data set, or you can download data sets from Kaggle. Let me show you guys the website. So you can go ahead and type Kaggle and click on the first link that you get. Register on this website and you get hundreds and thousands of data sets for absolutely free. You can download them, and you can also go ahead and check out the discussions if you face any issues or doubt, right? So get started with your pandas journey right away. In this section, I'm going to walk you through the basics of visualizing data using one of the most popular Python libraries out there, Matplotlib. And something important that I'll be discussing, which is often neglected while learning Matplotlib, is how to choose the right type of graph based on the kind of data you have. Not just that, we will also see how to read these plots and make sense out of them. But before we jump into it, let's take a moment to understand what data visualization actually means and why it matters. Data visualization is all about turning raw data into visuals using things like charts, graphs, or maps. These visuals help us quickly see patterns, spot anything unusual, and just get a better sense of what the data is telling us. Here's a quick example. Let's say you have a list of sales numbers for each month of the year. Sure, you could look at those numbers one by one, but if you plot them on a line chart, you'll instantly see how sales went up or down over time. That's the beauty of data visualization. It helps make data clear, simple, and easy to understand. Now coming back to Matplotlib, this is a Python library built specifically for creating visualizations. It's been around for a long time and is widely used in areas like data science, research engineering, statistics, and business management. What makes Matplotlib so powerful is its flexibility. You can create all kinds of plots like line charts, bar graphs, scatter plots, histograms, pie charts, and even 3D plots. And the best part is you can fully customize how your plots look, from colors and styles to labels, titles, and legends. When it comes to using Matplotlib, there are two main ways to make your plots. The first one is through something called the PyPlot API. This is the simpler and more commonly used method. You just import it using import matplotlib.pyplot as PLT, and then use functions like plt.plot or plt.bar to make your charts. The second way is through the object-oriented API. This one gives you more control and is better suited for complex or customized visualizations, especially when you're building something that needs to be more advanced or integrated into an application. In this tutorial, we are going to explore both methods using easy examples. So go ahead and open your Jupyter Notebook or Google Colab, and let's get started with Matplotlib and the world of data visualization. So before we get started with the implementation of Matplotlib, I want to quickly show you guys the anatomy of a Matplotlib figure. So a figure in Matplotlib is basically the entire window or page. It's basically the entire canvas that represents the various components like legends, your axes, the grids, your labels, everything, right? So all the components are contained inside a figure. So let us quickly go ahead and see what are these different components. So first we have the axis. So we have x-axis and the y-axis, and what these axes are representing is basically shown by the labels. So we have x-axis label and y-axis label. So say for example, I have the data of number of hours studied versus the marks scored. So I can represent my x-axis as the number of hours studied, and I can label it as number of hours studied, and similarly I can do it for y-axis label as the marks scored. So I know what I am showing on my plot. Then there's something known as ticks. So we have major ticks and minor tick labels. So major tick labels are basically these marks that you can see on your axis. So 0, 1, 2, 3, 4 are basically your major tick labels, and your minor tick labels are the in-between marks like 0.25, 0.5 and so on. And then we have something known as a legend. So this basically represents what each color or mark is representing. Right, so over here we have a blue line and a red line. So whatever these blue lines and red lines are representing, that can be shown in a legend. Then you have your grids. So these are the dotted lines that help you figure out or read your plots in a more efficient manner. Then you can also label your entire figure. So you can give a title to your figure using the title component. So that is pretty much it about a figure. So these are basically the major components inside your figure. As we go ahead, we will see how to tweak these different components according to how we want our figure to look like. Alright, so in order to get started, I want you guys to quickly open any terminal and just run the command pip install matplotlib. And once you run it, you will see a few lines of code run over here for you. And finally, when you get the message requirement satisfied, that means your library is installed successfully. Now, once your library is installed, you can go ahead and import it in any environment that you like. I'm using Google Colab. You can use VS Code or Jupyter Notebook, right? According to your preference. So I'm going to go ahead and import my matplotlib if I run it. So it's imported successfully. So along with my matplotlib, I'm also going to import pandas. And if I run it, so both my libraries are imported successfully. So just to give you guys a basic gist of what Matplotlib does, I'm just going to create two variables for you guys. So I have my variable x as 1, 2, 3 and my variable y as 4, 5 and 6. Okay, so these are my x and y variables. Now, in order to plot these variables using Matplotlib, all I have to do is say plt.plot, pass my variables x, y and just say plt.show. And as you can see over here, this is what Matplotlib gives me. So over here, what Matplotlib is trying to do is, it is trying to plot my data like this. So 1, 4, then I have 2, 5, and then I have 3, 6. Okay, so these are the variables that I passed, and this is the data that Matplotlib is trying to plot over here. Okay, so if you go ahead and see 1, 4, 2, 5, and 3, 6. So if I want those dotted grid lines that we initially discussed in our figure, all I have to do is say plt dot grid and run it. So now you can see I have my grid lines. Now it gets much easier to read my data in a more efficient manner. Now I can easily spot that this particular dot represents 2, 5 and this particular spot represents 1.75, 4.75. So now you're easily able to figure out what each of these points on this particular line represent. Right? So this is basically the major idea or the major implementation of Matplotlib. Now using this functionality of Matplotlib, we are going to try and plot different kind of plots for different data sets. So as we discussed earlier, Matplotlib has two types of plotting. So one is using the PyPlot API and one is using object-oriented API. So first we're going to cover the PyPlot API. So let me just write it down that we are only going to discuss PyPlot API right now. In the end of the video, I'm going to discuss how you can use object-oriented API as well. Okay. So in order to understand which particular plot is to be used for what kind of data, let me quickly introduce you guys to univariate analysis. So a univariate variable basically focuses on one variable at a time. It could be a height, weight, or a category like yes or no. Alright, so first we're going to cover the numerical column. So in order to understand, let me just create a data where I have a column, salary, and it looks something like this. Okay, so this is my salary column and this is just a dictionary and I have to convert it into a data frame. So I'm going to call my data set df and I'm going to say pd dot data frame and I'm simply going to pass my data. Now if I try and print the first 5 records of my data set, this is what it's going to look like. Okay, so this is my salary column and these are my records. Let me also go ahead and check the total number of records in my data. So all I have to do is say df.shape And if I run it, so I have 20 records and I have only one column. So over here I have 20 comma 1. Alright. So now in order to visualize this particular column in my data frame, the first plot that I have is a line plot that we have already seen, but now we're going to see it in much more detail. So in order to plot a line plot, all I have to do is plt.plot, and in my parentheses, I just have to pass my column inside my df variable, that is my data frame, like this. So if I run it, so this is basically how my salary column is varying. Okay. So at some point it is really high, that is the highest salary is going to 55,000, whereas the lowest salary is somewhere around 25,000. Okay. Now what I can do is I can also go ahead and make some changes in my plot. Like I can say I want my color to be red and I want my grids to be shown, and I can also have my markers. So I can have my marker as letter O. Now what this marker is going to do is wherever I have a data point, it is going to be marked. So for example, over here, basically wherever I have a data point, it's going to be marked with the letter O. I can also go ahead and change the line width. Let me just run it. So as you can see, my color has been changed to red. I have grids in my plot and my marker is being represented with a dot over here, as you can see. Now instead of a straight line, I can change my line style to a dashed line like this. So now you can see my line is a dashed line, or I can also change it to a dot using the colon. So now you can see my line has been dotted. I can also go ahead and change the width of my line using the line width parameter, and I can say I want it to be 2. Okay, so as you can see, the width has been increased. So if in case I want my marker to be represented with a star, all I have to do is pass this particular symbol and you can see the marker style has been changed. Okay, so you can go ahead and play around a little with the parameters that are available in Matplotlib. Again, Seaborn offers a bit more functionality compared to Matplotlib, but this is great when you want to deal with your plots at a lower level. Okay. Then the next way we can visualize our column is through a histogram. So in order to plot a histogram, all you have to do is say plt.hist and pass your column in the parenthesis. And for now, I'm going to exclude the bins parameter and just show you guys how the salary column is going to look like in a histogram. Alright, so histogram basically tells us the frequency of our data distribution. So what this graph is basically telling us is that there are around 3 people that have the salary in the range 25,000 to 30,000. Then 2 people have the salary in the range 30,000 to 35,000. And there are 3 people again in 35 to 40 range. Okay, so this is basically how our data is being distributed. Now, in order to make it more clear, I can go ahead and pass bins, and I'm going to, no, I don't want grids for this particular graph, and I'm going to say my color is going to be green. So now I have divided my plot in 5 bins. So now it's more clear and more readable. Okay, so I have 6 people earning 25,000, then 5 people earning 30,000, then 3 people earning 35,000, and so on. Okay, so this is how you can read your data through a histogram. Then the next plot that we have is a box plot. So in order to plot a box plot, all you have to do is say plt.boxplot and pass your column over here and simply say plt.show, and this is what your box plot is going to look like. Okay, so whoever is not clear with what a box plot is exactly, let us quickly understand it with the help of this image. So a box plot has 2 endpoints. One represents the minimum value and one represents the maximum value. Then there's a line that is connecting the minimum value to the lower quartile, and it's called the whisker. Now your lower quartile is known as Q1, which basically represents 25 percentile. So basically 25% of the data is below this particular point. Okay, then you have your mean value and your median. Median is also known as Q2 and it's the 50th percentile. This represents 50% of the data is below this particular point. Then you have Q3, which is 75 percentile. So 75% of the data is below this particular point, and then you have your maximum value. Okay, so Q1 to Q3 is known as your interquartile range. And then you have something known as outliers. Now outliers are basically the extreme values that are either lower than the minimum value or greater than the maximum value. Okay, so these are basically the extreme values and they are plotted outside the box plot. So Box plot makes it very easier to identify whether there are any outliers in your data or not. Okay, so as we can see in this particular plot over here, there are no outliers currently. But if I were to add a salary, so at index 20, I'm basically adding a salary 0. Okay, now if I run it, now I go ahead and plot a box plot. You can see over here, I got an outlier value which is at 0. So this is the value I just inserted, as you can see over here, through df.loc. So we have already covered LOC and ilog in my previous video of Pandas full course. If you guys have not watched it or you guys do not understand how I have added a new record in my dataset, I suggest you guys to quickly go ahead and watch that video before you continue with this video, because we will be using Pandas somewhere or the other throughout this video. Alright, so as you can see, I've got my outlier value over here, which is really far away from my entire box plot. So it's suggesting that whatever range my other salaries are in, this particular salary does not match that range. Okay, so I can simply go ahead and remove this value from my dataset in order to avoid any bias in my entire calculation when I'm going ahead with prediction models and all. Okay, so I'm just going to go ahead and remove this value. Okay, so I'm back to my original data set. Now this was all about when you have a single numerical column. Alright, so salary was something that contained all numerical values. But what if I had a column that had all categorical values? So now we're going to deal with a univariate categorical column. Okay, so in order to deal with a categorical column, let me just quickly go ahead and add another column to my data set called department. So now let me go ahead and check my data frame, what it looks like. So as you can see over here, I have a salary column and a department column, and my department column is a categorical column. I can also go ahead and check that using the info parameter. So you can see this is of type integer and this is of type object. So basically all of the data that I have in my department column is of type string. Alright, now if I want to visualize this particular column, I cannot use a line chart or a histogram or even a box plot, because those are used for a numerical column. So in order to visualize this column, I'm going to use something known as a pie chart. Now in order to plot a pie chart, what I have to do is I have to create a count variable where I am simply going to count the number of unique values in my department. So this is what it's going to look like. So I have 8 HR departments, 6 IT and 6 finance departments. Okay. Now I can go ahead and plot this data in my pie chart using plt.py. Simply pass my count variable, and if I print plt.show, this is what it looks like. Now over here, I do not know what these different colors are representing. So in order to have that on my pie chart, all I have to do is say labels equal to count dot index, and if I print it now, you can see the green color represents my finance, blue represents HR, and orange represents IT. But again, another issue is I do not know the values of these sectors. So in order to get my values printed in my pie chart, all I have to do is say auto PCT and pass 1.1% 1.1 F. So you can see I have 40% HR, 30% IT and 30% finance. Okay. So the format I've given over here basically represents that I want one decimal. If I were to pass 1.0, I would get only my integer parts over here. If I were to say 1.2, you can see I got 2 decimal values in each of my sectors. Okay. And another important parameter in pie chart is explode. So the explode feature basically helps us decide if we want to separate any particular section in our pie chart. So let me just show you guys. So I can simply say 0, 0.1 and 0. If I do that, so you can see IT, which is my second sector over here, has been separated from my entire pie chart by 0.1 distance. Okay, I can do that for 2 sectors at a time also. I can say I want this to be separated by 0.2, the last sector finance. So this is what my pie chart looks like now. Okay, now if you feel that your pie chart is not a complete circle, it's not a proper circle, you can quickly go ahead and say axis and pass equal in the parenthesis, and that will make your pie chart in a complete circle. Okay, so this was one way of visualizing a categorical column. The other one is known as count plot. So in order to do a count plot, all you have to do is say plt.bar and pass your count.index and count variable and simply say plt.show, and now you can see your different sectors represented as a bar chart. Okay, you can easily understand that HR has 8 values, basically 8 people working in HR, 6 people working in IT, and again 6 people working in finance. You can also go ahead and change the color of your bars. You can make it, so if I want different colors for different bars, so I can go ahead and say green, black, red. So you can see I have different colors for my different bars. Okay. So this was all about univariate analysis. That is when we had to deal with only one column. Either it was just a numerical column or just a categorical column. But what if we had two columns at a time? That brings us to our next type of analysis, that is bivariate analysis. And over here, we basically try to analyze the relationship between two features or two columns. So first we're going to look at two numerical columns. Okay. So right now, if I check my data set, I have one numerical column and one categorical column, right? So in order to perform numerical analysis, I should have another numerical column. So let me just go ahead and create a new column. I'm going to call it age, and okay, so this is my new column called age. And if I go ahead and check my data frame now, so you can see I have 3 columns, 2 are numerical columns and 1 is a categorical column. Alright. So now if I want to visualize salary and age column together, the first plot that I have is known as a scatter plot. So a scatter plot is basically going to help us analyze the direct relationship whether salary increases with age or not. Okay, so if you want to check that, all we have to do is say plt.scatter and pass my age column, my salary column, and I'm going to give the color orange, and I'm simply going to say plt.show. So as you can see over here, my age and salary are increasing together. Okay, so this is also known as a positive correlation. Alright, so when my age is around 20 to 25, my salary is somewhere around 25,000 to 30,000. But as my age increases, so when I reach the age of 40, my salary is somewhere around 55,000. Okay, so this is how you can analyze the relationship between two numerical columns. And the next way of visualizing two columns is again by using a line plot. So as we saw in our initial example, we had two features X and Y. So right now we have two features called age and salary. So I'm going to go ahead and plot my line graph over here. So as you can see, my line graph is not very easy to visualize over here. You can see the lines are very random. So instead of line style as dotted, I'm going to have my simple and plain line style. So as you can see, it's going back and forth a lot. So why is this happening? Because my age column is not sorted over here. So I have random age values and random salary values. So in order to have a better visualization, what I'm going to do is I'm going to sort my age feature. I'm going to create a variable called sort age, and I'm going to simply sort my values of age. Okay, and over here, instead of passing my age directly, I'm going to pass my sorted age. So as you can see over here, now my line chart is giving me a better visualization of the relationship between the age column and the salary column. Okay, so this is how you can plot a line chart between two numerical columns. Then the next visualization graph that we have is a bar chart. So in order to plot a bar chart, all you have to do is say plt.bar, pass your age. I'm going to pass my sorted age features and my salary column, and I'm going to say I want my color to be green for all the bars. And as you can see over here, it is giving you the visual representation in forms of bars. Okay, so at the age of 22, I have my salary in this range. At the age of 25, I have the salary at this range. So I can also go ahead and create bins. So I want only 10 bars to classify my age. So I can also go ahead and align my bars, and I can say I want my bars to be in center. So if I run it, So they were initially like this. Now if I say I want them to be left, so align supports center or edge parameters. Okay, so this is how you visualize two numerical columns, but what if you had a numerical and a categorical column to visualize? So let me go ahead and show you guys bivariate analysis, but with a numerical and a categorical. So I'm going to consider my salary feature and my department feature, and now I want to see the visualization of how my salary is distributed according to my department. Okay, so what I'm going to do is I'm going to create my feature called HR salaries, and here I'm going to fetch all my salaries that have the department of HR. So basically my HR salary variable is going to contain the salaries of only the HR department. So basically, these are the people working in the HR department and these are their salaries. Okay. Similarly, I'm going to do that for the other two departments as well. So I'm going to create IT salary, and similarly, I'm going to create finance salary. Okay. So once I have my salaries for all the three departments separately, I can go ahead and plot them in a box plot. So I'm going to go ahead and create a box plot. So in order to do that, all I have to do is say plt.boxplot and pass all the three salaries that I have together. And you can see the distribution like this. Okay, so I have one salary that is an outlier, that is 55,000, which is okay. So I need to also go ahead and label them. So I'm going to say label, and I'm also going to show the legend for my plots. So if I plot this, you can see I have three box plots, and over here you can see I have an outlier value for my first box plot, but in this particular figure, I'm unable to understand which box plot is referring to which department. So in order to clarify that, I can go ahead and say I want my labels to be HR, IT, and finance. So if I run it now, you can see my first box plot represents the HR department, and I have an outlier value in the HR department. Okay, so this is how you can analyze a numerical column with a categorical column using box plots. Okay, you can also check their median values. So the median HR salary is in the range of 25,000 to 30,000, whereas IT median salary is 35,000, and finance has the highest median salary, that is 40,000. So this is how it gets much easier to visualize data using plots in Matplotlib, right? If you were to find out such insights just looking at the data, it would take you much longer, right? But using graphs like this, I can easily figure out which department has uh, a higher median salary, or the maximum salary, or the outlier lies in which department, right? So box plot was one way. Another way where you can visualize your numerical and categorical column together is pie chart. So in order to plot my pie chart, what I'm going to do is I'm going to sort, or I'm going to group my salary by department, and I'm going to say df dot group by department, and I want my salary to be grouped, and I'm going to use the sum instead of mean. So this is what it looks like. So I have a total of this number for my finance department. So basically all the people in finance together are earning this much salary, whereas all the people in HR are earning this amount, and in IT they're earning this amount. Okay, so now I can go ahead and plot it in a pie chart. I can say plt.pie, and I can give my salary by department variable, and I can call my labels as the index, and I'm going to label them using auto PCT. And once I print my pie chart, so in my pie chart I can easily see the distribution of salary in percentage for the three different departments. Okay, so this is another way of visualizing. So in my box plot, I could easily figure out the minimum salary, the maximum salary, and the median salaries for all the departments. And over here, I can see the distribution or the percentage for each department, that is the total amount being earned by each department. Okay, so another way when you can visualize your numerical and categorical column is by using a bar plot. So I want to show the mean salaries of all the departments in my bars. So what I'm going to do is I'm going to say HR mean, and I'm simply going to say sum of HR salary and I'm going to divide it by the length of HR. And similarly, I'm going to do it for IT and finance as well. So once I run it, I can simply go ahead and plot my bar chart over here. I'm going to say plt.bar and I'm going to pass my HR, IT and finance as labels. And I'm going to pass these as variables as well. And I'm going to say I want my bars to be of color green, black and red. And once I print my chart, this is what it's going to look like. Okay. So in my bar chart over here, I can easily see the mean or the average salary for the three departments in a very clean and neat manner, right? So my HR mean salary is somewhere around 35,000, whereas IT is a little more and finance is almost crossing 40,000. Let me just use my grids over here. So you can see now you get a better visualization of the mean or the average salary for the three departments. Okay, so this is going to further help you in analysis where you are building large predictive models. Right now I just have 3 columns and the values are really small, so I could even look at the data. But when you have a larger number of columns and larger values, visualizing your data becomes a much more easier or you can say efficient way to understand what the data is trying to tell you, right? So with this we finish our bivariate analysis. Next comes our multivariate analysis. So basically this is where we're trying to understand how the 3 columns affect each other and how they change with each other, right? So first we're going to look at three numerical columns, that is numerical, numerical, numerical. So I'm just going to write 3 numerical columns. So in order to have 3 numerical columns, right now I just have 2 in my data set. Let me just check. Yeah, so I have 2 numerical columns, that is salary and age. I need to add another numerical column in my data frame. So let me just say DF and let me add experience. Okay, so you can see I have added another numerical column, that is experience. So basically this column is telling us how many years of experience the person has. So over here there's 1 year of experience, here over here the person has 2 years of experience and so on. Okay. Also another thing that I missed over here is a few parameters in pie chart. So over here there's something known as shadow. So if you want to give these effects to your pie chart, you can simply say shadow equal to true, and over here you can see a shadow like structure has been created below your pie chart. Okay, so it kind of gives your image a 3D effect, right? And you can also go ahead and say explode and pass a list of the distance that you want your each sectors to be away from the radius. So I'm going to say 0.1, 0 and 0.1. So basically this makes your pie chart look a little more interactive and different from the normal images that are out there. So you can go ahead and customize it. Okay. Alright, so moving on with our multivariate analysis. So I have 3 numerical columns as you can see over here. So now in order to analyze these 3 columns together, I'm going to use something known as a bubble plot. Okay. So a bubble plot is nothing but a scatter plot where your third numerical column, so in this case we're going to use experience as our third numerical column, and this experience column is just going to define the bubble size. Okay, so with that you get an idea of how much experience the person has. So basically the larger your bubble, the more the experience the person has. Okay, so let me go ahead and quickly create this plot for you guys. So I'm going to say plt.scatter. So basically I've passed my age column, my salary column and my experience column as the size of my bubble, and I'm saying I want orange bubbles. And if I print this, okay, so as you can see the size of my bubble by default is very small. So basically the smallest bubble is representing 1 year of experience and the largest bubble is probably representing 5 years of experience. But in order to have a better visualization, what I'm going to do is I'm going to multiply this by 20. Okay, so now you can see the bubble size has increased and now it's much more easier to visualize this particular graph than earlier. I can also go ahead and increase the number of multiplication. Okay, and I'm going to give the color blue because That would give a better bubble effect. So this is what my bubble plot is going to look like when I have three numerical columns. Okay, so you can go ahead and easily visualize that person of age 27 is earning around 35,000, and again the experience is also good, right? So I'm simply going to give the color as sky blue, and I can also go ahead and customize it as edge color. So I'm going to give my edge color as black so that I have a better understanding of my bubbles on it. So see, this is what my bubble plot is going to look like. Again, I can give a title to my plot. I can say plt.title, age versus salary versus experience, and my X label is going to be age, my Y label is going to be salary, and I do not need a grid. So now you can see my plot looks much neater and easier to read, right? So this was when we had three numerical columns. But what if we had two numerical and one categorical column? So in this case, we are going to again use a scatter plot. So the two numerical columns are going to be our age and salary, and our categorical column is going to be the department column. Now, in order to plot this on a scatter plot, instead of using a bubble plot, we're going to use a scatter plot again. But for the different departments in our department column, we are going to use different colors. Okay, so what I'm going to do is I'm going to say plt.scatter, and I'm going to pass my age column, my salary column, and I'm going to say I want my colors to be of the different departments, that is DF department, and I'm going to say I want the colors of a rainbow. So I want different colors in a rainbow, okay? Or if I didn't want rainbow, I'm going to show you guys how I can customize the colors in my own way. So I'm going to say X label, and my X is going to be age, then Y label, plt.x label, and plt.y label. My Y label is going to be salary, and I'm going to give a title to my plot, and I'm also going to print my legend. Okay, so I cannot use a rainbow color. Rather, what I'm going to do is I'm going to say df.map, and I'm going to map the different departments. So if I have an HR department, I'm going to map it with, say, color yellow, and similarly, I'm going to map my other two departments as well. So I'm going to say IT, I want to be mapped to color blue. And finally, I have finance, say orange. Print it now. So as you can see over here, I've tried to print my legend, but I am not really getting an output. So I can resolve this by simply saying labels equal to df department. So as you can see over here, I have tried to print my legend using plt.legend, but I am not really getting any output for that particular line. So the reason being, I have explicitly defined what colors each of my departments are going to get, and Matplotlib is unable to read that. So I have to explicitly define the labels using label, and I'm going to say HR, IT, and finance. So if I print it now, so as you can see over here, even though we've passed the plt.legend parameter, our legend is not getting printed. So the reason is because we have explicitly defined the colors over here, and even if we try to get the label parameter as df department, so you can see it is not going to work for us. So we cannot use this particular strategy. Rather, we have to follow a different kind of format over here where we explicitly define our color using a variable. So I'm going to say my HR is going to be linked with yellow, IT is going to be with blue, finance is going to be with orange. Okay, now I'm going to iterate through each of my color and my department. So I'm going to say for DPT and color in color.items, and basically I'm going to classify each of the departments separately, and then I'm going to print my scatter plot of age and salary. I'm going to say my color is going to be the specific color for each department, and I'm going to label my department. And if I run this and I go ahead and print my legend, So now you can see I've got my legend successfully, because now Matplotlib knows which department is representing which color. Alright, so that is why it is able to generate a legend successfully. Earlier in this case, Matplotlib had no idea about it. So this is how you can create a legend when you're plotting two numerical and one categorical column in a scatter plot. Alright, so that was all about our PyPlot API plotting for a single numerical column, a single categorical column, then two numerical columns versus a numerical and a categorical column. Then we went ahead and saw multivariate plotting, and we did all that using the PyPlot API. That is, we directly went ahead and used terms like plt.bar, plt.boxplot, and so on. Now we're going to dive into object-oriented API. That is, we're going to create objects before we start plotting. Okay, so let me just comment it over here. So object-oriented API basically allows subplots or multiple axes or multiple plots in a particular figure. Okay, so till now we saw one particular plot in one figure, but now what we can do is we can have multiple plots and subplots in a single figure. Okay, so let's quickly see how. So first I'm going to create two objects called figure and axis, and I'm going to say plt.subplots, and I'm going to pass 1 comma 3, and I'm going to say my figure size is going to be 10 comma 5. Okay, so this is basically the x and y ratio. So in terms of x, I'm going to have the figure horizontally expanded and vertically just 5. Okay, so basically what I'm telling my subplot parameter is that I want one figure, and in that one figure I want three subplots. Okay, so now let's go ahead and create our first plot. So I want my first plot to be a line plot. Okay, so as you can see over here, this is one complete figure and I have three subplots. Right now all these three plots are empty. Okay, so I'm going to go ahead and create my line plot first. So in order to do that, I'm going to use my sort age variable. Let me see if I still have it. Yes. Okay. So I'm going to use my sort age variable. So I'm going to say at my axis 0, that is my 0th x axis, I want to plot a line plot, and it is going to be sort age, pass my age and salary, and I want my color to be red, my marker to be a star, and my line width to be 2. Okay, I can also go ahead and define my marker size. So I'm going to say marker size equal to 2. So I can go ahead and set the grid. I can also set my title for this particular plot. I'm going to say it's a line plot, and I can also go ahead and set my x label and my y label for this. So I'm going to say dot set x label, and I'm going to call it age, and y label is going to be my salary, and then I'm just going to run it. Okay, so since I've not called my plot till now, it's not being generated. Now I'm going to go ahead and plot my histogram. Ideally all this should be run in a single cell, so I'm just going to paste it in my cell over here, and then I'm going to plot my histogram. And over here my axis is going to be 1, so that Matplotlib understands that this was my first plot, and I'm going to use axis 1 over here throughout histogram, so that Matplotlib understands that this is the second figure, while the earlier where I use 0 for axis is going to be my first figure. Alright, so basically I'm referencing to my first figure and my second figure over here. So I've created a histogram for my salary, and I'm going to give the color sky blue. And I'm going to set my title for histogram, and I'm going to set my label salary, and y label is going to be frequency. Then my third plot is going to be a box plot, where I'm going to say axis 2, that means my third figure, and I'm going to plot my salary over here. I'm going to set my title as box plot, and I'm setting my x label as salary again. And if I run plt.show, that is I print all my plots, this is what it's going to look like. So as you can see over here, my plot is sort of coinciding with my second plot. So I can go ahead and increase my x-axis direction. So I can say 15,5. Now you can see it's fitting perfectly. Okay, so you can go ahead and adjust the dimensions for your plots, that is your figure size. Okay, so this is how you plot multiple plots together, okay, in using object-oriented API. Cool. Now, if I want to save this particular figure in my local environment, maybe I want to use it for some sort of presentation or any sort of document that I'm preparing, and I want to use this figure in that, how do I do that? Okay, so you can either just right click and go to copy image, but that's not the right way. So Matplotlib offers an inbuilt feature where you can save your image. So all you have to do is say plt.save fig and give a name to your image. So I'm just going to say multiple plots. And now you can use any particular extension. So I'm going to use PNG. You can use the JPG format, or you can use the PDF format. Okay, any format that you want to download your image in, you can just use that particular extension in the end using the dot. So whichever image I need to save, I just need to run this particular line before the plt.show. And if I run this, so let me see if my image has been saved. So as you can see over here, multiple plots.png has been saved in my drives. So since I'm using Google Colab, it is unable to access my local environment, and hence my image is saved only in my drive, that is my disk space over here. If you're using VS Code or any other notebook like Jupyter Notebook, you can specify the path that you want your image to be saved in. Okay, so you can directly go and say, I want it to be stored in my C drive. Okay, so you can use a path like this so that your image is stored in that particular folder. And I can also go ahead and download it from here. So this is how you save an image. I can also save it in, okay, let me just go ahead and, so if I click on this is what my image is going to look like. Okay. Now, before we wrap up with our 3D plots, I want to show you guys another interesting scenario where we have a data somewhat like this. Okay, so basically I have multiple numerical columns. Now, if I want to visualize all these particular metrics over here, like the sales and profit and expenses all together in one chart with reference to the year column, this is how I can do it. So first I'm going to convert it into a data frame. I'm going to call it df2. This also ideally should be data2 because I already have data variable initially. Okay. So in order to do multiple plots, all I have to do is say plt.plot and pass my year as my x variable. So this is going to be fixed throughout. All my x variables are going to have the column year because I want all these particular metrics to be represented with reference to year, but in a single plot. Okay, so this is how I'm going to do it. So I do year and let me plot sales, and I'm going to label it as sales. So similarly, I'm going to do it for profit and expenses column as well. Okay, and I'm going to label it as profit and expenses. So if I give my plot a title, financial analysis, and I'm going to label my X label as year and Y label as the amount. So now my Y label, that is the amount, is going to vary according to sales, profit and expenses. Okay, so if I run this, okay, so as you can see over here, I have my profit, my expenses and my sales. Now how do I know which line is representing what? I can see it through the legend over here. And my x-axis is representing the year and my y-axis is representing the amount. Okay, so basically we had lesser profit and our expenses were greater than our profit throughout the years. So basically the company is in financial loss. So that is something that we can easily predict through this particular graph. Although our sales were pretty high, we are not generating the required profit, right? So this is how you can analyze financial data in just a few lines of code. All right. So now coming to the last topic for this particular video, that is a 3D plot. So let's plot a 3D plot for this particular data frame that we have. Okay, so in order to do a 3D plot, all you have to do is create a variable. So I'm going to call it AX and I'm going to say plt.figure and I'm going to say projection equal to 3D. Okay, and now I'm going to create my scatter plot and I'm going to pass my variables. So I'm going to pass my age, salary and experience column and I'm simply going to say plt.show. Okay, sorry, it's not going to be plt.figure, it's going to be plt.axis and my d is going to be small. Okay, so as you can see over here, I've got a 3D plot. So in order to clarify what each of these axes is representing, I'm going to label these axes. And in a 3D plot, I'm going to use set X label, set Y label, and set Z label. Alright. So once I run it, so as you can see over here, this particular axis represents age, this represents salary, and this one over here is supposed to represent experience, but I'm not really getting the label over here. So this code is going to perform better if it was run on a visual code or Jupyter notebook. Okay, Google Colab does not really support a lot of 3D animations. So if you were to run this particular code in VS Code, you would be able to rotate your graph on different axes and be able to visualize the data better. So if you want to achieve the same functionality in Google Colab, all you have to do is import plotly.express as px, and if you run it, so it's run successfully. And then you can simply go ahead and create your figure, which is going to be your scatter plot 3D. So it directly comes with a 3D scatter plot, and you can pass your data frame, and your variables are going to be age, salary, and experience. So what I've done over here is I've created a figure variable and I've used px.scatter3d. So it's directly going to plot a 3D scatter plot, and I've passed my data frame, my age, salary, and experience variables, and I've titled it as 3D scatter plot. Okay. Now all I have to do is say fig.show, and if I run it, so as you can see over here, now I am able to rotate my graph. I can visualize the data on a 3D level. Okay, so this is how you can do it using Plotly library. Okay. Matplotlib also offers this particular option, this particular functionality, but just not in Google Colab. Okay, you can do it on Visual Code or Jupyter Notebook. I hope you guys were able to understand Matplotlib, the functionalities, and most importantly, which plot is supposed to be used for what kind of data set. So we've discussed univariate, bivariate, and multivariate analysis along with PyPlot API and object-oriented API. So I hope this video was helpful to you guys. So in the last video, we saw how we can plot different graphs using Matplotlib. But there are some limitations with Matplotlib when it comes to customizing your plots or even grouping data. All of this requires more lines of code as it has to be done manually. This is where Seaborn comes in. It is powerful and easy to use as it is built on top of Matplotlib. So in this video, we will be looking at the different kinds of plots like regression, relational, multi-grid plots, and so on in a very simple and easy manner. So without wasting any time, let's get started. Alright, so the very first thing that we have also seen with our previous libraries, we have to install them using the pip command. So all you have to do is say pip install Seaborn, and you have to run this particular command in any of your terminals, your command prompt, right? So once you have installed the library, all you have to do is import it. So you can say import Seaborn, and I'm going to use an alias called SNS because that's the common practice again. And along with Seaborn, I'm also going to import pandas as ed and numpy. So these are all the libraries that I will be using. Now, one thing that I absolutely love about Seaborn is that it's got a number of inbuilt data sets. What I mean by that, let me quickly show you guys. So all you have to do is say sns dot get underscore dataset underscore names, and if you just run it, you get a list of all the data sets that come within Seaborn, right? So you have anagrams. You can go ahead and load these data sets and just take a look at what's stored inside these. But I'm going to go ahead with the penguins data sets because I'm obsessed with penguins. So all you have to do in order to load the data set is give a variable. So I'm going to use the variable name penguins, and I'm simply going to say sns dot load underscore dataset, and I'm going to pass my dataset name, that is penguins. So you can just copy paste from here in order to avoid any errors. I'm also going to see the top 5 entries of my dataset, what it's going to look like. So these are my columns: species, island, bill length, bill depth, flipper length, body mass, and the sex or the gender of the penguins, right? So Let me just see what all different species exist inside my dataset. So the basic EDA that I'm going to perform, I have already covered in my Pandas tutorial. So if you guys have not watched it and you guys are finding it a little confusing, what I'm going to do over here, you guys can quickly go ahead and watch the Pandas tutorial. I have provided the link in the description. So inside the penguins data set, I'm going to specify my column, that is my species, and I'm going to say value underscore counts, and I'm going to run it. So as you can see, I have three different species and these are their counts. Right, so I have 152 Adelie species, 124 Gentoo species, and 68 Chinstrap species. Similarly, I'm going to see the different islands that these penguins are distributed on. So simply I'm going to pass the island column over here. So if I run it, there. So again, I have three different islands, that is Bisco, Dream, and Togersen, and these are their counts, right? So I'm getting a little bit of an idea about my data set. So I have three different species and three different islands that these species reside on. So guys, one more important thing, it's very important to know about the features in your data set before you actually start working with your data set, because until and unless you know what these features are representing, you will not be able to do the right analysis, right? So let me quickly show you guys. So I have an image over here which is perfectly representing the bill length, the bill depth, the flipper length, the flipper depth, and the foot of a penguin. So basically these are the different measurements done on a penguin. So now that you guys have a basic idea, let's go ahead with our very first plot, that is a scatter plot. So what I'm going to do here is just say SNS dot scatter plot, and I'm going to pass my first parameter, that is the data. My data is stored in the variable penguins, and my x variable is going to be my flipper length. So flipper underscore length underscore mm. So it is in millimeters. Then I have my y variable. So I'm going to represent the body mass given in grams, and I'm simply going to plot it. Okay. So there you have your scatter plot. So basically what this graph is telling us is that as the flipper length increases, so does the body mass. Okay. So in general, whenever a penguin has a higher body mass, say above 6,000, the flipper length is going to be around 220. Okay, so this is what the data is trying to represent over here. Now, Seaborn lets you pass a third feature as well. So you have your X variable, you have your Y variable. Now you can pass in other features. So say I want to distinguish, or I want to see which of these penguins belong to which island, right? So simply what I'm going to do is I'm going to say hue, and I'm going to pass my island feature, and this is the graph that I get. Okay. So I have the three different colors representing the three different islands. Now you can easily see that the islands represented by the green and the blue dot, that is Dream and Togerson, have lower body mass and lower flipper length of penguins, right? Whereas this particular island, Bisco Island, has comparatively higher body mass and higher flipper length or greater flipper length. Now instead of island, I can also pass the sex feature. This is what my graph is going to look like, right? So male and female. So again, you can see the male penguins have a higher body mass and a higher flipper length as compared to the female penguins. All right. All right. So basically, Seaborn allows us a few default styling themes like white grid, dark grid, and ticks. There are two methods basically. So one is set style, okay, and the other one is set context. So first, let's go ahead and look at set style. So over here, you can basically set the different backgrounds. So if I say sns.setStyle and pass the parameter ticks, this is the kind of graph that I'll be returned. If I say white grid, you can see I am going to be returned a graph that will have grids and the background will be white. Similarly, I can do just dark, and over here the background is turned dark, and instead of dark I can say dark grid, and now I have a dark background with grids. Okay, so basically these are the different background styles that you can set with the help of sns.setStyle, and all you have to do is simply pass the parameter whatever background you want, and then you can just go ahead and plot your graph. Another thing that you can do in Seaborn is sns.dspine, and by default it is going to help you remove the top and right spines of your graph. Okay, so let me just set the background to text. And now if you see, the top and the right spines are removed. If I say left equal to true, so you can see my left spine has also been removed. Okay, so I can go ahead and customize my graph in this particular manner. Another thing that I want you guys to know about is set context. So Seaborn has 4 different types of context. So context basically means that you can override the default parameters. So you can change things like the size of your labels, the lines, and other elements of your plot, but not the overall style. Okay, so the overall style is set by your set style parameter, whereas your context, like the size of your labels, your text, your lines, that is set by set context method. So let us just see the different types of context that Seaborn has. So the first one is paper. So this contains of small elements and it is more ideal for printing in academic papers. Then you have notebook, which is what we are working on, right? So this is supposed to be an ideal context for all the graphs. So this has medium sized labels and text, and it is good for working inside a Jupyter or Google Colab for that matter. Then we have talk, which is for presentations. It is going to have large text and lines. It is going to help in increasing the readability of our plots. Then we have posters. So this has very large elements. That is, all your fonts and styles are going to be extremely large so that they are printed in an efficient manner for large displays or posters. Okay, so now that you guys have understood, let us go ahead and set our context. So let me just do it for this particular plot itself. Okay, sns.set context, and I'm going to do poster for this particular graph. And now as you can see, all my fonts and my plots, right, all my data points also have increased in size. If I were to say talk, they would decrease a little, right? So you can see they have decreased a little. If I say paper, they're going to be extremely small in size, as you can see over here, right? This is ideal for printing. Let me just remove this particular parameter because I want my left spine to be there, right? And the last one that we have is notebook, which is, I think, our by default context. Yeah, these are the different contexts and these are different styles that we just discussed. Then there's something known as palette. Okay, this is very important when it comes to styling. So you have different sets in your palette. So set 1 is basically going to contain your bright and high contrast colors. Again, you can by default assign the different colors, but if you do not want to remember each and every color, you do not want to go that extra mile, you can just by default pass set 1, set 2, set 3 as your palette. And set 1 is going to have your bright and high contrast colors, whereas set 2 is going to have more softer or pastel colors. So it could include shades like baby pink and sky blue. Whereas set 3 is going to be a mix of soft and bold. That is, it is going to have a varied hue. Okay, so these have 9, 8, and 12 respectively distinct colors. So these are the 3 sets, but your palette or your color palette also has different parameters like deep. So this is going to have a rich and balanced shade of colors, whereas muted is going to be comparatively softer range of colors or softer shade of colors. Bright is going to again be your high contrast bold colors. Then pastel is again your soft colors or your pale colors. Then dark is again a little dull side of colors. Then colorblind is optimized for colorblind accessibility. So Seaborn gives you that option as well. So since you have so many options in your palettes, you can also choose your palette type depending on your graph. So if you have a qualitative graph, that is, it is categorical in nature, the color assigned to each group needs to be distinct. Okay, so say suppose you're just plotting the different fruits in your data set. So you can set your palette type to be set 1, set 2, set 3, or pastel 1, dark 2, colorblind, ascent. Okay, so this is going to help you distinguish each category based on the groups. Similarly, for sequential data type, that is a data with ordered progression, that is low to high or high to low, you can use a particular color and the different shades of those colors would be assigned to that particular data. So it is going to help you see the magnitude or intensity like population or revenue. Then you have diverging, that is when you have a midpoint and you have negatives as well as positives plotted in a graph. So you can use palettes like cool, warm, or red, blue, and so on. So it is going to help you see the positive versus negative changes in your graph, like the profit or loss or temperature changes. Okay, so these are the different use cases of a palette. So let us go ahead and try some. So in this particular plot, we would say we're sort of qualitatively distinguishing between our features. So I would pass my palette as set 1. So let me see what it's going to look like. Okay, so it's blue, green, and red. If I say set 2, you can see these are the pastel colors. And if I say set 3, there. Okay, so this is not a good choice for this particular graph because I can barely see the yellow color. Okay, so let me do dark 2 for this particular graph. Okay, D is going to be capital. Okay, so I think I'm going to stick to this because this is helping me distinguish all the data points very nicely. Okay, so we saw how we can plot a scatter plot between two numerical features. That is, we saw flipper length versus body mass. Now let me go ahead and plot a scatter plot where my data is going to be penguins and my X feature is going to be species. My Y variable is going to be body mass in grams. Okay, and let me classify this based on the islands. So if I go ahead and see the graph, okay. Now another thing that I want to add in this graph is I want to see the sex as well. So I want to also classify my data points based on male versus female. So I'm simply going to say style equal to sex. So style is basically going to define the style of our data points. So the round data points are the male data points and the cross data points are the female data points. Okay, so now my legend looks something like this. But now one problem over here is that my data points are overlapping a lot. Okay, so one thing that I can do is I can go ahead and say alpha equal to 0.5. So what this is going to do is it is going to decrease the opacity of my data points by default, and wherever there is an overlap, it is going to have a higher opacity of my data points. Okay, so since it makes reading the data somewhat clearer, it is not very efficient, right? I still cannot figure out a lot of things in this particular graph over here. So another plot that we have that is similar to scatter plot is known as strip plot. And I'm going to do the same thing over here. I'm going to pass my hue as island. And what I'm going to do is I'm going to say jitter equal to true. Okay, let me not do that for now. If I just run it. So now as you can see, my data points are somewhat more scattered. And this plot is giving me a somewhat better representation of my data spread, right? Now what I can do is I can go ahead and pass dodge equal to true. So what this is doing basically, it's going to separate my data points based on my hue. Okay, so earlier I had all these data points clustered together, but now they're spread away. Okay, they're divided based on the different islands. Okay, and I can also say jitter equal to true, which is again going to help me read my data better. Okay. So basically we pass jitter equal to true so that we can randomly spread our data points a little for better readability. Now, in order to randomly spread our data point, we have another plot that is again similar to scatter plot that is known as swarm plot. Okay. So if you want to plot a swarm plot, all you have to do is say sns dot swarm plot and pass my data is penguins and my x variable is species, my y variable is body mass in grams, and hue is island. If I go ahead and print my graph, you can see this is what it's going to look like. So it is basically going to give a swarm shape to my data, and this is going to help me read my data in a more efficient manner. So I can clearly see that in the Adelie species, most of the body mass is concentrated between 3,500 and 4,000, whereas there are a very few chinstrap species that reach the body mass index of 4,000. And lastly, the Gentoo species have comparatively higher body mass compared to both these species, right? And as you can see, the Gentoo species are only found on Bisco Island, whereas chinstrap species are only found in the Dream Island. And Adelie species are the only species that are found on all three islands, right? So you can also figure that out with the help of this particular plot. Now, in order to make it a little more pretty, what I'm going to do is I'm going to set my context to say talk, and I am going to define my top and right spines in my chart. So there. Okay, so I have modified my graph a little bit using the Seaborn features, and this is what it looks like finally. So we saw how we can visualize two features together. Now, what if I want to just visualize one feature? So for that, I have something known as histogram. We have already seen this in our previous lecture on Matplotlib. So in order to plot my histogram, all I have to do is say sns.hisplot, pass my data, and I want my x-axis to represent my body mass in grams of all the penguins. So as you can see, so this is getting really difficult to read. What I'm going to do is I'm going to set my context back to notebook. Okay. And okay, so now it's much easier to read. So as you can see over here, around 60 penguins have the body mass of 4,000. All right. And only 10 have around 3,000, whereas even fewer, that is around 5, I think 4 or 5 have the body mass of 6,000. Okay. So very few penguins are, I don't know if it's overweight or healthy. I am not aware of that. So you can see the frequency distribution of the body mass. And now I want this to be divided based on the sex of the different penguins. So as you can see over here, more number of females have a lesser body mass. That is in the range of 3,000 to 3,500, whereas in the range of 5,500 to 6,000, more male penguins have a higher body mass, right? So in order to make it better, I'm going to say multiple equal to stack. So this is going to help me stack the different categories of my hues, right? So basically this is the distribution of male versus female body mass and the different counts that each of these have. So usually a histogram is combined with other plots like a KD plot or a regression plot, which is nothing but a trend line that helps you see the pattern in a more efficient manner. So let us go ahead and see the regression plot. Okay, so it basically helps us see the relationship between two variables and fits a regression line, which is basically a linear line, okay, through all the data points. So in order to plot a regression plot, all you have to do is say sns.regplot and pass your data, and then pass your x variable and y variable and print it. Okay, so as you can see, this is your trend line over here that is passing through your data point. So if you've studied linear regression, this plot becomes much more easy to understand and easy to read. So again, we've talked about the palettes, we've talked about how to style your plots. You can go ahead and experiment with that. I'm not going to go ahead and style each and every plot because again, that would take a lot of time. And if you don't want your data points to be visible over here, you can simply pass scatter equal to false, and now you would be only left with your regression line. Okay. So I want my data points to be visible, and what I can do is I can simply pass my color and I can say I want it to be green in there. Okay, so you can go ahead and play around with your plots using these parameters. Then the next plot that we have is a line plot. So again, a line plot basically helps you visualize a numerical column in a continuous manner, right? So I can go ahead and say sns.lineplot and pass my x variable and my y variable. And let me not use hue right now. So as you can see, this is what my body mass versus flipper length looks like. So when my body mass is around 3,000, my flipper length is around 180. Okay, and when my body mass is around 4,500, my flipper length is around 215 or 218. Okay, so let me just go ahead and say sns.set style, and I want it to be a white grid. So now you can use the grids to help read your plot better. That is, if you are trying to make any inferences. So as you can see, this particular data point is crossing the body mass of 6,000 and it's touching 230. So the maximum flipper length that a penguin has is 230. Now I want to see whether this particular penguin is a male or a female. So I'm going to pass hue equal to sex, and okay, so it's a male, right? So male penguins have higher body mass, whereas a larger flipper length. Okay. Instead of sex, now I want to see the distribution based on island. I can simply pass island in my hue, and I can say style of my line should be represented by the sex. So now I can have both my sex and eyelids. So the dotted lines basically represent the female penguins, whereas the orange line represents the Bisco Island. Similarly, the green dotted lines are the female penguins at Dream Island, whereas the blue complete line represents the male penguins at Torgeson Island. So this is how you can plot a line plot between two numerical columns. Now there's something known as a join plot, which is nothing but it lets you combine two different plots. Okay, so you can combine two plots, like you can combine a scatter plot and a histogram. So you can simply say SNS dot join plot and pass my data to penguins. Okay, so my X variable is going to be the body mass in grams and my Y variable is going to be the flipper length. And if I plot this particular plot, so as you can see, this is my scatter plot, and over here on the edges, I get my histogram. So this histogram is basically representing the density of my data points. So wherever I have a higher density, my bars are going to be higher for that particular area. Okay, so this particular area has a higher density and it is being represented on both the axes in a similar manner. Now I can go ahead and plot a different kind of set of plots in a join plot. If I increase my number of parameters here, I say my hue is sex for now. And if I plot it, you can see I have scatter plot versus a density plot. So this plot is nothing but a smoother version of a histogram. So over here we have two colors, and these colors are representing the density of, again, the two data points that we have. Okay, so the orange data points are more dense at this particular area, whereas the blue data points are more dense over this area. Okay, so you can also go ahead and manually describe the kind of plots that you want. So I can go ahead and say KDE plot, and over here I would get a plot like this. So this is basically telling us the concentration of data points at a particular place. Okay, so as it's clearly visible over here, I have more data points over here and a slightly less concentration of data points over here. Similarly, for the male penguins, I can see the concentration of the data points. So instead of dividing my data points based on sex, I can also divide them based on the island. That I can pass my bar over here instead of a KD. Okay, no. So kind can be scatter, histogram, hex, KD, regression, or res ID. So let me go ahead and pass regression. Okay. So scatter plot is supported for this particular hue. Okay, if I do not have a parameter hue, I can go ahead and say I want it to be a regression plot, because then I would have my histograms over here and now I can have a regression line based on these histograms. Okay, so I hope joint plot is clear. Now the next plot that we have is a bar plot. So again, this is very much similar to a histogram. All you have to do is say SNS dot bar plot and pass your data, your X variable and your Y variable, and the category that you want to separate your two data points with. And then I have my different species, the body mass represented by each species, and the male and female distribution of both the species. Right, I can go ahead and pass my palette. I want the colors, say, pink and blue. Okay, so similarly, you can also go ahead and change the different parameters. So instead of blue, let me have sky. Okay, much better. So this is somewhat a pastel palette version that I have implemented. Okay, so by default, the bar plot is telling us that this is the mean distribution of these species. So basically, what's happening here is the male Adelie species have an average body mass of 4,000, whereas female Adelie species have an average body mass somewhere around 3,400. Okay, so by default, the parameter of estimator is np.mean. Okay, so if I say np.sum instead, okay, there. Now you can see our scale has been changed. So the overall body mass of all the male species of Adelie is somewhere around 3 lakhs. Okay, and similarly now our scale has been changed to sum. I can also go ahead and change it to median. Yeah. So I can check the median body mass of all the species based on their sex, that is male and female. I can go ahead and change it to standard deviation. Okay, so this is the standard deviation. I can also go ahead and see the variance. Okay. So this is the added advantage of Seaborn as compared to Matplotlib. If I were to plot a similar graph in Matplotlib, I would have to do a lot of manual calculations side by side in order to get this particular graph. But in Seaborn, I just have to pass a simple parameter called estimator, and I can change the scale or I can change the distribution to the way I want it. Now, what if I want to just simply count the different species of penguins that I have in my data set? So for that particular goal, I have something known as a count plot, which we also saw in Matplotlib. But there was no direct implementation of a count plot in Matplotlib. We had to manually count our categorical data using value counts. But over here in Seaborn, we have a direct implementation where I can simply say sns.countplot, pass my data equal to penguins, and my x variable is simply going to be species. If I go ahead and plot it, okay, so my data frame is not going to be in quotes. I'm sorry about that. Okay. So as you can see, I have around 150 Delhi species, whereas around 65 or 70 chinstrap and around 125 of Gentoo. Okay. So this is the distribution of the various species. I can go ahead and set my hue as island. Okay. And I'm going to go ahead and set my palette to set to there. Okay, so I have the different species in different islands and their count all in one graph. Okay. Alright, so moving on with the next plot, that is box plot. So again, this plot is used for detecting outliers, that is the extremely low or extremely high values in a particular column or feature. Okay, so this particular plot basically helps us identify the different groups in a feature through their quartiles. So a box plot basically uses three quartiles, which is 25%, 50%, and 75%. So let me show you guys through an image over here. So this is what a box plot looks like. So over here, this is an outlier because this is an extremely low value, and box plot has a minimum and a maximum range of value. So over here, for this particular plot, 10 is the minimum value and 90 is the maximum value. The median value lies somewhere around 55. So we have whiskers, which are basically the lines connecting the minimum and the maximum values along with the lower quartile, which is the 25 percentile, and upper quartile, which is the 75 percentile. Median is basically a 50 percentile. Okay. And what these percentiles basically represents is 25 percentile is basically representing all the data points that are below the 25th percent of this particular plot. Okay, so let's go ahead and plot a box plot using Seaborn. So all we have to do is say sns.boxplot and pass your data, which is penguins, and I'm going to have my species. Basically, I'm going to create a box plot for body mass, and I'm going to group it using island, and I want it for the three different species. Okay, so this is what my box plot is going to look like. So I have the three species on my x-axis, and the y-axis is representing my body mass, and these are the box plots for the three different islands. So instead of island, I can also categorize them based on the sex, that is male and female, and this is what they're going to look like. Okay, so basically the chinstrap species have outliers, that is, so there is one male penguin in the chinstrap species that has an extremely high body mass compared to the other species, whereas there is one female penguin in the chinstrap species which has a really low, that is below 3000 body mass. Okay, so this is something that we can easily figure out, and we can also see the median values for all the species and male and female respectively. So again, this particular species has an extremely high body mass for both male and female compared to the other two species. So we can say the male species of these two particular groups are pretty much the same as well as the female species. Okay, so this is basically what a box plot helps you figure out. You can also go ahead and play around with the palette, the colors, the background, and the other context that we just talked about. So the next plot that we have is known as a violin plot. So while I was learning the different plots, I think violin plot was one that I found most difficult to understand. So let me simplify it for you guys. It's very much similar to a box plot, but the only difference is it uses a KD, that is kernel density estimation. So this is what a violin plot basically looks like. Okay, whatever features we just discussed for a box plot exists the similar way for a violin plot. It has a lower adjacent value. That means it has a minimum value, a maximum value. Okay, the point where this particular line ends is known as the maximum value. The dot over here represents the median, whereas this particular bar, the top part represents the third quartile, that is the 75 percentile, the first quartile, that is the 25 percentile, and these are basically the whiskers, and the outside points are basically anything that lie beyond this particular graph. Okay, so let us go ahead and quickly plot a violin plot, and let me just do it using the same particular features that we used earlier. So if I go ahead and run it, so this is what a violin plot looks like. So again, it is helping us see the distribution of data, and we can also see the shape of our data, right? So I can see that my data points are mostly concentrated over here through this axis. So I can conclude that the female species of chinstrap are mostly have the body mass around 3,500. Okay. Similarly, I can do that for the other species as well, looking at the shape of my plot. Now, another thing that the violin plot offers is the split parameter. So if I say split equal to true, this is what my plot is going to look like. Okay, so basically it has been split for my male and female. So this is what a violin plot looks like, and this is how it's done. So basically, as I told you guys earlier, the width of my violin plot is going to represent the density of the data at different values. So if you see the plot being stretched at the particular point, you need to know that the data points are concentrated at that particular point. The middle line over here is the median value, and the thick bar is the interquartile range. That is, if there is an inner box equal to true. Okay, so if I pass inner equal to box, so what this is trying to tell us is this particular box over here is basically representing our interquartile range, that is IQR. So the interquartile range is nothing but the third quartile minus the first quartile. Okay, so that's it about violin plot. So I hope you guys remember swarm plot that we talked about earlier. So let me show you guys something. So if we do a violin plot for a species and body mass, and on top of that, if I do a swarm plot, and my X is again going to be species, and Y is going to be my body mass, and my color is going to be black, and let me have the size of my data points as 3. If I plot this, so as you can see, my swarm plot is going to fit exactly inside my violin plot like this. Okay, so I can clearly see the distribution of my data points with the help of these two particular plots. Also, instead of passing the color black over here, what I can do is I can pass my hue as eyelet. I'm going to give this palette pasted, and if I run it now, okay, and over here I'm going to have palette of dark. Okay, so this is what my plot is going to look like. Then the next plot that we have is known as a KDE plot. So this is nothing but a kernel density estimation plot. So a KD is basically a probability density function of continuous data. In simple terms, we can say that it is a smooth version of a histogram. So it basically shows the distribution of data, just like histogram. So instead of bars, we have a line, and if we pass a hue function, we can have different color of lines. So it's basically going to help us see where the data is concentrated with the help of the peaks, and how it spreads with the help of the density of the graph. So in order to plot a KDE plot, all I have to do is say sns.kde plot, pass my data, my X variable, and pass my hue. And I'm going to say fill equal to true because I want my colors to be completely inside these particular lines. If I make this particular parameter as false, it's just lines. Okay, so this is basically what a KD plot is. This is basically just representing a histogram in a different manner. Okay, so I'm going to make this true because it looks much better with filled in graphs. Alright, so the next plot that we have is a heat map. So it is a 2D color-coded matrix that shows the relationships or patterns between two or more variables. Okay, so it is commonly used to show the correlation between features, visualizing the confusion matrices. That is something that we will be looking into deeply in machine learning in the later stages. And it also helps us highlight the missing data. So it has a simple function where you can see whichever data points are missing using the isNull function. Again, that is something that you will be implementing in the later stages. So a heat map only allows to visualize the relationship between numerical columns. So let me go ahead and check which columns over here are numeric. So build length, build depth, flipper length, and body mass. Okay, so I can take these particular columns. So let me just copy it. Let me create a variable called columns, and let me just go ahead and pass these particular columns. So basically I've stored all the numerical columns in a list format in this variable columns. Now what I'm going to do is I'm going to create a heat map using sns.heatmap, and then I'm going to say my data is going to be the penguins. Columns are all these columns, and I'm going to do a correlation on them. Okay, so let me just go ahead and run this for you so you guys know what this CORR function does. So as you can see, it's giving us a correlation. So bill length with bill length has a correlation of 1 because these are the same columns. But the features bill length and bill depth have a negative correlation. That means that as the bill length increases, the bill depth decreases. Okay. But bill length and flipper length have a positive correlation, which means as bill length increases, so does flipper length increase. Okay. Same with body mass. So this is basically what correlation means. It gives us the relationship between two numerical columns, whether one increases with the other or not. Okay. So for now, let me just go ahead and pass this in my heat map and see what it looks like. So as you can see over here, it's giving me a color encoded information about the correlation between these particular columns. So instead of numbers like this, we have colors which represent the different information. So the highest correlation has a peach color. Okay, so this is why all the diagonals have a peach color over here. And black represents very strong negative correlation. So flipper length and bill depth. Okay, so these two particular have a very high negative correlation, and body mass and bill depth also have a negative correlation. Okay,
So this is something that you can infer from this particular graph. Now what I can do is I can say a note equal to true. So this is going to label my information on my color encoded box. So over here now it gets very easy for me to read this particular graph. I can also go ahead and change my color to, I can say blue. So I want all the blues in my graph. So you can see the different shades of blue. The extremely dark shade of blue represents a positively high correlation, whereas a lighter shade of blue represents a negative correlation. Okay, so you can see it's almost white. And as the correlation moves towards the positive side, so does the shade of blue move to the darker side. Okay, so this is what is happening. Now another thing that I can tweak over here is, say I want my negative correlation to start from 0.2 rather than minus 0.5. So what I'm going to do is I'm going to say vmin, and I'm going to say I want it to be from minus 0.2, and once I run it, you can see my negative correlation is starting from minus 0.2 rather than minus 0.4. Okay, so I have changed my scale completely, and since my scale has been changed, the color over here of my boxes has also been changed. Okay, so this is how a heat map works. You can go ahead and play around with other parameters like line width. I can say I want it to be 2. Right now I think it's 0. Okay, so as you can see, I have a line between all my boxes over here, and right now it's white. I can go ahead and change my line color to black. So there. Alright, so moving on to the next plot, that is rug plot. So this is a very simple plot that adds small ticks or small lines, vertical lines along the axis that you define. And these ticks, like rugs, basically represent the different data points of your feature or your column. Okay, so these rug plots are generally used along with histograms or KD plots to give a little extra detail to your plot. So in order to plot a simple rug plot, all you have to do is say sns.rugplot and pass your data, which is penguins, pass your x and y variable, and I'm going to set my palette to set2. Okay, and once I run it, so you can see these are my lines over here representing the different species. I have passed my x variable as body mass and my hue is species. If I say I want this to be my y variable, my rug plot is going to be over here. Okay. I can also go ahead and change the height of all these vertical lines or rugs. I'm going to give it, say, 2. It's going to be pretty big. Okay, I was supposed to do it 0.2. Okay, so this is about rug plot. So the next plot that we have is a pair plot. Okay, so this is basically a grid of plots that shows the relationship between all the numerical variables in a data frame. Okay, so it basically does multiple plots together and helps you visualize all of these numerical variables together. So it's going to use a single plot to visualize the pairwise relationships and distributions in a data set. So in order to do a pair plot, all you have to do is say sns.pairplot, and we already have a list or variable specifying all our numerical columns. So I'm just going to go and use that. So my data is going to be penguins and all the columns that we specified, and if I go ahead and plot it, okay, if I do not pass this particular thing over here, so unlike a heat map, your pair plot is not going to raise an error if you pass your entire data frame at once, which is obviously going to contain categorical columns as well. So what pair plot does is it automatically filters out all the categorical columns and works only with the numerical columns. Okay, so I have not passed the numerical columns explicitly. Rather, pairplot has done it by default, right? So I can go ahead and play around a little with my features. I can say I want my hue to be sex, and I'm going to give my palette as set 2. I don't know, I'm obsessed with set 2. And I'm going to say I want my diagonal lines to be KD. That is, I want it to be the KD plot for the diagonal direction. And as you can see, I have the diagonal line covered with KD, and I have scatter plot for all the other features. Okay, so this is a pretty big plot having multiple pairwise relationships. Okay, so you can go ahead and understand them all one by one. I'm not going to do that right now because that's going to take up a lot of time. Rather, what I'm going to do is I'm going to show you the different parameters that exist in pair plot and how you can use them. Okay, so basically what a pair plot is doing over here is it is showing you a lower triangle and an upper triangle. Okay, so this is a pair plot. Over here we have a diagonal line which we have specified to be as KDE. Okay, and then what we're left with is a lower triangle and an upper triangle. So we have scatter plots for a lower triangle as well as upper triangle. For our diagonal, we can either specify our distribution to be a KDE plot or it can be a histogram. So I've just written hist over here. So this is basically what's happening. So if I go ahead and try to have my lower triangle, so I can go ahead and change this to histogram, which was there previously. There. So you have your histogram and you have your scatter plots. Okay, so this is what a pair plot looks like. Now the last plot for this particular video is a pair grid. Now this is an interesting one because mostly this is not covered in many places. So a pair grid is basically a subplot grid for plotting pairwise relationships in a data set. Okay, so it's very similar to a pair plot, but we're going to see how it acts differently or how it behaves differently. So I'm going to go ahead and create a variable called graph, and then I'm going to say SNS dot pair grid and pass my data as penguins, and I'm going to classify my hue with sex, and I'm going to give my palette set 2, and then I'm going to define that in my upper triangle I want a scatter plot, in my lower triangle I want a KDE plot, and on the diagonal I want a histogram. Okay, so now what I'm doing over here is I am defining each and every parameter on my own. I'm defining my lower triangle. Okay, this is my upper triangle, this is my lower triangle, and this is my diagonal. If I run it, so as I defined, I wanted a scatter plot in my upper triangle. So as you can see over here, these are my scatter plots in my upper triangle. I wanted KD plots in my lower triangle. So we have KD in our lower triangle, and I wanted a histogram on my diagonal. So this is how you can define the various parameters, and you can also go ahead and say graph dot add legend. So this is going to give me a legend. So now as you can see over here, I have my legend which is specifying the different colors, which one represents male and female. I hope you guys understood Seaborn, and I hope you guys found it much easier to work with comparatively to Matplotlib. Alright, so far we've covered the basics of Python. We've also explored a little bit of NumPy, and we have seen how we can work with data sets using Pandas. Now the next step is EDA, or Exploratory Data Analysis. This is also one of the most important steps in data analytics. This is where you truly begin to understand the data. In the next few sections, you will be learning how to create reports and dashboards. But in order to do that, you need to have a clean data. So in this section, we will be learning how to deal with missing values, duplicate values, and more. So without wasting any time, let's quickly dive in. I want you guys to open your Jupyter Notebook or VS Code or any sort of compiler you are comfortable with. It could be Anaconda, right? So in order to get started, I'm going to quickly go ahead and import all the libraries. So first one is going to be Pandas as PD. Then I'm going to import my NumPy. So I've imported Pandas and NumPy, and for visualization, I've imported Matplotlib and Seaborn.
So I want to quickly remind you guys, I have created detailed courses on all of these 4 libraries. So if you guys have any sort of doubt or you guys want to clear your concepts for any of these libraries, I would recommend you to quickly go ahead and watch those videos. I have provided the link in the description. Alright, so if once I have imported my library, the next step is to import my dataset. So I'm going to go ahead and upload the dataset on my drive first. Okay, so this is my dataset over here. People, and in the bracket I have ins. It's a little complicated name, so I'm just going to copy the path over here. And I'm going to store my dataset in the variable df, and I'm going to say pd.read underscore csv, and I've simply passed the path in quotes, right? So let's see if I run it. Now I'm going to go ahead and see the first 5 entries of my dataset. So this is what it looks like. Now I want to give you guys a quick detail about the dataset. So this dataset is basically for HR analytics. So this dataset is basically of the employees of the company for the past years. And this is basically a sort of feedback form. Okay, so you have your satisfactory level, last evaluation, number of projects, and so on. So let us quickly go ahead and understand what each of these columns represent. Satisfactory level is how satisfied the employee is with the company or was. Okay, so we have the scale of 0.38, 0.8. So you can assume that this is in percentage. So the employee was satisfied 38%, 80%, 11%, 37%, and so on. Okay. When the last evaluation was conducted, the employee was satisfied by 53%, 86%, and so on. So either there is a drop in the satisfactory level or there is a rise in the satisfactory level. Okay. Then we have number of projects. So how many projects the employee was assigned? What was the average monthly hours of the employee? How many years the employee had spent in the company? If there were any work accidents basically represent the conflicts. If the employee was ever involved in any sort of conflict in the company, whether the employee is currently working or not. So if for a particular employee there is 1 in the left column, that means the employee is no longer working in the company. Then we have promotion in last 5 years. So 0 represents that the employee did not get any promotion in last 5 years. Then we have the department column. So we have sales and there will be other departments as well. We're going to quickly go ahead and check which all departments are present in the particular data set. Then we have salary, low, medium, and there will probably be high as well. Okay, so let me go and get more information about my data set. I know very little about my data set till now. Okay, so satisfactory level is a float data type column. We have department and salary as our objects, and we do not have any null value as far as I can see. Let me just check the shape of the data set to be sure. Yeah, so we have 14999 entries, and as you can see, all of these columns are non-null, right? So we do not have any sort of missing values in the data set. Okay. The next thing that I can do is I can check how many departments and what all are the salary criteria in our data set. So I'm going to say DF and I'm going to pass department. So we have all these departments: sales, technical support, IT, product management, marketing, and so on. You can see the distribution as well. So there were 4140 people working in sales department, 2720 in technical, and so on. Okay. So you have your department and you have your count. Similarly, let me check for the salary, how many types of salaries are present. So we have low, medium, and high. So as you can see, there are very few employees with a higher salary, right? As we can already see over here, none of our columns have any sort of null value, but just to be sure, what I'm going to do is I'm going to simply say df dot is na, and then I'm going to pass sum, and as you can see, I have 0 null values in any of the columns. Okay, so I do not have to deal with any sort of missing values. Now I'm going to go ahead and check for duplicated values. So I'm going to say df dot duplicated, and then I'm going to calculate the sum of all the duplicates. And as you can see, I have 3008 duplicated values. Now, duplicated values are of no use to me, so I'm going to directly go ahead and say df dot drop duplicates, and I'm going to say in place equal to true because I want to get rid of all these duplicate values in my original data set. So I'm going to go and run it. Now if I check for the duplicate values, let me just copy this line over here. Now you can see I have 0 duplicate values in my data set. Now let me go ahead and check the information of my data set once again. And now you can see the number of entries for all my columns has been decreased.
Okay, so earlier it was around 14,999, and now I'm just left with 11,991. Right, so there's a huge decrement, that is around 3,000 rows or 3,000 entries have been removed from my data set. Now the next thing that I'm going to do is I'm going to check the statistical summary of my data set by using a very simple syntax, that is df.describe and empty parenthesis. And now over here I get the entire statistical summary of my data set. Right, I can see all the counts, the mean value of my entire columns, my standard deviation, the minimum value, the maximum value, and the percentiles over here. Okay. And one important thing is, whenever I'm getting a statistical summary, I'm only going to get it for all the numerical columns, right? So as you can see over here, I only have my float and integer columns, whereas the object data type columns, department and salary are not included over here. All right. So now in order to get started with EDA, as I mentioned earlier, we have to ask the right questions, right? So the first question that I'm going to ask is, do the number of projects affect the employees leaving the company? Okay. So this can tell a lot about the work distribution process in a company if we get the right insights, right? So let us quickly go ahead and answer this question. So I'm going to use Seaborn library and I'm going to use the count plot in order to plot the graph, and my X variable is going to represent my projects, and I'm going to separate them with the left column. So my hue is going to separate. Alright, so in order to answer this question, what I'm going to do is I'm going to go ahead and plot a count plot using the Seaborn library. So if you guys remember the Seaborn tutorial, this is how we plot a count plot, right? And what the count plot is going to tell us, it is going to tell us the number of distribution of projects across the employees, right? And I'm simply going to say number of projects, and let me see what the graph looks like. Alright, so in order to answer this question, what I'm going to do is I'm going to plot a count plot. And if you guys remember, count plot is going to help us see the distribution of the projects across the employees, right? So my data is going to be df, and my x variable is simply going to be number of projects. So if I go ahead and run it, so as you can see over here, 2 projects were distributed among 1,500 employees. So around 1,500 employees got 2 projects, whereas around 3,500 employees got 3 projects. A little more than that got 4 projects, and around 2,000 got 5 projects, and around 1,000 got 6 projects, and very less number of employees got 7 projects, right? So this is the distribution of number of projects across the employees. Now I want to figure out if the number of projects had any sort of effect on the employees leaving the company. So in order to do that, I'm going to add another parameter to this particular graph, which is hue. Now I'm going to say I want it to be differentiated based on whether the employee left the company or not. So I'm simply going to pass my column left. And if I run it now as you can see over here, I have a legend with me, which is telling me that the blue bar is representing that the employee did not leave the company, whereas the orange bar is telling me that the employee left the company. Okay, so as you can see over here, most of the employees with 2 projects left the company. Very less number of employees with 3 projects left the company. Same with 4 and 5. But if you see for 6 projects, a lot of employees left the company. Same for 7. I think 7, all the employees left the company who were assigned 7 projects. But as you can see, for the employees who got 7 projects, all of them left the company. So what we can conclude from this particular graph is that none of the employees who got 7 projects stayed back in the company. Same with employees who got very less projects, that is less than 3, also had a higher tendency to leave the company. Okay, so these are the 2 basic conclusions that we could come up with after looking at this graph, right? So what can be the solution for this particular problem that we just witnessed? One solution could be that the projects should be divided between, say, 3 and 5, right? So basically, no employee should get projects that are less than 3 or greater than 5. So basically, they should have a good work-life balance and a good workload distribution in order to prevent them from leaving the company. Okay, so this is one basic conclusion that we could come up with looking at just this one simple graph. Now, in order to cross-check our conclusion, what I'm going to do is I am going to filter out all the employees who have or who were given 3 number of projects. Okay, So if you go ahead and see the satisfactory level of these employees, it was in a pretty good range, right? 57%, 71%. Okay, there's one employee that had 12%. But if you see the majority of the numbers on your screen, they were above 50%, right? So that was our question 1. Now the next question that I want you guys to understand and try answering is, does the time spent in the company, or we're going to consider the experience level over here, okay, does it affect the employees leaving the company? Okay. So before I start answering this question, I want you guys to take 2 minutes and try it yourself, and just compare your answer later on. Okay. So in order to answer this particular question, what I'm going to do is I'm going to plot a COM plot again. And this time, the COM plot is going to be between my X variable is going to be time spent dot company, and my hue is again going to be left. So as you can see over here, again, I have a legend telling me that the blue bars are the employees who did not leave the company and the yellow bars are the employees who left the company. So as you can see in this particular graph, employees who spent 2 years in the company, barely any of them left, right? Again, for 3 years, very few of them left the company. For employees with 4 years in the company, the ratio slightly increased over here. For employees with 5 years, the ratio is almost equal, as you can see. So almost half of the people left after getting 5 years of experience in the company. Whereas employees with 6 years, again, very few of them left. And then you have employees with greater than 6 years of experience in the company where none of them left. So what are the conclusions from this particular graph? So can we say that employees with 3, 4, and 5 years of experience tend to leave the company more often? Okay. Whereas employees with experience greater than 6 do not leave the company. Okay. So what can be done in order to prevent these employees with 3, 4, and 5 years of experience from leaving the company? How can you as an HR prevent that from happening? So one solution could be giving more employee benefits. It could be a salary hike. It could be more vacations, more sick leaves, right? So basic employee benefits like that could help retain the employees more. All right. So moving on with the next question. Does the department of the employees affect them leaving the company? So basically, we're going to check the correlation between the departments and the left column. So we're going to see if there is any sort of correlation between those two columns. Okay. So again, what I'm going to do is I'm going to go ahead and plot a COM plot. And this time my X variable is going to be department, and my hue or my separation parameter is going to be the left column. And if I go ahead and print it, as you can see over here, sales, accounting, HR, technical support, all the departments are on my x-axis and the counts are on the y-axis. Okay, what if I say I want my y-axis to be the departments? There. So this looks better. I can read all the departments in a much more better way over here, right? Okay, so instead of passing y equal to department, what I could have done was I could have said plt.ticks and I could have rotated my ticks at a 90-degree angle. And then all I had to do was say plt.show in order to avoid any warnings. Okay, sorry, it's going to be x ticks. Okay, so whenever you have large labels on your x-axis and they are merging with the other labels, you can either use this particular method or you can simply plot them on the y-axis. Basically interchange your axis so that they automatically come in neater format. Okay, so as you can see over here, we have the different departments and we have the legend again telling us that the blue bars are the employees who did not leave and the orange bars are the employees who left. Okay, so as you can see in this particular graph, we have the sales department, technical, and support. Okay, so you can see the orange bars going really high up in these 3 particular departments, right? This is where most of the employees are leaving. Okay, whereas the other departments like accounting, HR, IT, product management, marketing, management, and some random departments, there are very few employees leaving the company. Okay, so that could be a basic conclusion. I am not going to write this one down because this is very basic. It's pretty clear from the graph itself that sales, technical, and support have maximum employees leaving the company. So another important thing while we are plotting these graphs is that we are not able to see the exact values or the exact numbers on these graphs or on these bars, right? So what we can do in order to get the exact values on our graphs, so we're going to follow the API method that we had discussed in our Matplotlib video. So I'm going to assign a variable AX and I'm going to store my count plot in this particular variable. Now what I'm going to do is I'm going to say plt.xticks and I'm going to have them rotated by 90 degrees, okay, as I have already done earlier. This is nothing new. Now what I'm going to do is for x in ax.containers. Now what I mean by ax.containers, so basically our ax variable is storing the entire plot. Okay, and containers are basically these individual graphs or individual bars that you can see in the graph. Now basically I'm telling my code that I want to loop through all these bars one by one and simply ax dot bar underscore label, that is I want to label them. Okay, and I'm going to have the count value of those individual container values. And then I'm going to say plt.show. If I run it, there's a spelling error, but my graph was still working fine. So as you can see in my graph, now I have the exact number of values of the bars, right? But there is a mistake or there is an error in my graph right now. I want you guys to quickly comment it if you guys have found the issue. Okay, so the issue is that I'm getting the values only for my blue bars, okay, and not my orange bars. This is simply because I have asked my plot to be shown exactly after I call this particular syntax. Okay, so it's not considering my orange bars. Now, if I call the plt.show function outside my loop, as you can see, I have the numbers for my orange as well as blue bars over here. Okay, so this makes reading the graph much more easier. Now, you can make it a common practice whenever you're plotting a graph. You can just simply follow this method so that you do not have to guess any sort of value and you have the accurate values with you while you're analyzing a graph. Okay. Another thing that I want to find out is the relationship between the salaries of the employees and their departments. Okay. Now, in order to do that, I am again going to use the count plot. I'm going to say sns.countplot and I'm going to have my data as df and my x-axis is going to represent my salaries and my hue is going to represent the departments. Okay. Now again, I'm going to simply say sns dot. Okay. Now I'm going to again rotate my x label text to 90 degrees so that it's more readable. Okay. So as you can see over here, I have low. Okay, so my x-axis should have been my department. Okay, and my hue is going to be my salary because I have only 3 different types of salaries, that is low, medium, and high. Okay, so this makes more sense. So I have the sales department where a lot of employees have lower salary, a little less than them have medium, and very few of the people in sales department, so basically the VPs or the managers, people of that position have extremely high salaries in sales department. Whereas accounting, the ratio is pretty fine. I mean, more than 200 have low and a little less than them have medium. And again, very few of them have high salaries. Same for HR department. Technical department, again, a lot of people have low salaries. Okay. So if we see the most ideal department over here is management. Almost equal number of employees have low, medium, and high salaries. Right. No wonder people from the sales and accounting and technical department are leaving the company more often because most of the employees have very low salary, right? As you can see in this graph. So as I saw earlier that a lot of people from the sales, accounting and technical department were leaving the company. And I can also see that these 3 departments have the maximum number of employees who are getting very low salaries. So I'm going to quickly see the relation between salaries and the people who are leaving the company or not. Okay, so the next thing that I'm going to analyze is, do salaries affect the employees leaving the company? Okay, so in order to do that, I am again going to plot a count plot saying sns.countplot and my data is going to be df. My x-axis is going to contain the salary and I'm going to separate it by hue left. Me print it. So there. Now I would like to see the exact counts on these bars. So I'm going to follow the same method. I hope I don't have to explain it to you guys. You already understood how you guys can get the counts displayed on the bars. Okay, so I'm again looping through my containers and I'm simply printing. And as you can see over here, people with low salaries, 1,000 of them left, more than 1,000. with medium salary around 700, which is still fine. People with high salaries, very less people left, right? As you can see, only 48 people left who are getting high salaries. So salaries do play a very crucial role in retaining the employees in the company. That's something we can clearly see through this graph. Okay. So if I were to calculate the percentage of people who left and who were getting low salaries, I would simply say 1174 divide by 4566. Okay. And I would multiply it by 100. So 25% of the people who are getting low salaries left the company, whereas people with high salaries, I would simply have to say 48 divide by 942, and I would multiply it by 100 and I would simply print it. So only 5% of people who are getting higher salaries left the company. If I were to do it similarly for medium salaries, okay, so 17% of the employees who were getting medium salary left the company. So again, the percentage is highest for people who are getting very low salaries, right? All right, so moving on to the last question for this particular section of our video. Does the work accidents affect employees leaving the company? Okay. So again, I'm going to do a count plot for this question. I'm going to say sns.count plot. I'm going to pass my data equal to df, which is the variable that's storing the data. And my x variable is going to be work accident, and my hue is going to be left. And if I go ahead and plot the graph, okay, so as you can see in this graph, 0 represents the employees that did not have any work accident, and 1 represents the employees that did have work accidents. And as you can see, a lot of people left even though they did not have any sort of work accidents in the office, right? But comparatively lesser people left who had conflicts in the work environment, right? So if we were to calculate the percentage, I would simply have to follow the same method to get the labels for my bars, and then I would loop through it, print it. Okay, so now if I were to calculate work conflict percentages, I mean people who had work conflicts and left. So if I were to calculate that, 105 divided by 1745. So as you can see, 6% of people who did have work conflicts in the office left the company. Whereas if I were to calculate no work conflicts, so 22% of the people who had zero work conflicts in the office left the company. So we can conclude that work conflicts do not really have any sort of impact with people leaving the company. So this was the last question for this particular section. Now, I'm sure you guys can go ahead and explore the data set even further. You guys can go ahead and explore different relationships between different columns, different features that we have, right? And you can maybe come up with better conclusions that we did in the video. But this is how a basic EDA is performed on a data set, where you try to answer different questions, you try to ask the different questions through a data set and come up with insights, right? So this was it for this section.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with iHub IIT Roorkee. Through this course, you'll get to learn data analytics from industry experts and IIT faculty in depth. You'll learn tools like Excel, SQL, Power BI, Python, and K9. This data analytics course is praised by our learners, and their user testimonials are available on our Intellipaat Achievers channel. You can check them out. The link is available in the description below. So if you are really interested in learning data analytics, this is your opportunity. Click on that apply now button right away and get started in your data analytics career journey.
What is the difference between statistic and statistics? So descriptive is done. So I think I can ask this, right? What is the difference between statistic and statistics? Anil is like telling, come again. Let me write it also. I'm just finding. Oh, I got my pen. Okay, let me write. Statistic versus statistics. Any idea? Anybody? Don't Google it. This is the first question I asked when I talked about statistics. If you observe, there's just one extra letter S in there, right? That's the difference in the spelling, not in the concept. So anyone, statistic can be a single piece of data. So guys, I think, see, so this is a question out of syllabus, right? You might say, you have done this statistics and not sure what is this, what is that, right? So I think this is a more like a teacher's way of testing where the unexpected question might come. So see, statistic. I think Soumya, what you have mentioned in the chat, you are close. Statistical techniques. So in case someone is wondering, he suddenly jumped into the concept. The reason is that I have taught this batch. Okay. Statistical technique like Z test, T test, chi-square test, right? All these are your statistic. More like it's an approach, it's a method within the universe of what? Statistics. Statistics is a subject, right? Isn't it, guys? So statistic is more like a method or approach, a technique which you apply on a set of data, which you have collected over a period of time. You have done some transformation. You are going to analyze with the help of these tests. Okay. Let me give you a couple of things and let's see, understand you few things that what is your understanding of descriptive statistics a little bit more so that I can use some of those things in inferential. So I'm just making sure. So tell me one thing, if I talk about salary, right? And I have a very good diagram for that. So you must have, this is the time, by the way, guys. So those who have been to engineering colleges or typically I would say IITs, December is day one. December 1 is day 0 for them. So this is the moment I am sure my juniors will be getting placed, right? So this is a bell curve which I put together, and you might be seeing something coming in the news, right? 1 crore package. Let me tell you, I have been asked this question a lot of time. 1 crore package is a myth, or more like it's a misinformation given to news media print to get some footage or mileage. Uh, Definitely some of the guys, maybe 1 or 2 or 3 people in a batch, they get 1 crore, but that's all in dollar, means it's not in India, it's in US or likes of US. So converting dollar into rupees and then telling you are getting a package of 1 crore, the people forget that they have to spend in dollar. They'll not take a flight, come back to India and spend in rupees. Understand my point? So 1 crore package is okay, right? It's not like that. It is beyond imagination. Okay, so don't worry about it. In India, hardly anybody gets as a fresher 1 crore package. If some company is giving, they're idiots. The company owners or the board is idiot. Okay, doesn't make sense. Now come back to this amazing curve. Okay, let's understand quickly, guys. So definitely you can see this is a skewed distribution. And as you can also see, I've already written it's a right skewed. Anybody? Why it is called right skewed? Why is it called so? Very good, Anthony. That's correct. Because it has a long tail, on the right side. Some of the guys will be wondering what is that long tail. Let me highlight, you will see it. Can you see the distribution is going like this, as a long tail? This is what we say long tail. And the peak is on the left-hand side. So it's a right skewed. Okay. Now, you must have been taught when the data is symmetric, when the data is having a shape like this, the distribution, so then mean, median, mode, all are going to be at the same place. Remember? Now, when the data is skewed, then there is an issue doing mean here. Okay. So far with me, guys? Doing mean here. And what is the reason for that? Because mean is sensitive to outliers. I hope must have been taught this, right? Mean is sensitive to outlier. And this is a very, very common concept. Are you guys aware? Mean is sensitive to outliers. Let me show you if you're not. Tell me one thing. I've also written some packages. Okay. Let's say this is not 51, by the way. This is 5 LPA. Let me write clearly. Else you start laughing at me. 5 LPA. Let's say most of the guys are getting 5 LPA. That becomes, if you think this is your, this is the peak of the salary, you can say like mode. So this is the highest value which you see in the normal distribution. So that's your highest frequency value, which means it's the mode, right? Or you can say close to median, but it cannot be the average. You know why? Because of these guys who are sitting somewhere here, can you see this? Who are sitting here, they are going to impact the average. Are you able to follow, guys? Let me give a simple example. So let's say these are your salaries, 3, 5. I'm taking some numbers in LPA, lakhs per annum. 50 and 80, let's say. So let's say these guys' salary, if you want to find, and this is all in LPA. So if you do the math, what is the mean salary? If someone can do this for me, you will get to how much? Do the maths, guys. Anybody who can help me out here? And I think I have 3, 6, 9, 10. So what is it coming, guys? Did someone do? 81.5. No. Soumya seems to be close. How can be 81.5 average? Only two values are 50, 80. Please check your calculation. 18.2, so many people are telling. So let's say that's the average. Okay. I have not done myself. Right? But if you observe closely, most of your data distribution is not even higher than 10. Right, guys? Can you see this? Just because of these two guys who are like the IITs, that media guy who are getting this high package, has impacted your overall salary. Guys, so far with me? Why don't you do that? If you exclude these outliers and do this maths again, add these 8 salary only and divide by 10. Oh, sorry, divide by 8. How much you are getting, guys? I think it will be close to 6 or 7. 6.5. Okay, thank you. Those who are helping me. Do you think which one looks more closer to reality? This one or this one as an average salary? Definitely 6.5, right? Definitely 6.5. So you understand when I say mean is sensitive to outliers. And that's the reason people say whenever you are looking at a data with outliers, you should not go with mean, you should go with median. Now, why don't we find median for this one? So just arrange 3, 4, 3, 4, 5, 6, 8, 10, 11, 50, 80. 4, 6, 8. I missed one number. I think 5 is 2 times, right, guys? Okay. Aryan, what are you asking? Such a silly question asking why 50 and 80 is outlier. Now tell me, guys, what is the median? So I'll come to you, Aryan. 2, 4, 5, right? So what you will do, my dear, you will take first 4 and second 4, last 4. So you will be left out with what? These two guys. Hello? What is the average? I'm damn sure you must have been taught how to calculate median. So what is the average of these two? I'm not going to teach that. I'm just making a... Now tell me, looking at this number and this number, which one is more realistic? Mean is more realistic or median is more realistic to the average which you might have thought. So now you understand. So that's why if you see, if some apps like Glassdoor or some similar like PayScale, if they report average salary, you should not never go with that. Because let me also tell you, there are students who are coming from ISB and all, and they're getting 30 lakhs as a fresher salary. And then there will be students who are coming from normal college, and they will be getting 3 lakhs or 5 lakhs. So 30 lakhs guys, if you keep taking right blindly, you will he will be in a wrong, means he will in a bubble that thinking, oh, I am also going to get 30 lakhs. So just to, just to bust this thought that, it doesn't work like this. Okay. So does it make sense, guys? Now coming back to RN, outlier, identifying outlier, treating outlier. Okay. So remember I had taught you guys box plot. Okay. So box plot says that if something is in, I'm just more like, revisiting few things. So RN, if you do a little math and try to identify an outlier, you will be able to do that. So now my question is, did you guys go through some of those examples where you identify the outlier and got treated and treat the outlier already, right? So generally, this is in response to the question Aryan asked. I don't know, Aryan, if you're there in that session. That's why you might be asking outlier. Can you see these? There are two on the upper side and two on the lower side. We have outliers. Okay. So there is a statistical way to calculate these whiskers known as whisker. I have also talked about it in my visualization. Let's say this is your upper threshold. So guys, I'll not repeat it. I'll quickly write the equation. So you take the Q3 and then you add the 1.5 times. Statistically, this number has been given to you, this whole formula. You do the interquartile range, which is Q3 minus Q1 and multiply with 1.5. Anything which is greater than this, like these two guys, are going to be outlier. Similarly, you can also do lower threshold. Just refresh your memory. So that will be Q1 minus 1.5 IQR. IQR is interquartile range. Anything lower than this lower threshold, like these guys, are outliers. And you can also make a little sense out of it. If someone is getting, outlier means little something unexpected or weird, right? Everybody is getting 5 lakhs, 6 lakhs, 10 lakhs, and somebody is getting 80 lakhs. Definitely, that is an outlier. That's a normal way of saying it. So outlier means which is not normal, which doesn't fit in normal scenario, is an outlier. Literally, I'm trying to explain. Mathematically, this is how do you do that. Now, guys, I'll jump to one question. And if you have been taught normal distribution, you should be able to take it, because then you must have been taught Z score as well, or no? So then what did you guys do in normal distribution? There's no normal distribution without Z score. And without the normal distribution Z score, I cannot go into inferential. So it's a prerequisite. Okay, so remember, there's a bell curve, okay? Standard normal distribution. Let me do the thing. Okay. So one of the key distribution is normal distribution, also known as bell curve. Bell's curve. I hope my spelling is correct. It has gotten a name, bell curve. Anybody knows why it is? Because if you go to a temple, right, and have you seen a bell, right? The normal distribution can be, shown as a bell curve. Okay. And here you go. Now, if you look at the normal distribution, okay, most of the thing in the world can be modeled as a bell curve. Trust me on that. So that's what I was telling, right? If the normal distribution is symmetric, your mean, median, mode all will be on the same point. Okay. So ideally, when we talk about standard normal distribution, you make sure that it is symmetric, it's not skewed. Okay. And if you look at the top one, not the bottom one, the top one, you must be seeing that I have given 3 colors. One is, between mu plus minus sigma. So I hope you know what is mu, what is sigma. So this is going to cover how much of your data? 68.27%, right? And then if you look at the from mu plus minus 2 sigma, 95% of the data will lie in there. And if you go and stretch it further, mu plus minus 3 sigma, 99% of the data will be there. So you might be wondering, why do we need normal distribution, right? And why mu plus minus sigma is so important. See, this is what has been found or observed on a normal distribution, because it's all about probabilities of what data will lie in where. So if you take any normal distribution curve, you can always find mu, which is your more like expectation of x. Don't go into this. It's a random variable. I'm damn sure you don't know. So expectation of x is generally written as mu, which is your, you can say mean, but it's not real mean, because mean of deterministic data is your average. But this is more like expected value of x. So I'm going to write expected value, and the moment expectation comes, it's probability. Okay, then you also have sigma, which is your, you know that, right? Standard deviation, which is square root of variance. Now, what we are saying that if you take a range of mu plus minus sigma, 68, I'll say roughly, 68% of the data it will have, plus minus 2 sigma, it will be 95% of the data, and mu plus minus 3 sigma, 99% of the data will lie there. This is the reason the professors or the college universities professors, they use this like a lot. So suppose they fit on a normal distribution on your to calculate grades, right? So what happens, guys? Let's say, and definitely it will not be like symmetric. This normal distribution can be skewed. So they know that. So we have a mean somewhere here. So this is going to be mu. They know that in this there will be some sigma. So this is mu plus sigma. This will be mu plus 2 sigma, and this will be mu plus 3 sigma. And let's say this is mu minus sigma. Are you following, guys? And then they create bands. So this is going to be their favorite student, which is maybe 1 or 2, who is maybe 1 or 2, right? And they will be getting, let's say, A plus grade. Then they'll go to the next band, which is mu plus 2 sigma to mu plus 3 sigma. Focus, guys. So all those guys who are here, they are going to get, let's say, grade A, grade B, grade C, grade D. Hello? And everybody who is behind this are going to get what grade? F grade, which is a fail grade. First of all, this is just a high-level overview of how grading system works. It's not that straightforward, by the way. This is just to give an example. And this is the, most of the guys, generally F grade means you have to repeat the course and exam as well. Are you guys able to follow how normal distribution can help you? As a matter of fact, even the COVID quizzes were modeled as a normal distribution. Income can be modeled as a normal distribution. IIT's performance or result can be modeled as a normal distribution. So normal distribution is like bread and butter. Okay. The beauty about normal distribution is that it starts from negative. So it can fit all the real data from minus infinity to plus infinity. No other distribution can do justice for a continuous one. Okay. Now coming back to how we are going to use it. Okay. By the way, you understand what is the meaning of standard deviation? What is the interpretation of high standard deviation versus low standard deviation? Anybody? So for example, I give you two curves. Tell me which one is having the higher standard deviation. Higher standard deviation curve is which color, black or red? Where do you observe higher standard deviation? Right? Very good, guys. First one, right? Black. Those who are saying red, so please pay attention. Standard deviation is spreadness of the data, right? So how spreadness means amount of variation. So standard deviation, and you know why do we need standard deviation? Because can you see that the mean of the data, the peak of the data is same, right? So just saying mean, median, mode is not enough a lot of time, right? It's all same, but these two distribution are quite different. So the reason is that why standard deviation is required, because standard deviation talks about the amount of variation or dispersion, also known as dispersion, or also known as spread of data. Amount of variation or dispersion of data or spread of data. So you guys can clearly see that this guy, the black one, is like quite varying, and the red one is like less varying. If you look at the similar range, that's why it is. Okay. Now, guys, there is a probability density function for the standard normal distribution. So what happens from the mean? It's definitely from the mean. So probability density function. Now you might be wondering what is it? Don't wonder much. I'll just use this jargon for you, although it should have been with you, but I can't do much about it. Probability density function is actually a mathematical function to represent the any distribution. So for normal distribution, you also have a probability distribution function, density function. Those who have done a little bit of random variable, they know that. So it is actually a mathematical equation, and it's a very ugly equation, guys. I love it, but you can hate it. 1 upon root under 2 pi, sigma is outside, e to the power minus half x minus mu by sigma whole square, where x can be between this. Doesn't look close. Yeah, this looks better. Okay, guys. Now this is your normal distribution. This is not standard. Now the problem this guy has, this is normal distribution. Sorry, guys. Normal distribution. Now, giving a little idea. Suppose you talk about a normal distribution curve, and this is how it is. P. I hope everybody knows this. The area under this curve is the total probability. Come on, right? If it represents all the different probabilities, the total data will have probability equal to 1. I think this is common sense. So then if it is symmetric about, let's say, about the center, then can I say that this area minus infinity to 0, let me take some time to shade it. How much this will be probability value? What is the area under this curve? What is this area? If total is 1, what is this area? Similarly, on the other side, you can say, what is it? You tell me. Another 0.5. So total is 1, right? So far with me, guys. Hello? Total is 1. 0.5 is 1. Since it is symmetric, it is easy to do some of these juggling. So you can say minus infinity to 0, Akash, it is one part, and 0 to infinity, it is another part, right? When it is symmetric. But look at this. Suppose this is a distribution, right? This is also normal distribution. It is like skewed distribution. Ideally, people don't say this is a normal distribution. Let me also tell you this. But let's say the distribution is not symmetric. Let's say this is the 0 here. See, about the peak, it is symmetric only, but it has shifted. Can you see that, guys? Hello? Are you with me? Now, this is not at 0. It has shifted towards right. Now, you tell me, if I ask what is this area? Minus infinity to 0. Minus infinity to 0. What is this area? Will it be easy for you to calculate? I think no. Because to find this area, and if you have done a little bit of maths, it means that you are going to integrate this guy from minus infinity to 0 dx, and you will die doing the integration. Very good, Aryan. You got it. You got my point. So statisticians, mathematicians, they agreed that, boss, we can't do it all the time. So they said, why don't we normalize this, make it a standard normal distribution? Doesn't matter what data we are getting. End of the day, we are going to make it look like what you see on the first one. And that's what where we got the normal distribution to the standard normal distribution. Are you guys able to follow me? Because who will be doing this integration, right? It is doable, but it's not easily doable. So they thought, why don't we introduce standard normal distribution, which is in Python, you must have heard this like, oh, I'll standardize the data. Have you heard this word? Normalize the data. The data scientists, they keep telling this all the time, which is overused or abused. But what is the interpretation of it? It means that you will take all the x value. Then what you will do, you will subtract the mean and divide by sigma. And you will call a new variable called z. And this is where I introduce the z score. Are you guys able to do? Have you ever observed this at some point, x minus mu by sigma? So basically what you're doing, you're taking the whole data, subtract the mean and divide by sigma, means normalizing by sigma. This is known as, z value or z score, right? And what you're going to do with this, the idea is that if you take this and find expectation of z, which is like expectation of x minus mu by sigma, this is a little bit coming from random variable. So please excuse me for that, but I want to show you. So if you do the maths, it comes to be expectation of x minus expectation of mu 1 by sigma. Expectation of x is also average. If you remember what I've given on the top, see here. So using that, you write this as mu. Why I'm using curly braces there, sorry. And then expectation of anything constant is also mu. Cancel madi. So this is coming to 0. So the beauty of z score is that expectation of z is what? 0. Which means that mean for standard normal distribution is always 0. Mean for standard normal distribution is 0. It is a calculated mean. Always know it's not the natural mean coming from the data. You have standardized it. So don't miss this step in the whole scheme of things. I'll take a pause here, guys. You have done this extra step on your data to normalize it. And that's the reason that your expectation of z is coming to be 0. And likewise, sigma will come out to be 1, which I'm not deriving because it will take me to the intensive calculation on random variable, which is not there for you. Okay. Let's not go too mathematical actually. So far with me, guys. Now you might be wondering what is the benefit of this. So benefit is there, no? The moment you do this, you started with fxx mu sigma equal to 1 upon root under 2 pi sigma e to the power minus half x minus mu by sigma whole square. Now what you have done, my dear, you have taken this guy and you have calling this as z. Focus. So now suddenly what's happening? The transition is happening, and I'll write it will become fz. Z mu becomes 0, sigma becomes 1. And then you will write 1 upon root under 2 pi. Sigma is 1, so this will be a shorter one. E to the power minus z square by 2. Guys, does it look simpler than the one which I just showed you? So right, your equation gets simpler and you can generate a table out of it, and that's where you're going to use it. So when I say table, then you will be looking at something. This is known as just for table. So now if you see, guys, if you look at, z equal to 0, which is here, this is 0, okay? So all the values of, z is coming here, okay? On the left, why it's not picking it up. All the values are coming on the left. Then you see z value 0.1, 0.2, 0.3. And you have another set of values which are decimal values on the horizontal line. So you have two lines, vertical line and horizontal line. Let's say I'm trying to find a z score for, let's say, some value. Like, let's say, what is the z score for 1? So when the moment I say 1, it means that from 0 to 1, what is the value? So 0 to 1, how will you find? You can clearly see that this is your value. What is that? 0.3413. It's your probability. Okay. Don't get me wrong. It's your probability. Okay. So let's say if I fit a normal distribution curve, I take an example to make you understand this table and you will definitely appreciate it. Let's say this is 0 and this is 1 and this is -1. I'm interested in finding the mu plus minus sigma. Guys, this is mu plus minus sigma. Na? Mu is 0 and sigma is 1. Everybody, keep talking to me. This is challenging, I know, but don't give up. Mu plus minus sigma. Basically, you are trying to find 0 plus minus 1. Now, to get it, you can also understand that this is symmetric. If you find 0 to 1, you can also get the whole thing. And as this example say, this always talks about 0 to z, right? So 0 to 1, if I say, already I identified it. See, z 0 to 1 means in the chart, you have to find 1. What is the value for 1? Z equal to 1. What is this value, my dear? 0.3143. And since it is symmetric, it doesn't matter. The z value for -1 to 0 will be same. Why area-wise if you look at that? It's not in this table. Do you see any negative value -1 or not? No, right? If you do the total, are you seeing a number which is very much familiar to you? Let me show you in case you are not able to recall. What is this number, guys? Mu plus minus sigma, 68.27. Are you able to almost getting the same? In percentage, what is it? 68.26% of the data. Interesting, no? So this table works, right? This table works. So what you can actually calculate and find and then answer, you are getting right point. Make sense, guys? Why it is 50%? Then this reminds me one of my cousin. So he was solving a trigonometric question and he was supposed to find this angle. So you're supposed to find this angle. And then what he did, he drew this extension. And then he was thinking that this will be 60. So this angle will be 180 minus 60, so 120. So that's exactly what Aryan is doing. What is the basis for this? Are you observing it with the line? You're not looking at any condition, what angle, what is the triangle shape, right? So exactly you're doing the same. You have to go with the concept. The concept says that if it is 0 to 1, how will you find 0 to 1 in a Z-score table? You will go and find what is the value for 1. Because this table gives you from 0 to Z. So suppose you want to find 0 to 1, I can see that 0 to 1 is this. Then you might be wondering, what is this? You should ask that, what is this? What is this? So suppose you want to find till 1.5, right? Or let's say you want to find 1.05. How will you find 1.05? So you'll take 1 here, my dear, and 0.05 will look at here, and then you will draw 2 lines, and then where it is intersecting, that's the value. So what is the value, guys? 0.3531. Are you getting how to use this? This is for decimal places. Okay, got it? So let me take this. Top 5% of applicants as measured by GRE scores. Top 5% of applicants as measured by GRE scores will receive scholarships. If GRE is normally distributed with the mean 500 and the variance, 100 square is variance, my dear. Right? Sigma square is variance. So sigma is 100. This is like being smart. How high does your GRE score have to be to qualify for a scholarship? A real question, guys. We're trying to estimate it. have to be to qualify for a scholarship. So this is for all those guys having American dream, going to US, going to US university, get a job, learn there, study there, and settle there, right? So they write GRE exam. So did you understand the question, guys? You have a normal distribution, mu is 500, sigma is 100. And they're asking that what should be the value, what should be the GRE score to qualify for a scholarship? You will not be able to do this right now. Let me do it for you. So guys, definitely when you look at this, it's a normal distribution. It's not a standard normal distribution. It's a normal distribution. Because why it is not a standard normal distribution? Anybody can answer that. Let's see who is still, awake and not sleepy. How do you realize that it is normal distribution, not a standard normal distribution? Come on, Janta, let me know. What is in standard normal distribution? What is the value of mu? Is it 500? It's very good, Soumya. Expected from you. It's normal distribution, right? Because mu is something non-zero and sigma is also not 1, it is 100. So it's normal distribution. Now, I needed to convert into standard normal, right? So standard normal I have to get into. How will I get it? I'll calculate Z, which is x minus mu by sigma, which is basically x minus 500 by 100. Right, guys? So far with me? Now here we'll need a little bit of help on from the question itself. They'll give you in the question itself that if you talk about that I need some data about the threshold, this threshold will be given from the data itself. And it's given, right, that 5% of the applicants are going to, receive the scholarship. Like, if you are having 96 percentile, 97 percentile, you're going to get the scholarship, right? Remember, those who have written CAT exam or any exam which are having percentile. Percentile means, suppose you are at 99, what does it mean? It means that 99% of the students are behind you, right? So similarly, for 95%, this is your 95%, the whole of it 95, and the small part is your 5%. Let's say this is your 5%, and this all is your 95%. So those who are going to be in the pink area, they are going to get the scholarship. Hello guys, so far with me? So the major chunk is 95. Obviously, majority doesn't get scholarship, right? So far with me? 5%. Now this 5% cutoff will be given by the question itself. Generally, when I'll teach you confidence interval, hypothesis testing, right? So I will give you this. Don't worry about it. That 95% means you have a probability there. And that probability is going to get converted into a Z score, and that Z score will be 1.65. For the time being, just remember it. So alpha 0.05 gives you the alpha cutoff, right? And for this corresponding Z score is, for now, you just take it as a value. Later, I'll explain everything. Okay, it is 1.65, right? What is this coming? Because this is your confidence interval cutoff, and this is where the magic happens, okay? So for the time being, I'm just saying again and again, forget how I have reached to this, how they have given you this number. Later you will see. So now you have the Z score cutoff. Anybody who is having higher than this value will get the scholarship. So 1.65 x minus 500 by 100. If you calculate, it will come to 665 guys. Hello. So anyone who is scoring more than 665, they'll get a scholarship. Guys, are you able to follow this question? So you might be wondering that how do you know that? Because see, if this is your cutoff, which is 1.65, then as you go towards the right, this value will increase now, right? So Aryan, buddy, the question is how high does your GS score? When I say how high, means how minimum you have to maintain to get the scholarship. Higher cutoff, they're not asking, they're asking the cutoff, right? Suppose the qualifying marks is 665, you'll get the scholarship. Ideally, I use this table for getting this more better. So this is like, the problem is that this chart is that this chart can only be used, and that's why we'll not use, when something we are measuring from 0, right? Guys, remember they're saying 0 to Z. But if you are trying to do from minus infinity till here, right, this value. So then you should use this minus infinity to Z, right? This is the most appropriate chart. Now you tell me, where is 1.65? So this is 1.6 and 1.65. Now let's see. So this is a value, and the closer values are this. Now you are making sense, guys. So it is coming to what? Either you take this higher cutoff, 95.05, right? Now, guys, let me talk about important things, which is, I feel, the first question I generally ask, moving away from descriptive to inferential, is that what is the difference between descriptive and inferential statistics? Anyone? Anyone want to take a shot at this, answering it? Inferential is conclusive, descriptive is unbiased measurement. Okay. Very good, Pulkit. In descriptive, we'll be doing things on population. What even with things like you're finding mean and all. And then what we will do in inferential, sample. Very good. I think you've gotten it. But someone has answered in terms of what you will do with what, right? But what is the key difference? Descriptive. If you go with the literal meaning of it, describing your data. Now that data will be population or sample, that is another discussion, right? But if you are summarizing and presenting the data in a meaningful way to describe it without taking or making or generalizing any inferences based on the presented data, which Aryan has also mentioned. So inferential is conclusive. So if I can give you some pointers, guys, okay? So descriptive, if I may write, descriptive statistics, I'll just write stats, involves the summarization and presentation of data in a meaningful way. It's not like it's good for nothing, just it describes the data, So what is the primary goal here, guys? Primary goal or objective is to describe the data. Obviously, with the help of mean, dispersion, measures of central tendency, leveraging, measures of central tendency. What is that, guys? What are the measures of central tendency? Mean, median, mode, right? Must have been taught. Measures of dispersion, right? Spreadness, variance, standard deviation, right? Measure of shape. What is measures of shape? I hope you must have been taught. Skewness, kurtosis, right? Etc. Prabha is saying inferential is used when you want to make prediction or generalization about a population based on a sample. Yes, that's the application of inferential statistics, right? Why do we need inferential? That's the answer to that question. We are still understanding what's the difference between what is what. So guys, definitely all of the answers which you have given is correct, that descriptive is all about population, inferential is all about sample. But one thing which is very much, you have to be very much clear about that descriptive stats do not make any inferences. Okay. That's why I have a separate branch altogether. Do not, draw conclusions or inferences, but it doesn't mean that you will not find any logical conclusion, right, to our end point. It does not draw any conclusion or inferences beyond what is presented in data. So basically means what? Generalizing it. What you see in the data, you tell it, right? It's an unbiased approach. So I'm very happy to see some amazing answers from few of the folks. Are we good, guys? Everybody's clear, descriptive. Then I'll go into inferential. So this is what descriptive is. Now I'll get into inferential. If you remember in school days in the English MCB main course book, those who have done CBSE, they would know. I don't know if it's still there or not, but I'm talking about more than a decade ago. So when I was in class 9, 10, right? So there we had a book called MCB, main course book. There they used to give some, 5 or 6 lines, right, in the paper, in the exam. And then they used to ask, what is the inference of this, these 4 or 5 lines, right? Remember, somebody remembers that? And then they used to give 5 option, 4 option, one would be correct, right? So obviously read those 4 or 5 lines, right? And trying to make some conclusion on inferences about it. That's what you must have done in English, but it's a similar kind of situation for statistics as well. So inferential statistics, as the name suggests, you draw some inferences, right? The literal meaning of inferences is conclusion, some generalization. So I'll also keep talking and write so that I can save some time. Involve making inferences. And once you have done the inferences with you draw some conclusion. About a population based on sample data. And that will be random sample. There are numerous ways of doing the random sampling. So what is the goal? The primary goal is to, sorry guys, I'm writing after like 3 weeks or so. Can you see that the handwriting has gone for a toss? So that's how practice is important in life. The goal is to generalize findings or insights from a sample to a larger population, right? And then you also have some techniques there. Leveraging, what are the techniques generally we use, guys? Like as simple as doing hypothesis testing, right? So you actually form a hypothesis and you test it to come to a conclusion, using confidence interval concept, right? CI concept. And you will love it the way I'll teach you, I can promise. As simple as running some tests like t-test, right? ANOVA, analysis of variance, etc. Okay. So this is my introduction to the difference between these two guys. Now, at least we have come to a point where we know that descriptive is all about generalizing the data. Sorry, describing the data. Inferential is all about making inferences or generalization about a larger data set from a sample of those, right? That is clear? If that is clear, guys, so then I'll give you a movie recommendation. And this is just one summary, which I have already written. I don't want to write. See, so if I have to summarize it in a nutshell, descriptive talks about describing the visible characteristics of a data, which can be a population or sample. So not always be like stubborn, I'll only do population with. You can also find descriptive statistics for sample. Who is stopping you? Meanwhile, inferential talks about inferences or generalization. Look at the green highlighter. About a larger data set based on sample of those, and that sample will be random. There are a lot of samples, stratified, strategic, random, simple random. There are a lot of things are there. So whenever we talk about sampling, so sampling is very, very important for any inferential statistics, right? Any sort of test. You cannot test everybody. So let's say you are looking at a population, which is, the country population. India has how many people? How many we are? 1.4 or we are now 1.5? How is it? Prabha, you must know, right? 1.4, 1.5. What is it? 1.6. Okay. So 160 crores. Okay. So let's say if I try to measure something, 160 crore people, this will be quite a lot of data, isn't it? If you are referring to what is India's population in 2023, I think it is saying 1.43 or 1.44, not 1.6. So yeah, it is, you're right, Arun. We are close to 1.4243. Anyway, so doesn't matter for my example. Suppose I ask you to go and talk to everybody and ask their mathematics marks, right? And give me the mean of maths for Indians who have studied maths, means except those guys who are in, let's say, and grade wise. So grade 1, average marks, grade 2, grade 4. Do you think it is even possible to do that? I think no. I'm asking you to go and talk to everybody, right? Okay, let me take a recent example. Election just concluded, right? You must have heard about exit poll. One of the famous things happens on media. Exit poll. Anybody has any idea? Exit poll? Exit poll is like they do give you, agencies, they do the polling and they do the random polling, random sampling of the voters. They ask in a constituency that, okay, tell us. So let's say there are three parties, party ABC. Whom did you vote for? They don't ask. They have a very amazing set of questions, they call questionnaire, and they go and they do this survey. But do you think is it possible to, let's say, just so I was in Indore, so MP Indore, let's say we go to Vijayanagar. Anybody from Indore, say hi. So let's say an MP election just concluded. Suppose this is a nice place in MP Indore. So even for a Vijayanagar population, let's say the population is maybe let's say 20 lakhs. Okay. Hypothetically, I'm just making some numbers. Is it easy to go and talk to everybody who are 18 plus who can vote? We can vote 18 plus or 21 plus. My GK has gone. I think 18 plus is the voter. This is really, sometimes mathematics, we keep talking about normal distribution, but I don't know. Kids will laugh at me. Anyway, so 18 plus guys can vote. You're not going to ask all the voters that whom did you vote for, right? It's not possible. So what this agency do, guys, agency do the random sampling of voters. So what they do, they are going to do random sampling of voters. And if I'm correct, they also pay the one who participate in it, but they never accept it, by the way. So agencies do random sampling of voters. They'll do in Vijayanagar and ask a set of questions to gauge the sentiment, right? Ask a set of questions to gauge the sentiment and tie back to which party these guys voted for, right? And then what happens, they prepare a nice summary. And if you have seen, and I think I can get a screenshot also, exit poll MP 2023. You must have seen something like this. I cannot show you who is getting what, but I can definitely show you how does it look like, right? Have you seen this? So can you see, if I take the first number, 120 to 140, let's say this is party A, party B, party C, party D, whatever. It seems that party A has a clear majority in most of the agencies. So what is this 122 to 140? What do you mean by that? So these agencies, what they do, right? Let's understand the process. 120 to 140, right? Is the range they are given. Isn't a range? That minimum party A will get 122 seats and maximum they are going to get 140. This is what we call it as confidence interval. Interesting. So we have been seeing these exit polls for long. This is known as confidence interval, and they give a confidence score also that we feel 95, we feel 95% chance is that party A will get these many seats. This is known as confidence interval estimate. It's an estimate, right? Because you are not talking to everybody. You are talking to a sample of people. You are asking those questions, right? You are asking those questions and you are coming to a conclusion that, okay, party A will get these many seats. Because don't forget that you did some sampling here, right? This is how sampling looks like. You go to a constituency, you will pick and ask questions. This is your sample, right? And then you come back to generalize something about that population. Makes sense, guys? Everybody? Now, what is the difference between point estimate versus confidence interval estimate? So just to, give you a little idea, and then we will pick it from here as well. Pick it from here tomorrow. Point estimate would be like, okay, I will say party A will get 130 seats, period. Hey, you are not Rajnikant, right? You cannot exactly predict it. 130 seats. Astrologers do that. I think party A will get 130 seats. It is a point estimate, one value, single value. That is like, getting the mean. Generally, people say this will be the mean of the sample. And then I am saying that this will become population. So mean of the population I am predicting. So on an average, I feel party will get 130. But tell me, getting 130 correct is tough or not? Tell me. If the party gets 132, you're wrong. If the party get 128, you're wrong. Are you feeling it, guys? So point estimate, you cannot, put a confidence to it. So that's why statistically, we generally go with confidence interval concept. Now, if I'm getting 132 or 128, still both the options are going to fall in here. Hello. And your analysis is still correct. That happens with clinical trials in vaccines as well. When the COVID hit us, so a lot of vaccine trials would have happened. And I'll take that example. I talked about that case study that vaccine trials, right? Vaccine trials are not going to be 100% accurate. And when the pandemic happens, right? It's a mahamari. It's very tough because you're running against the clock, right? You need to get a vaccine in the market. So you cannot be like waiting for 99.99% accuracy, right? You will go with some confidence interval. Generally, they use 95 because it's related to health. You cannot administer something to someone who are having some comorbidities. They might die, right? Rather than they die with the virus, they die because of your medicine. So you have to be very careful. But they do all those clinical trials to come to the range of efficacy. So that's what is the efficacy of the medicine. How effective it is, it's a score. So that score, if it comes in a threshold, you go and release the vaccine in the market. Hello? And then you put in the batch production. Are you feeling it, guys? So that's the difference between the point estimate and the confidence interval range. I'll deliberate more on it. But point estimate does not provide a room of error. There's no margin of error. 130 means 130. But confidence interval does provide margin of error. You can make mistake. And that you can also set it up. Suppose you say 80% confidence interval, then your range will be like 100 to 140 or 100 to 160. Are you feeling it, guys? Then you will say that, what is this? You cannot have this much of range, right? 100 to 160, and then some party will, the majority is like only 60, let's say. Majority to form a government is 70, and you are putting a range of 100 to 200. Error cannot be the majority, right? Are you getting my point, what I'm saying? Let's say to form the government, the majority is like 70. You are putting the range of 100, that the gap is 100. So that's not an appropriate study. So that's where range, how much we should keep a percentage, 95, 99, 90. Generally, these are the confidence interval levels, 95, 90, 99. In any exit poll, they follow a very good set of approaches to come a number, which is your confidence interval. That's what they show in the TV, which you are seeing, right? And they also claim that my analysis depends on blah, blah, blah thing, right? That's why if you see, some of the guys are like rock star. Can you see these guys? I am telling you, you'll get exactly. This is like EDA. They must be new. So definitely these are the top players, right? Sea Water I have been seeing since my childhood days. But this is like new nation, whatever. Can you see that? They are giving the point estimate. I just realized that. So I don't know. Definitely they're wrong because looking, there's no range. So even 90 is not, they will say, okay, it's close to 86, but that's not how it is.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
So for the exit poll, a point estimate looks like, let's say there are 300 seats. So now I'll take my own example. You have three party A, B, party C. Let's say you are saying party A will get 180 seats, party B will get 80 seats, and party C will get 40. Total to 300 if you do the maths. This is what we call it as what? Point estimate. What point estimate? You are giving a single value that this will happen exactly the same. So there we don't have any, margin of error, right? But on contrary, if you go to the other side of the story where we are saying we'll talk about, so this is point estimate. Let's say we talk about confidence interval. So what we do, we add a margin of error to the point estimate and we develop confidence interval. And then we have different levels of confidence that, okay, you will say 90%, 95%, 99%, which one you are going to say. So for example, if I look at party A, so I'll say, okay, party A will get 170 to 190 seats. So let me rewrite this, party A, party B, and party C. Let's say we say party A would get 170 to 190 seats. So what you have done, my dear, that you have added a margin of error. You have added a margin of error. Obviously, it's still the mean, the average is what? 180. But you are not saying 180, you are saying 170 to 190, which means that you are going with certain alpha. Let's say alpha is 95% confidence. Don't worry, I'll explain that. Alpha is, 95 means 0.05. You have to do opposite. And alpha is known as level of significance. This is a jargon for you as of now, but I'll explain. Similarly, for party B, you will say, 70 to 90. Party C will say 35 to 45. Something like this, right? This is known as interval estimate, confidence interval estimate. You have a range there. So I have a very good example to give you the definition of confidence interval. I always show that. So, and you will love it. Can you see that? So there are two people, right? There are two images. Can you see that? So I have already kept the concept and notes here. But if you see here, look at the first point estimate. Let's say you go for fishing, right? You go for fishing and you're using a more like a spear to fish, right? So you think that, oh, I'll just, hit the fish with this, right? What is the margin of error in this? Quite a lot of, there's no margin of error, right? Means you have to make a mistake. Chances are very high, guys. You agree with me? Then there are another image on the right hand side that talks about confidence interval, that you have a fishing net. Tell me which option will give you more number of fishes. Chances of you get a fish, obviously the net one, the confidence interval, because it will place you in the range. Chances are very high to compare against with that you will get exactly that fish. So this is a very cool image to understand that confidence interval, refers to the probability that a population parameter will fall between a set of values, right? And that set of values is like your range, your interval, and that will fall for a fixed or certain proportion of times. So when you say 95% confidence interval, what do you mean by that? It means that if you do this activity of exit polling, 95% times I will fall in this range. Hello. I will not be in this range for how much time? 5%. Means still there will be some error, there will be mistakes, but it will be 95% within the range. Hello, guys. And you will be 5% outside the range. Means mistakes has been done, means your exit polling gone wrong. Are you getting it? So that's how you define confidence interval. So it's okay, I'll explain again, Anthony, but why don't we look at this image? So see, this is a normal distribution curve, and this is 95% confidence interval, which I mean to say alpha is 0.05. Again, look at this. And you can clearly see that if alpha is 0.05, so it is two tail. So you have divided this into alpha by 2. So one is for the left tail, right? If you do alpha by 2, how much is that, guys? 0.025. In percentage, it will be 2.5%. Similarly, for the right tail, you have alpha by 2, so 0.025 equal to 2.5%. Total is 5%. So if you look at the limit, right, this is your upper limit, this is your lower limit. What we are saying that, let's say we gotten a population mean, right, and we say that the population mean, we are trying to estimate, there is 95% chance, listen to me, 95% chance that the population mean will fall between what? These lower and upper limit. 90%, 95% chance is your population mean will fall between this. This is your confidence interval, right? Just like in this example, I had mentioned that let's say your mean is 180, and when I give a range of like 170 to 190, I am sure that 95% times you will get a value 180 lying in between this range. Clear? This is for Anthony. Don't worry, I have given you the formula, derivation, everything, but did you understand the concept? Now moving on to Prava's question. Prava is asking, point estimate is used in which cases then? Because CI has a broader approach. So whenever you are interested in getting a single value, Prava, right? You are not interested in giving a confidence interval. You can go and use it. For example, let's say you want to estimate the average height of a population, right? You don't need to really go and give them, let's say estimating average height of a population. So in this case, point estimate can be might be the sample mean height, right? So you take a sample, you find the average, that will be your point estimate for the population. Okay. Now, whenever you want to add, and that's exactly being done now. You have taken a sample in the exit polling also, right? Remember? And you have done the average number of seats I feel from the sample it should come. This is a point estimate. So it's not like that point estimate is not being used. You are using point estimate in the more like a first step. And that becomes the base for your confidence interval, which you will realize that let's say if I have a average sample height, let's say some value X, right? Sample mean height or sample average height. And now you want to, rather than you want to represent this into a confidence interval manner or confidence interval representation, you want to say, oh no, I don't want to say average height. I would like to say 95% confidence that the true population height is between the lower limit and the upper limit. So it's more likely to, go from point estimate to confidence interval when you want to give a more like a certainty of getting a value, right? If you are not going to give that certainty of a value, you just want to estimate it and just say it out, you can use sample mean, and that's where point estimate can be used everywhere. You're getting my point? It's not about that it's like A versus B, it's like A, and then how we can add a layer of certainty to A, and that becomes your confidence interval. Point estimate, single value you are estimating. Confidence interval, when you want to give a range of values and showing that, okay, you are 95% sure that, it will fall in that range. That's how you should take both these guys. Cool. So now, why don't we get into some questions then? How to calculate confidence interval? See, I'm telling you mathematics behind the scene as well. Generally, trainers will just show you this in hands-on by using Python codes. I'm teaching you how to calculate manually, right? Just taking a pen and paper. That's the difference. Now, guys, you always remember that you have a Z-score for different confidence level, okay? Confidence level is different from confidence interval. Always remember that. So this is your confidence level. This is as good as saying your 1 minus alpha, right? So 95% chance is 0.95, Z-score is 1.96. And you can see this in your, right, 1.96, now. So 1.9, where is 0.6? Here. So you can come here, see. So what is the value you're getting, guys? 0.9750, right? You are here. And this is your 2.5%. Do the maths. If you subtract 1.9750, you'll get 2.5 in percentage. And similarly, we'll have other 2.5. So are you getting 1.96 means 95%. 95% chance, right? So these are the values you should always remember. It should be on your fingertips. So once you have the confidence level and the Z-score, so the formula becomes, to be honest, very easy. So the formula says, let me give you, confidence interval CI is equal to X bar plus minus Z S by root under N, where X bar is the mean, sample mean, Z is the chosen Z value, right? I'll also give an arrow to take you the right place. Yeah. S is what, my dear? S is your standard error. Standard error. It's not standard deviation, it's standard error. I'll come to that. And N is the sample size. So what is going to be upper limit? It is going to be upper limit for confidence interval X bar plus Z score S by root under N to multiply. What is going to be a lower limit? Confidence interval X bar minus S by root under N. So now, guys, this is known as standard error of mean. Okay. Let's talk about a little bit more. Standard error of mean. So what is the meaning of it? So let me write one line and you'll understand. This is a measure. Again, this is equal to a standard deviation only, but not like typical standard deviation. You have to always say standard deviation of what? So this is measure of variability associated with sample mean when it is used to estimate the population mean. You will not get anything. I know that with these word. Okay, I'll explain. So suppose you have a population, right? This is your population, and you have a sample. This is your sample. And you can have multiple samples, right? Every time you will get a sample mean, guys. Sample 1, sample 2. So far with me, guys, right? If you do that random sampling, population mean is not going to change, right? Let's say this is your mu p, mu population, mu pop. So every time the delta between mu pop and what you have estimated, there will be some number, let's say A, mu pop minus x2 bar, B, mu pop minus x3 bar, C. Hello? If this delta, if you find standard deviation for ABC, that becomes your standard error. And dot, 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 dot. Are you getting that measure of variability associated with the when you're trying to estimate? Okay, the difference always. Okay, that becomes your standard error. Are we clear, guys? And I'm going to give the formula C. Right? Correct, guys? So obviously, you can see what I was saying, right? Xi is your different sample mean, and you're finding that. So what we are trying to do, we are finding x1 minus mu, x2 minus mu, x3 minus mu. No, this is a different formula. So we are not actually subtracting from standard error. We are not subtracting from sample mean. As for this formula, what we are doing, I'm just also contemplating that only somewhere, that sigma divided by root under n. Yeah, so that's correct only now. You are right, you are right. So n is the sample size. This, what I've written, this whole thing is your standard error. You're right, you're right. So this S, okay, let me update this because then you will get confused. You're right. This whole thing is your standard error. This is your standard error. But guys, I think this is something I need to just validate, but this is the formula of standard error of the mean. There is no doubt about it. Okay. Standard error of the mean, but I'll validate it. Okay. For the now, for the time being, just hold on to that. Okay. This formula can be a little tricky time to time. And what is n, by the way, guys? N is the size of the population. Rest terms, you know, right? Rest of the terms, you know. But I'll get back to that again. I need to validate from a. So every time all the resources will have, you know, S by root under n is the standard error of the mean. Okay. Every time, some of the times, you know, the portals are not that great. They also make slight mistake in the formula, not concept. But this is how we go about it. For the time being, guys, let's go into the question so that we have a certain idea that how do we calculate confidence interval. Okay. So let's say if I give you, and I can give you like an example rather than calculating it. So for example, not a question, but for example, if you look at confidence interval, suppose I say sample mean is 86, Z is 1.96, and standard error is, a standard error of the mean is 6.2 by 46 total, right? 46 your sample sets. How will you do it? This is your sample mean. X bar and mu are not same in Rani. Mu is for population mean, right? This is for population, and X bar is for sample mean. They are not same. Okay, so don't get confused. Come on, guys. How will you calculate it quickly? Yeah, you have to calculate the margin. So give me the upper limit, give me the lower limit, and tell me the answer. Do the maths. By the way, guys, tell me one thing, and maybe Soumya, you only tell me. What this is standard error of the mean, but what is this S? This is your sample standard deviation, right? I hope you guys know, right? And the moment you divide by root under n, it becomes the standard error of the mean. Okay? Standard error of the mean. So that's the difference. Okay, by the way, come here. So what is it? 86 plus 1.96. Why you guys are thinking so much, right? 46. Come on. Someone can give me this, or I can write myself 86 plus, and guys, this will be root under now 46. I need help now. I cannot calculate this. Root, I don't know, I can take it in one note. But guys, anybody has solved it? I have the answer, so you can help me. This is root under. So I have the answer for the upper limit as 87.79. Anybody who gotten this? Yeah, Siddharth, very good. So this is what you will get. For the lower limit, you have to do the same thing. And it should be 84.21. Right? So if you look at this formula, guys, x bar plus minus, z into s by root under n. This is your confidence interval. If you deliberate little more, you'll realize that as the sample size increases, right, confidence interval become narrow. It's obvious, right? It's a general thumb rule, right? Should become more narrow and vice versa. Right? Because you have more data points to get more exact answers. So your confidence level can be narrow and you can still achieve better accuracy. But don't worry, guys, I'll do some questions. Let me give a question here. In a sample of 40 light bulbs, the mean lifetime is 5,000 hours. Okay. 40 light bulbs, mean is 5,000 hours and the standard deviation is 400 hours. Compute a 90% confidence interval for the average lifetime of the bulbs. Guys, come on, get to it. And I'm giving you another question, and that will be your homework. Come on, guys. I can also help you. See here, whenever you're looking on any confidence interval, generally there is a concept of central limit theorem, which says that to apply any concept of normal distribution, you have to have your distribution normal. And that can only be possible that if n is greater than 30, which is your sample size, we can use, z-score equal to how much? 90%, right? So it is what? How much is the value? 1.676. Look at that table. 90%, 1.645, sorry. Z-score is what? 1.645. So if n is not more than 30, then you will not be able to use this. There are some rules. Now, if you use this, so you have the z-score, you have a sample size n40, you have mean lifetime, how much? 5,000. You have standard deviation S, sample standard deviation is how much? 400. So what is going to be your confidence interval? It will be x bar plus minus z score. Listen to me, guys. S by root under n, right? Someone should have done by now. So someone should have done it. How much is that? 1.645 into 400 by 40, root under 40. What is it, guys? What is the range coming out to be? Upper limit will be how much and lower limit will be how much? Please help me out. Then I can confirm the answer. So upper limit is 4895 or lower limit. Which one is it, Siddharth? Lower. Lower I am getting. No, I think I made some calculation mistake. What is square root of 40? I don't know if it will work. It works. Wow, this is good, yeah. Okay. So 400 divided by square root of 40. I can use it. axis. Cool. Wow, this is good here. Then what I can do, I can multiply 1.645 into this with this, right? So, and I also want to add 5,000 plus, right, guys? This is my one note equation. I'm getting 5104. Okay. I'll copy and paste. I'll just add a minus. And here is your 4895. I think you guys are right only, no? Sorry. So the answer is, so apparently my answer key is wrong, which I was looking at. 5104 and 4896, right, guys? Come on. So upper limit is, so that's why I don't trust these question and the answer keys. You have to be careful. But you guys are doing amazing. Hello. And this is a homework, guys. You can try it at your end. Answer again I can give you, but I'm not sure this is correct answer because I don't trust these sources. I'm only interested in the question, but this is the range, guys. If you're not getting it, whatever you have done is correct. Okay. So yeah, this is how, generally any statisticians, right, they come up with this kind of approach to estimate the population characteristics with the help of sample, right? So you can clearly observe in question like this, you are not looking at all the bulbs. Let's interpret it now. You're not looking at all the bulbs. You're only looking at 40 bulbs, right? And taking the sample mean of those bulbs, standard deviation of those bulbs, hours, right? And then you are coming with the confidence of saying that I feel all the bulbs in the population will either last 4896 to 5104 hours. Interesting, right? So looking at batches, you are coming and generalizing the whole, you are looking at this batch sample and then generalizing it to the whole population in that batch. So in manufacturing, you use confidence interval like anything, the quality assurance, the quality engineers, they use a lot. So if you are not finding a lot of issues, right, you feel that average lifetime is X, right? You can generalize and you can generalize it to the population. So using this sample mean and putting a buffer, which is your margin of error. This is your margin of error, no, guys? You forgot? This is your margin of error, right? And this is for you, Prabha. You were asking, right? What is point estimate? You started with what, Prabha? This is your point estimate, correct? Should be clear for everybody. Combining these two guys, you get confident. Okay. Indrani is asking, percentage of CI table from where we can get that, are those constant? You're talking about this 90, 95, 99. This is your confidence you want to keep, right? So you start with this, Indrani, right? That I want to be 95% sure or 90. This is your confidence on your manufacturing process or any activity. So this is not coming from any table. You come up with this score. Oh, I want to go with 90 or 95. And then you have a table, which I have already given, right? This one. And this is coming from the same jet score table. And then 90% confidence level gives you this jet score. So this you will decide or the business will decide, right? It's not coming from anywhere else. I'll talk about the next very important topic. Later on, guys, you remember I said n should be greater than 30, sample size should be greater than 30, then only we can use that score. But nobody asked me that what if sample size is less than 30? So if the sample size is less than 30, you will be using the t distribution and you will be using a t-score. So I'm giving a note because I have not talked about t distribution or t-test. But I'll give as a note. Please keep it with you. You don't need to write. It's going to be in the notes. So I'll write a note. Let's say we have one small set of data or one small set of sample, which is, let's say, n is less than 30, then t distribution in place of z distribution or normal distribution instead of normal distribution is used. Used to construct the confidence interval. Okay, guys, clear? So if the sample size is less than 30, then t distribution, and instead of normal distribution, so I'm going to highlight it as like pink, purple, to construct the confidence interval. That's how you construct the confidence interval when the n is less than 30. You have another t distribution, your formula will change. Your formula will look like this, my dear. X bar plus minus. Here you will bring t distribution or t score, t distribution score into same thing, S by root under F. Nothing changes. Only thing is changing is what, my dear? This Z score will be replaced with T score. Clear? Now I'm interested in more on hypothesis testing. Very interesting topic. Hypothesis, right? In India, people are always ready with their own hypothesis, right? Indians are opinionated. You guys agree with me? We Indians are very much opinionated. Right? We always have opinions for everything, everybody. So we have a lot of opinions. So we make a lot of hypotheses, and then without testing a hypothesis, we assume it is true. That's our characteristics, right? But you ask anybody anywhere in India, they'll answer something. That's the problem. So let's say you want to ask about where to do statistics course from, let's say, which college, and you ask this question to a commerce guy, right? Or maybe let's say a arts guy, BA, who's doing a BA, right? Arts. That person, the student will also have a lot of knowledge about that where you can do statistics in which college. I don't know how much you can trust that, but we'll get some colleges named from that person. So that's the problem. Okay. But hypothesis testing is not like, just form opinions. It's beyond that. It's a science. Okay. Even in our projects, right, we always come up with some hypothesis and we test with our data to ascertain that that hypothesis is correct or wrong. So a simple hypothesis can be that, which I always take this as an example, that there is a man who goes for a trial. A man goes to a trial where he is being tried. This is a very classical example I take. Where he is being tried for the murder of his wife. I know it's, discussing this example in the morning is not a good idea, but I'm bound to take this example, right? What do you guys think? What is your opinion, thoughts? Girls, ladies, let me know. Ideally, when I say this, without getting into anything, 95% will say, okay, definitely he would have done it. Guys, a man goes to a trial where he's being tried for the murder. The moment you see murder of his wife, living in today's society, we believe that this is 99% correct. But do you think, judiciary works on this principle? Do you think the judge in the court will behave like you? Never ever. There's a rule, right, in the law, and obviously I'm again, just like we Indians are opinionated, right? I don't have any idea about law and order, but I'm just reading some lines and telling you this is how they proceed any cases in the world, not in India, across the globe. And if you see the last few words, innocent until they have been proven guilty. That's how you have to treat it. But trust me, it doesn't work like this. And people have their opinions and they try to. That's why you must have heard about these words these days is media trial, right? And they influence everything. And the judge has truly honest here, right? Judge does not have any power. Trust me. Judge will only work on the documents and Documents is always under the administration. How they present it, what they presented, that is going to decide the fate of the case. That's how reality is. Okay, there's no emotion attached to it. But when I say this statement, a lot of people, if you go and say this in society, right, the moment something happens, right, 100% people will start believing that this man was that, blah, blah, blah. 100% he has murdered his wife. But this is a hypothesis. You need to test it. So if you want to test it, then you have to form two set of hypotheses. And that's where you must have heard in hypothesis, there is one known as null hypothesis. So you have to first frame null hypothesis. Now you tell me, guys, what should be the null hypothesis in this case? H naught. In this case, the null hypothesis is what? Not guilty. The code will proceed or initiate this discussion, right, with the guy saying not guilty. Right? At the moment, have you seen in the movie, right? I think we learn a lot from movies, but few things are correct. The judge will, just to save the court time of the court, they'll ask the person that, do you accept that you are guilty or not? Like there's a very typical language, right? The lawyer will tell you how to respond. If the person himself accepts guilty, then nothing to be done, right? So obviously he will be just punished for it. Agree? So that the first thing they ask to the person itself, that are you guilty or not? Do you accept that you have done it? If you have not done it, then the court will accept it as the null hypothesis. Null hypothesis means natural. Null means no change. Always remember that. Someone can ask this in interview. Null means no change. Tell me, do you really think that everybody, right, waking up and killing their wives? I don't think so. Right? Every man in the world, every day they wake up and they plan to kill their wife. I don't think so. Right? What is rare is you're going to be alternate hypothesis. What is very common to happen in this society is going to be null hypothesis. So what is common in this world? Like you sleep in the night, sleep during night. That's common. I know some, no, we are owls. We don't sleep during night. We wake up. We wake up in the 2 a.m. in the night, and then they'll sleep around 6 a.m. in the morning. So I'm not talking about exception. I'm talking about natural. What is natural in this world? You sleep during night, and you wake up in the morning. Guys, hello. You agree? That's your normal. Similarly, this is also normal that man is not going to kill his wife, right? This is normal. Still, it is normal. I know it's hard to believe it, but then the woman would not have got married, right? There's no point if you know you are going to die. So definitely this is all normal. That's why the hypothesis should be very carefully framed, right? Null hypothesis is not guilty because of this normal natural phenomena that nobody wants to kill nobody, right? Trust me, still this is the philosophy. And trust me, building hypothesis is a lot of philosophy. Then alternate hypothesis. Alternate will be what? There is some change. Change in what? Change in the normal behavior, right? And that will be HA. Sometimes people also write H1. So both these notations are there. And it looks weird. HA or H1, and it is going to be killed. And now you will start with the data to test this assumption that, okay, guilty or not guilty, and you're going to start with the whole data-driven approach to come to a conclusion. Are you clear with the example which I took to explain hypothesis? This is maybe not a good test, but this is a very cool example, trust me. This opens a lot of eyes. That, what you feel is not important. What is correct? What is the approach? You have to pick it up. You might feel something about it, right? But doesn't matter what you feel, right? This is how it is. Okay. Yes, we always want to prove the null hypothesis is true. If we are failing to do it, then alternate wins. Clear? So you lose the case. while trying it, right? And generally, when we say, have you seen this also a defendant? If you are getting convicted in something, so not convicted, sorry. If you're getting tried for something which you have done or not, still you will get a defendant, right? You are going to be defendant, right? Victim, I don't know what are the words, but defendant means that the person who is getting blamed, right? That person needs to be defended. So naturally, you feel that this person, even you can feel that, okay, he might have killed his wife, but you need to still defend that person because that's not natural for killing, right? A person. So null hypothesis is going to be the idea to win that so that you prove that person is not guilty. In case we fail to prove it, then he will be getting convicted and he will be getting the punishment. Simple. Anthony, are we good? Okay. So see, we were discussing hypothesis, right? So null hypothesis means no change, no impact on treatment, no change, nothing has been done. Okay. You're doing a test like in a pharmaceutical company, you are doing a control test group. What is the effect of treatment on your patient? If it is null, means no effect, right? So that's where comes your normal distribution. Sorry, comes your null hypothesis. Now, let me get into the little more of the details. You should know that hypothesis testing is basically an assumption, right? Always remember that. Let me give you as a note, else you will forget. Hypothesis testing, my screen is up, right? Is basically an assumption that we make about the population parameter. It's an assumption that this will happen, that will happen. Till the time you are done the test, complete testing, it's still an assumption. If I continue right, hypothesis testing evaluates two mutually exclusive statements. Correct, guys? H0 and H1. What is the meaning of mutually exclusive? Means if H0 is correct, H1 will be false, right, guys? Correct? Two mutually exclusive statements you are going to evaluate about population to determine which statement is best supported by the sample data. Now, how does hypothesis testing work, right? I want to show you. And to show that, I have to use an image. Let me show you this. This is very, very important, guys. Again, you are going to fit a normal distribution, right? You can see that this is for two sides, by the way. Can you see two tails are red? This is for two sides. Suppose you say alpha equal to 0.05, right? That's your level of significance. But tell me for alpha 0.05, alpha by 2 is what? I have just calculated. So in terms of percentage, it is 2.5, 2.5, guys, correct? For 95% confidence interval, you have alpha by 2 is equal to 2.5. So guys, if you look at this, I'll start shading. This is your happy region. That's your confidence interval, now, guys. This green shade, the bigger area. Come on. Keep talking to me, guys. You agree or not? See, this can be a little tricky. So you can always ask me question. Don't hesitate. Don't think that what I'm thinking about your question, I'm not thinking anything. Okay, I just want to answer those. This is a tricky topic. I'm trying my best to explain. See, this is your confidence interval region. You can say this is your happy region or CI region, where you will say that if anything which you're trying to test is going to fall in this place or not, right? Now, what happens now, whenever you're trying to form the hypothesis, I'm giving one example of hypothesis. that average height of the sample is equal to the national average height, which is your population height, right, guys? Come on. If you're comparing sample height with national average height, is your population height. So ideally, you will believe that average height of us, like let's say, and this is a sample, and the data you're looking like all the adults, male, between age 18 to 25, right? Something like that, or 20 to 25. You can decide the test. So you are saying that if you try to take a sample out of this population for the height of the average height of the adults male, we believe ideally it will be same. That's why it is part of what hypothesis? H0. If your hypothesis is true, listen to me. So you have a alpha. Always remember that. You have a alpha, which is your level of significance. Remember that. In this study, I have fixed it to 0.05. Now there are certain rules. If your p-value, which is denoted as p, is less than alpha, listen to me, less than alpha, sometimes people also write less than equal to alpha, you are gonna reject the null hypothesis. Listen to me. Don't worry how, why, I'll explain, you will understand. If your p-value is greater than alpha, you accept the null hypothesis. Is it clear, guys? At least can you remember this as a rule in your head? P less than alpha, less than equal to alpha, you reject. P greater than alpha, you accept. Simple. Abhi ke liye, just remember it. Sorry, I'm speaking Hindi. I know some of the learners will not understand a word, so should not do that. But yeah, sorry. P greater than alpha, you have to accept. Now the question comes, bro, I'm going there only. What is P value? So what is P value? Let's answer that. So P value is the probability. P stands for probability of rejecting a null hypothesis when it is proven to be true, right? So it is the probability of rejecting a null hypothesis when the hypothesis is proven true. If P value is less than or equal to, as it's written here, guys, let me highlight, P value is equal to or less than the significance level alpha, then the null hypothesis is inconsistent and needs to be rejected. I think that's the same thing I've written, guys. Here, if P is less than equal to alpha, you are going to reject the null hypothesis. But this is a little tricky. And Anthony, everyone, please hold on to your question. Let me explain. I'm not done. To explain this, I need to show you one cool example with the help of this chart. I think you are going to understand like this. Tell me one thing. I'm talking about two scenarios. Scenario number one, a dog bites a man. You must have seen some news in the videos, right? Where the pet dogs in the left, they are doing all the kind of nonsense things. Have you seen it, guys? Especially the residents or the delivery guys have been victim of the dogs, the pet dogs. So it is in our society also, but no such incident happened. But that is a very common phenomenon. A dog bites a man. Do you think it's going to be here or in the tail? What do you say? There are two options on the plate. Most likely observation, most unlikely observation. Very unlikely. It is going to be in the tail or it is going to be in the peak. Why it will be in the tail, Prabha? A dog bites a man is a natural phenomena. It will always be somewhere coming as a most likely observation. In India, every day a dog is biting somebody, right? It's a common phenomenon. The second phenomena I'll give you is a man bites a dog. The moment a man bites a dog, it becomes the breaking news. Very good, Pulkit. You read my mind, huh? A man bites a dog is like likely. Now, probably will understand why I was asking this. What do you think? A man bites a dog is very unlikely. It's like some psychotic behavior, right? That's how we put it. But I don't see this is going to be a common phenomenon, right? You guys agree or not? Hello? So it will be coming somewhere in the tail. Now it's clear, everybody. I'll take a pause. Right? Now you tell me, a dog biting a man is like a non-hypothesis. It's a normal behavior. To reject it, you have to come to the tail. Listen to me. A man biting a dog, you have to come here, and that is in the tail, very unlikely. So you will come here. Now let's say this is your p-value. I think this is your observed data point. This is your p-value. So I think this part of the chart, which these idiots have put, that's why sometimes I'm not happy. But see, this is a chart which I have gotten, but they're not doing a justice there. Okay, forget about what they have written. So these images I take it from the web, different places, but not everything is as per I would have done it. So forget about all this observed data point and all this, right? Now, you know that you have a cutoff, remember? And you have another cutoff here. Guys, don't forget that. At least you know this, right? You know that this part of the graph is your green region. Let me do my way. If there is an easy way to create these diagram and all, I would have done all myself. So now if you see here, this is the most likely to happen. That's why it's green zone. This is this purple zone where the unlikely things happen. Agree? Everybody so far with me? Don't lose it. Keep holding on the thoughts, right? Now tell me, this is your reason of what? 0.025. Remember? Alpha by 2. And this is also 0.025. This guy is 95%. And this guy is how much? 2.5, 2.5. Don't forget that. Okay. Now you have a alpha. Alpha is how much? 0.05. You are saying that if your p-value, probability value, is less than equal to alpha, you reject. Remember that. Tell me, p-value is probability value. This is going to be the highest probability. Look on the y-axis, right? So if this is less than alpha, your alpha is what? Fixed. You fixed it. Somebody asking me alpha is going to be fixed. Yeah, you fix it, na. Your alpha is 0.05, or for two tail, you will fix it to 0.025. Depends on you. But let's keep it for 0.05. If you get any value which is less than that, you will automatically land in this region. Are you feeling it, guys? Where you have the less probability? This is your cutoff. Less than means what? You are going in this red zone, na? This purple zone. Everybody, I need your yes, no, good to go, right? The moment you say less than 0.05, so see, if I can give you some numbers, then you will understand the beauty. Let's say this is like, 0.3. This is like 0.2. This is like 0.1. This guy will be like 0.05, right? If you go lesser than this, you will come more toward the tail now. Are you feeling it, guys? People don't feel, because they don't look at this. This is y-axis is probability only, no? Let me also tell you with so much confidence, you can go after this lecture, watch any video. It will be tough to understand, because these examples combining everything into one story or narrative will not find anywhere. Maybe one guy after doing 1 hour of search, you'll find. Obviously, I'm not there. So you'll find someone X, Y, Z, but it's very tough. Trust me on that. Understanding the p-value, understanding the alpha, and understanding where to reject visually. As Soumya mentioned, explaining this in visually is very tough. And if you're able to explain, it's very easy then. Because everybody gives some statement, some gyan, that doesn't help. Are we guys cool on this? Why, when I say this line, it means it go to this region. Everybody has gotten this. You can say no if you have not. Alpha is 0.05, which is your cutoff, or alpha by 2. What do you set? If you want to go lower than this, you will don't go there. Because what in our head happens now, you always think like a kid, x-axis, y-axis. Suppose this is your cutoff, let's say alpha. When I write less than equal to alpha, your brain automatically will push you back. Isn't it, guys? That's what always happens. The moment you say less than alpha, so sir, it will go towards the left now. But what is the issue here? The left is more probability because this is different from your normal XY axis, right? So here alpha is less on the right hand side. Again, always remember, this is the distribution. You are not looking the x-axis now, buddy. You are looking on the y-axis, deciding on the x-axis. That's why it is confusing. You look at the probability on the y-axis, where the probability will be less as you come down now, come towards the right or come towards the left. This is the highest probability, guys. This is the highest probability, this point. Clear? So that's why when you say p less than alpha, you reject. Less than equal to alpha, you reject. Because why do you reject also? Because it's a very unlikely observation. It's not normal, right? Again, I'll tie back to this diagram, right? A man kills his wife, right? Are we going to put here a man kills his wife? No, it's unlikely or likely. It's likely to kill a person? No. So I'll say a man doesn't kill his wife is likely to happen, right? And here it will be a man kills his wife. Unlikely. So now you understand why I say that not guilty is null hypothesis, because it is likely to happen. And being guilty is your alternate hypothesis, which will come here. Are we clear, guys? So if you observe, I have connected the dots. So now I will move on to the steps, typical steps in doing the hypothesis testing. Steps involved in hypothesis testing. So number one, null hypothesis means no change. It doesn't mean no assumption in running. You are assuming that he has not killed his wife, right? It means natural, anything which has no change in the behavior, right? So if you take my example, killing a person is not a normal behavior, right? It's not natural, right? Got it? So number one point, how to get into hypothesis testing. So first of all, you have to formulate it, you have to assign which one is going to be null, which one is going to be alternate. So formulate two hypotheses for analysis. Once you have done it, we'll move on to draw sample. So once you have done the hypothesis statement, draw samples from population for analysis. Obviously, it is for analysis, why do you need to write? Third step will be perform appropriate test. And there I will be teaching you mostly tomorrow. I think we have a couple of more sessions. Perform appropriate statistical tests or techniques. Right? There I'll teach you multiple techniques. Last step will be either accept or reject. Accept or reject. We don't even talk about alternate. We always talk about accept or reject null hypothesis based on evidence. So when you try to do hypothesis, you are bound to make mistake, and there can be type 1 versus type 2 error. You might have heard about this in statistics, hypothesis testing. You must have heard about type 1 versus type 2 error, very famous. So let me show you a nice diagram. Doesn't matter what you do, right? You are always going to make mistake. Trust me. Chances will be less, but you are bound to make mistake. And the moment you make mistakes, right, you are going to get certain error. Okay. So first thing first, let me explain you what are these errors. So number one, if you see, you are going to see two normal distribution curve, right? And if you see here, if you take this curve as the base, which is your null hypothesis samples, right? And you are thinking it is null hypothesis part, but if you look at, this is your any mean value you have estimated, like, if this will be equal to mu naught or mu one, whatever, against this cutoff, can you see that against this line, something like this? Right, I'll share it so that it stands out. I don't know which color I should use. Yeah, this will look more, no, I need a light color. I'm stuck. Yeah, I think this will do a good job, right, guys? Yeah, perfect. See, so now if you look at this, this is known as type 1 error. Why it is type 1 error? Type 1 error is a type of error which happens when there is a rejection of null hypothesis, which is when it is actually true. So let me take in my example. Suppose a man is being tried for the murder of his wife and he was innocent. A man who is innocent got convicted in the trial for murder of his wife. What kind of error is this? Come on. Guys, are you able to relate? This is your type 1 error. Generally, again, in the law and order, there's a philosophy that doesn't matter that if you set free some criminals, but make sure that you don't convict an innocent man, right? Have you heard of it? It's okay that you make mistake in punishing a criminal, but you cannot punish an innocent. But irony is that it happens a lot of time, right? Across the globe, but the idea is to avoid it. This is known as blunder. This is not an error, it's a blunder. You cannot go with this. Even in any machine learning model, type 1 error is not accepted at all. Okay? Means how can you do that? It's like you're telling a man you're pregnant. I'll show you that image also. You're telling a man that you're pregnant is a type 1 error. Let me show you that image. It's a very cool image. Generally, it comes as memes, right? Let me just pull that for you. Yeah. So this is the image which I was talking about. You must have seen it in a lot of data science memes. Oh, this is a very bad quality image. Hold on. Yeah, this is much better. So guys, can you see this on your screen? Although they are calling, true positive, true negative, I cannot go in that yet because that's more of a classification ML based kind of understanding. But can you see that type 1 error? It's there in the box. What is type 1 error? You are looking at an old man. He's the doctor, and you are telling him that you are pregnant. Obviously, it's a blunder, right? You can look at a pregnant lady and you can say you are not pregnant. That's your type 2 error. That is still acceptable, right? It doesn't harm anybody, right? But how can you say this to a man? So then, this is a typical example of making an error, right? In null hypothesis. And can you see that this particular part of the tail is a null hypothesis? But since you are overlapping these two guys, null and alternate, and you have a cutoff of mean, anything more than this, you say it is it is rejected. So you have rejected the null hypothesis, right? Anything before this, now can you see that, guys? This one, you have accepted the null hypothesis. And there can be a chance that if you look at this part, can there be a chance that this part is part of what another one, alternate also, right? Guys, please pay attention. So what's happening, guys? This is known as type 2 error. So far with me? So what is type 2 error? Type 2 error is the kind of error that occurs when we do not reject the null hypothesis equivalent to false negative, and when the null hypothesis was false, right? So this is as good as saying, I'll write, I need some space below it. I'll write here, this is like saying a man is proven not guilty. This also happens, by the way, even when he killed his wife, right? Are you getting, guys? This is equivalent to what error? Type 2 error. Type 2 error. Type 1 error, type 2 error. Right, guys, clear? As per the law and order, this is okay. Means I know you guys might be feeling, oh, how can you leave this person? But this is how it is. In case you make a mistake and a criminal gets free, it's okay. But an innocent cannot be convicted. Guys, there. Now I'll give you the definitions. So this is type 1 error. This is type 2 error. So type 1 error when there is a rejection of null hypothesis, when it is actually true, and type 2 error when we do not reject a null hypothesis, that is false. So this marks the closure of hypothesis testing, not from the example or use cases. This is more from the concept side. When I take this example in the hands-on, you will understand nicely.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
Let me give you this, and we can discuss on this. So whenever you're comparing two samples means, right? So you are looking at a population. So this is your population. Just imagine. I hope you can see my screen, right? And let's say you have two samples, sample 1, and you have another sample, sample 2. Now there can be two different population as well. So that's one of the way of looking at. You can have one population and you can have another population, pop 1, pop 2. You have two samples coming out of these two different populations. Now the question is that which t-test is being used where? This is known as paired t-test. I don't know if you guys are able to recall, those who have studied or not. Those who have studied. If you have not studied, definitely will not know. This is known as paired t-test. Okay. And what you are looking at, the other one, this is known as, if samples are taken from two independent population, two different population, this is known as two sample t-test. So far with me, guys. And this is something you have to keep in your head. Means you can't do much about it. These are the concept. Okay. So when you're trying to compare the means, two means like this, you have a two sample t-test, you have a paired t-test. There's one more thing when you compare the mean against the standard value. So let me take a population. You are getting a sample out of it. Sample. And you are comparing this sample against a standard value. Then this becomes your one sample t-test. So now you don't have two samples, you have only one sample. You have only one sample, right? And you are comparing against some standard value. Let's say I have a sample and I want to compare the sample mean against, let's say, 20, right? So that it will say that you are comparing with respect to 20, and that becomes your one sample t-test. Okay. So these are the different flavors of t-test. T-test works on the, as I was telling, that when you have the sample less than 30, then only you should use t-test. And there are a few assumptions, guys, like samples are independent. I just talked about homogeneity in sample variance, also known as homoscedasticity. It's a very difficult word to pronounce. And heteroscedasticity. Anybody recalls that? So homoscedasticity, let me use this word, means homogeneity of the variance. Can you see that? So whenever all the samples, right, sample 1, sample 2 are having the same variance, different samples exhibiting same variance, they are called homoscedasticity. Okay. So that's like more like, one assumption that we have to just check to apply t-test. and data is assumed to be normally distributed. So normal distribution, homogeneity in sample variance, and samples have to be independent. So these are some assumptions that you have to, follow, you have to comply, right? Now I'll get into more like a tree diagram. Suppose you are doing the hypothesis testing, right? You want to reach to a conclusion, okay? And you are trying to do test. Now this tree diagram will help you guys. And this is about your population, okay? So suppose you're doing hypothesis testing, right? And you know that in my, in my data, sigma is known, okay? Population variance is known, and n is greater than 30, then you go ahead and use z-score or z-test. What is that? You remember I had taught. So you will take x bar sample mean, subtract population mean, divide by sigma by root under n. Okay, that's what we call z-test. Now z-test will also be of two types. So let me extend this a little further. Z-test is also going to be of two types. One sample and two samples. Just like I have mentioned about t-test. One sample, it will be compared against a standard value. Two sample will be compared against each other, right? This is what we call as z-test. Okay. I will show all these things in hands-on format as well when will we reach there. Now, what is x bar? Sample mean. Let's get familiarized. What is mu? Population mean. What is sigma? Population standard deviation. What is n? N is your sample size. Any doubt on this, guys? This is your formula. Okay. Should be good. Give me a go ahead if you're clear about the formula and the bifurcation. If sigma is known and n is greater than 30, right, we will use that. This is all informative. We have to follow that. Means we cannot be questioning that how did it come. Definitely it has a history, but there's no point getting into it. Okay, we should learn how to use it. And that's where our focus will be. Then on the second side, we have a t-test, right? For the t-test, you don't know the sigma, so you come with S. S is your sample standard deviation, and n is less than 30. So these are the two criteria there that you don't know the population, standard deviation. You know the S. S is your sample standard deviation. Let me write here. S is sample standard deviation. And if you look at the formula, you will try to, so S is known and n is less than 30, right? Then what you will do, again, you will use a flavor of z-test, which is going to be replaced, my dear, please pay attention. Yeah. Going to replace your formula, which you have written z. Now, since you don't have the sigma, what you will write? S by root under n. You have seen this as well. Okay. And this can also be one sample and two samples. Both are z-test only, guys. But the flavor is different, right? Now the question is that, can we apply this z-test, n is less than 30? Then people say that, okay, x bar minus mu, and why don't we name it something else? Because it is similar flavor of z-test, right? But can we call like a z-test, right? No. When n is less than 30, right, you will name it as the t-test, right? But if you see the inspiration is from here only. See, I'll take a pause here, guys. So similar to z-test, but you are renaming it given that your requirement of the sample size, and you say that it is t-test. Okay. See, the only thing which you are looking at this as differently, my dear, is the sample size, and S is known. You don't know the sigma. So your t-test, what I've written here, you will observe that it is close to z-test. That's what I'm highlighting, nothing else. Okay. What is the name of symbol of standard deviation? So I've written now, see, x bar sample mean, mu is population mean, sigma is population standard deviation, S is your sample standard deviation delete, N is sample size. I think I've written everything. This is what we call also as student t-test. So by default, we say loosely t-test, or you will say student t-test. Clear? Now, moving on, there can be, sometimes people say, what is one tail, what is two tail, right? So let's understand that. One-tailed versus two-tailed test. Okay. First, understand two-tailed test. Well, two-tailed test. So let me show you one nice diagram. So this is the two-tailed test where you say if the population mean is equal to sample. Can you see that? This is what we are saying. Population mean is equal to sample mean. That is going to be your natural hypothesis, right? Population mean is equal to sample mean. And here we are saying population mean is not equal. So guys, at the moment you say not equal, it can go in any direction. Say, if you say it is not equal, it can go either towards right-hand side where it is, more than the population mean is more than the sample mean, or it can go to the negative direction, sorry, left side direction when the population mean is less than sample mean. That's where you need, when you're trying to have hypothesis like this, you need a two-tailed test. You cannot do one tail. Why? Because you don't have a direction there. Do you have a direction that you will go towards left or right? No, it's bidirectional. It can go any direction. So for that, you have already seen me doing this study, the whole game, the same game, right? Alpha is, are you able to focus, guys? This is your rejection region, also known as significance level. This is where when you reject your null hypothesis, let me write, and this is for alpha equal to 0.05, which is your level of significance or significance level. And when you say that your probability value, p-value, is less than equal to alpha, what do you do, my dear? Reject the null hypothesis, which basically means H naught. The moment you reject, either you will come here, this part of the chart, or you come there. This is your rejection region. This region is known as what, my dear? 1 minus alpha, which is 95%. This is the reason where you will accept that your null hypothesis is true. Basically, you will say that your population mean is equal to sample mean. Let me shade. Now, this is two-tailed test. There can be another one, which is one-tailed. Now, one-tailed test can be left or right, both. Because it's a directional one, right? So either you can go left or you can get right. Just for our reference, I'll use left. So when you say left, means your population mean is less than the sample mean. See, I'm saying, my dear, population mean is less than the sample mean. And alternate hypothesis is that null hypothesis is same only. Population mean is equal to sample mean. So now do you guys agree that, or you can see whether it will be a one-tailed or two-tailed will be dependent totally on the way you are forming the hypothesis. You guys agree? Now this is known as left one-tailed test. So you can clearly see that the whole of the 5% is sitting here. And I'm not going to share it now, it takes time. And this is your total acceptance region of 95%. Are we clear? And you can imagine the right hand will be what? Just opposite of it. Let me also quickly show you. So we'll see the rejection region on the right hand side, as you can see on the screen. See, total 5%. And Rani is asking in the previous example, alpha was 0.025. No. In both the cases, alpha was, it's not alpha, it's alpha by 2. Total is this alpha, right? That's why you can see 1 minus alpha is 1 minus 0.05 will get you the 95, right? That you are going to use z-test when your n is greater than 30, even equal to 30 will work, and population variance is known. Always remember that. Population variance is known means what? Sigma is known, right? You will always use t-test, student t-test, when n is less than 30 and population variance is unknown. That's why you use sample standard deviation. Clear? Now there are different t-tests. I have already explained, but just giving a nice description about it. One sample if you're comparing it against the standard value, two sample if you're taken from two different population, right? And if the two samples are taken from the same population, right, you will use pair test. Okay, I'll give an example also. So I have a couple of examples to explain. I think that's what maybe someone is asking. One sample t-test, it tests whether the population mean of a single population is equal to a target value, right? Some target value. For example, mean height of female college student greater than 5.5 feet. So this is your standard or target value you are comparing against, right? That's your one sample. Two sample, when you say you are going to compare the difference between the means, right? See that? Of two independent population. So you say that, okay, you have a target value, but the target value is the difference between the means of two independent population. So then the example can be, does the mean height of female college student significantly differ from the mean height of the male college student, right? So there are two different colleges, right? One college is only for female students, right? So that's your sample. It is your female college. And you will take a sample called S1. Similarly, you have another sample, which is male college. And then you will extract another sample, and then you will compare the difference between the mean, right, using these two samples. Got it? The difference between one sample, two sample? Perfect. Let's do a question, guys. The following data represents hemoglobin values in gram per deciliter for 10 patients. Okay. So number are 10.5, 9, 6.5, 8, 11, 7, 7.5, 8.5, 9.5, and 12. Question is the mean value for patients significantly differ from the mean value of general population? So guys, the data you are seeing is a sample, and the mean value of general population of hemoglobin is 12 gram decimeter per deciliter, right? At alpha equal to 0.05. My first question to you guys, look at this question and tell me that it is what kind of test you're going to do on this. Come on. Very good, Prabhat. T-test is correct, but what T-test? One sample, two sample, or paired T-test? One sample. This is correct. So guys, you are going to do, since n is less than 30, how much is n? N is equal to 10, which is less than 30, and you have the sample compared against standard value of 12 gram per deciliter, right? So this gives me, combinedly, I can say, combining these two, it means I need to do one sample t-test. Okay. So let's do that now. So what is going to be x bar? And we know that n is 10. N is 10. X bar is what? Sample mean. So you have to do this sum of all these values. I'm not going to do till the last. And divide by 10. If you do that, guys, you can confirm it later. It will come out to be 8.95. Right? Then we need to calculate the sample standard deviation. The formula is root under xi minus x bar whole square, I equal to 1 to n, divided by n minus 1. So basically it will be 10 and this will be 9. That's how you calculate sample standard deviation. Guys, if you do this maths, you will find 1.80. So what is your t statistics? X bar minus mu by s by root under n, 8.95 minus 12, 1.80 root under 10. Don't worry, in the hands-on, you will be getting this as a result in 1 second or maximum 2 seconds. Python will do it. So now, guys, we have the t statistics value. What is it? Generally, what we do now, once we have the t stats, t statistic, we take mod of it. So if we take mod of, yeah, guys, so I think I'm audible, right? So what you're doing, you are taking minus 5.35 and taking mod of it, right? Clear? So what you're doing, you're taking the t statistics and taking mod of it. There's a reason for it, and you will understand the moment I show you the t statistics table. Again, you will look at the table. Please focus. So this is the table, guys. And in this table, you will have a couple of things. One is your degree of freedom. That is nothing. That is n minus 1. So your sample size minus 1 is your degree of freedom. That is something you have to keep in your head. So tell me what is n minus 1. 10 minus 1 means 9, right? So we'll come here, 9. Okay. Now it says that what is the critical value for this particular question? You have an alpha, which is 0.05. You have an n, which is n minus 1. So you have two things, or you need two things. Like, let me put it like this way. You have a degree of freedom. Yeah. Tell me for degree of freedom 9 and alpha equal to 0.05, where you are intersecting, guys. You are intersecting a cell called 2.26. Hello, very good. So it basically gives you the t critical value coming from the table, 2.26. What is the t stats? You have got it, t statistic. That is 5 point, although it was minus 5 point, what was that? Sorry. Minus 5.35, but since it's all in positive, we'll take a mod. So it is 5.35. Now, there's a condition that if your t statistic, and that's what you will learn step by. So I'll give the steps once you have these value steps. So number one step is what? Calculate t critical at given significance level or level of significance and degree of freedom from the above table, right? That's number one step. And you know that that is coming, T critical coming 2.26. You have done it. Step number 2, if T critical is greater than calculated value, which we known as mod of T statistic, then what you will do, my dear, you will accept the null hypothesis. Maybe I'll use green. Accept the null hypothesis. Okay, that is 2 ka A. There can be a scenario where T critical is less than equal to calculated value T statistic, and then you will say reject the null hypothesis. If you compare this equation with this, remember, this you can compare like P is greater than alpha, and this is P is less than equal to alpha. This is just your reference point. Are we not saying the same thing, guys? Come on. Now let's look at the diagram also. So by the way, what is happening here? What, as per our question, what is happening? Your T critical is 2.26, T statistics is 5.35. Which one is what? Definitely T critical is less than equal to calculated value, right guys? Since T critical is less than T statistics mod, right? So what you will get, guys? The conclusion, you are going to reject the null hypothesis. So basically you are saying that sample mean is not equal to population mean. It is not a true reflection of that. And look at the values now. Your sample value came quite low, right? 8.95 sample mean. Look at the values, the different values, right? You have as high as 12. You have as low as 6.5, right? So that is definitely not putting you in that confidence that your sample is a true reflection of your population, and that's why you are going to reject it. Even you can visualize it, and you can also come to a conclusion from the T statistics, right? Now, if you try to put it into a understanding of the same distribution thing, right? So here, if you see, this is going to be two tails. So again, this will be 2.5%. This will going to be 2.5%. Let's say this is your T critical. What is that value? It came, guys, 2.26. So you know that your T critical is less than the T calculated value. T calculated value is what? 5.35. Although trust me, this is like, somewhere here minus 5.35. And this will be minus 2.26 symmetry. That's why I'm saying positive, negative. Isn't it? It is in this rejection region, my dear. You know that this is your rejection region. Or you can say that it is significant, statistically significant. That's why you're rejecting it. So we also say, right, this T statistic is what? In one way, we will also write it as statistically significant. Why it is statistically significant? Because it is higher than the critical values, and you will reject the null hypothesis. So basically, it is going to be in this. So this is known as what region? Rejection region or significant region? Significance region. I have shown you that. If you're not able to recall, let me go up and show you the diagram. See, it's there now. Rejection or significance level, right? I hope you are following here, right? See, look at me. I'm getting into the details of the things, right? I hope you can see that efforts. Miss, trust me, nobody teaches like this. I know what others are doing, right? So are you feeling that okay, it makes sense, right? The statistical tests are making sense. Even for a smaller sample, you can make a judgment and it looks correct. Generally, when you do in Python, it will be just telling you one line. It will give you this T calculated, this number, and then it will say that whether you can accept or reject, and you reject. That's it. Behind the scene calculation, I'm showing. I'll take a pause here, guys. Guys, give me a good to go if you are following this. Rest others are going to follow the similar kind of style, right? Pindran is asking with this example, what decision can be taken? So we just understood now that sample mean is not a true reflection of the population, right? So you are saying that the hemoglobin sample is not a true reflection of the population, right? So you see different behavior in the sample and the population. You might need to do a different sampling approach or something else, right? But this sample doesn't reflect the hemoglobin level for the population because it is significantly differ from the mean, right? So you can write a conclusion like that. Yes, that's correct. So let me write also. So what is the conclusion? Sample significantly. So it significantly differ from the population, from the mean of the, I should write here, from the mean of the population hemoglobin. Let me find some more questions for you guys. I want to do a 2-sample t-test. Now, why don't you look at this? So it's a more like a MCQ question, guys. You have to choose one correct answer for it, right? So you have a Mio or restaurant owner wants to test if her 2 managers, so let's say it's an organization, it's a restaurant, right? And Mio wants to test her 2 managers perform at the same level, right? You're comparing 2 managers, whether they're performing at the same level or not. So what they're doing that she collects the data about the number of customer complaints at 2 random sample of shifts, right? So there are 2 managers working in 2 shifts, one for each manager, right? You know, right? In restaurant, people work in shift. Someone will start at 6 and they will go till, maybe 6 a.m. in the morning. So shift 1 can be 6 till 3 p.m. So 6 a.m. to 3 p.m. And another guy can come at another shift, which will be 3 p.m. till 12 in the night. So what she's doing, that she's collecting sample for this manager and this manager. Sample is all about number of customer complaints. So far with me, guys? And then the summary of the result they have given to you. So mean is 4 complaints, 5 complaints. Standard deviation is 0.3, 0.5. Number of shifts they have done 19 and 21. So this guy, she has collected for, let's say this is manager A. This is manager B. So how many shift data she has looked into? 19, and here she has looked into 21, right? 21 days, so 21 shifts. In that, she is trying to come with the number of complaints. Now the question is, what you are going to use? Means how do you solve this? Do you have an idea? Definitely, this is going to be 2-sample t statistics. No idea? So it's not that easy, huh? So guys, here you are going to do or use the statistics called T. And here you're going to use sample mean x1 bar, x2 bar. Here not you're going to write x bar minus mu. And then you are going to use this formula, S1 square by N1 plus S2 square by N2. Okay. This is the formula we use all the time. Now, that's the reason that I am telling you this, because this formula can be derived. And I hope you know, right, everything here. X1 is, let me write. This is something you are not supposed to remember because you are going to code in Python, so you can easily use it, but you should write. This is sample mean 1, X2 bar, sample mean 2 for the second population sample. Then S1 is what? Sample standard deviation 1. Follow me, guys. S2 means sample standard deviation 2. N1 means sample size 1. And N2 means sample size 2. So when you do two sample t-tests, you do the difference between the mean. This is much important. So guys, 4 minus 5 you will do. So this is correct, this is correct, this is also correct. So definitely out of these options, these two are gone. Right? Now standard deviation is what? 0.3 whole square. So I think this looks more closer, right? So what is the right answer? I think a lot of people are already there. Answer is C. Very good. But tell me one thing. This is so very close, but why this 0 is coming? If you look at the exact formula now, there will be one more term which we generally assume as 0. So the formula says sample difference. Definitely it is x1 bar minus x2 bar. But you are also subtracting, well, there is one more difference, and that is known as hypothesized difference. So basically I'm saying population difference, if there is anything, and then standard error of the difference divided by standard error of the difference. So what I have seen, people missing this, x1 minus x2 bar, and you also do this, my dear friends, please pay attention, mu1 minus mu2. So this mu1 minus mu2, if you think that the population mean difference is also there, this comes from the null hypothesis. If there is no difference in the population mean, then what you will set mu1 minus mu2? Come on, tell me. If there is no difference in the population means, it implies that you put mu1 minus mu2 equal to 0. That's how you put this equal to 0, and that's how this 0 is coming. Are we clear, guys? See, I'm telling you everything. Denominator, no change. You will still write the same. S1 square N1, S2 square divided by N2. Good? Comfortable? I hope you like this question, right? It's easy. Then you can do a number of things. So if someone can calculate this t statistics quickly for me. What is that? 5 minus 4. Sorry, 4 minus 5. Do the maths, anybody? Root under 0.3 whole square by 19. 0.4 whole square by 21. 0.5. How much it is coming, guys? I hope someone is calculating for me this thing. Okay, Siddharth is telling it is coming to, what is the t statistics you have gotten? Minus 14.46. Okay, anybody else? I need a couple of guys to tell me. And degree of freedom you have to also take, na? So see, N1 is equal to 19, N2 equal to 21. So you know degree of freedom will be what? N1 minus 1 plus N2 minus 1. So actually it comes out to be N1, N2 minus 2, right? So how much is that, guys? 40 minus 2, 38. And alpha, if nothing is given, you can always take 0.05. Okay. I'm just confirming my degree of freedom. Let me open my notes. I think it is N1 plus N2 by minus 2 bits. That's correct only. So this is your degree of freedom. Now look at the table. I know this is 38. I don't know we'll have 38 in this. No. But these stats df equal to 38, alpha equal to 0.05. It's very tough. Generally, you should not get worried because I think sometimes these things trouble us, but that's fine. There's a website called Mera Calculator. Significance level 0.05. And calculate this. So don't worry, this is here. That will give the critical value. I'll give you the calculator also, don't worry. Now everybody, guys, what is the value for that? So see, this is a calculator for critical value. I've taken two tail 0.05, 38 is my degree of freedom. So that gives me this value. What is this value, guys? So T critical comes out to be, please help me here. It is 2.0249. What is my T statistics mod? Come on, everybody, quickly. Minus 14.46. Earlier, you told me how much? Someone can also confirm that. So this is 0. Nobody is calculating, but I assume that this is what, but I don't want to assume. That's what the problem is. Leave it. 0.3, 0.5, right? These are the values. 0.3, 0.5, 19, and 21, right? So my equation is 0.3 into 0.3 divided by 19. I'll just do this. I'm using Excel, by the way, in case you're wondering what he is doing. This plus this, and I'll do square root this, and then I'll divide minus 1 by this number. It comes minus 7.7518. I don't know what you guys are doing, right? Okay, hold on. Guys, I'm getting totally a different value. It comes minus 7.7518. Why you are getting so many different values? Minus 7.7518, period. That should be the value. Why you are getting different values? What's going on? आप लोग calculation नहीं कर सकते. So it will be 7.751. Definitely you can see that it is higher, so you will reject null hypothesis. That's it. Clear? Prava, are you comfortable? I think this is what I'm looking at the table, getting it. So what you are saying that definitely there's a significant difference in the manager performance level because they're not same, right? Which one is better, which one is not, that is a different question. So now guys, next thing we can look at is the F test. Okay. So I'm putting the heading F test. So F test is more to look at the variance of two populations, right? Not the mean. So when you want to compare the variances of two populations, you are going to come to F test. Okay. And there are a few assumptions similar to like t-test, normal distribution of the data is independent. So generally when you are trying to do the F-test, what you do, you try to check if my screen is up, right? if the variances of the two populations where the groups are taken from equal or not, where the groups are taken from equal or not. So there are, two populations. You have extracted two samples. Let me draw. This is gen population 1. This is pop 2. And you are extracting a sample 1, a group 1, and sample 2. So what you do, you try to estimate using two samples that the variances for the two populations are same or not. Are you able to understand, guys? What you are comparing? You're comparing the variances are same or not. Earlier you were comparing the means, remember? So what will be your null hypothesis? So null hypothesis can be variances are equal and alternate hypothesis is, that variances are not equal. Okay, null hypothesis, and this is your alternate hypothesis. Once you have it, then you calculate the value of F. And what is the formula we deploy? It is larger sample variance. Which one is larger? You will put it on the numerator, divided by smaller sample variance. That is sigma 1 square divided by sigma 2 whole square. Okay. And then degree of freedom you need. And that is going to be, there will be 2 degree of freedom, df1 and df2 because of two populations. So because of two sample, n1 minus 1 and n2 minus 1. Okay. It's very easy, guys. Trust me, it's more easier than t-test. This is the distribution table for F test. Can you see that? Now you have a degree of freedom 1, see, and you have a degree of freedom 2. Let's say for any of those, let's say hypothetically, your degree of freedom is 1 is 8 and another is 12, let's say. So where you will reach finally, guys, come on. What is your T critical? 2 point whatever this. What is this number? 2.50. Maybe I can shade it like this. So where you are intersecting, guys, 2.50196, that becomes your F critical. And then again, the same game. You will compare. They will try to, come to a conclusion. It is also known as, F test is also known as variance ratio distribution test, right? Some fancy name, but you have it. So trust me, there are a lot of distribution. One of the distribution is F distribution. But the problem is that we cannot get into too much of the distribution also because that's not in the scope of the syllabus. But you have a T distribution, you have a F distribution. So the sky is the limit. You have a chi-square distribution, right? There are quite a few distributions. But our aim is to, look at F distribution and try to get into any of those kind of analysis. But rather than looking too much into distribution, our focus is directly look into the, the test, and so that you can handle it. Okay. Formula is clear, Indrani? I think so. See, formula derivation, if you try to do, then you will get a little out of the place. Okay. Any sample limit, I think no. As you can see the notes, we are not talking about n has to be less than or more than, right? So you can use it. And this table is for different alpha, guys. So just one thing I missed to write is that this table which I've given now, this is for alpha 90%. So 0.10. You can also have alpha for 0.05 like that. So this is a very good website which you can look at it for the table. So for different alpha, different table is there, and you can leverage that. Okay. So these tests I will show you in the hands-on. Don't worry about it. I have a good case study there, so I'll do that. But currently, I'm just trying to acquaint you guys with the formula and what kind of and how to do it, on a piece of paper. But when I'll have a right data for you and then show you, then you'll understand quickly. Oh, there I have to use it like that. Okay, so let's try to do a question on this so that you get a better understanding of it. So this is the question, guys. An insurance company. Let me give you the question. An insurance company sells health insurance, right? And motor insurance. So let's say you're looking at ICICI Lombard, right? It's an insurance company, guys. ICICI Lombard. They sell health and motor. Motor is like what, guys? Health, right? Any Mediclaim. What is motor insurance? Motor insurance is a vehicle insurance, right? Like bike, car, right? So they are selling this, and the CEO of the obviously customer will pay premium. We always pay, we don't get. The CEO of the insurance company wonders if either of the insurance segments are more variable than other. Variable means the moment you see this word variable means what? Variance. Are you getting? So he finds the following data for the premium paid. So I'm going to give you that table, and that is, I'll just write. So you have two segments. I have to draw this table, guys. You have health insurance and you have motor insurance. And you have motor insurance. Health insurance variance is in terms of dollar and the sample size. Perfect. Looks like a nice table, guys. I'll punch in the numbers. So variance is $200 and sample size is 11, $50 and sample size is 51. Okay. So now, guys, I'll solve this question for you. So first step, you have to frame the hypothesis. So you will say null hypothesis is what? You will say the population variance is equal. Hello? Null hypothesis will tell you to put what? Sigma 1 square equal to sigma 2 square. Alternate, you will frame H1 sigma 1 square sigma 2. What I've done? Sigma 2 whole square not equal. Step 2, you will calculate F statistics. The moment you say you want to compare the variances, you will go ahead and you will say, let us calculate F statistics. So we will use that. F value is equal to sigma 1 square, sigma 2 square, right? So we will do 200 by 50. Already they have calculated. You don't need to do it. So the ratio is 4. Step 3 will find the degree of freedom. Remember? So degree of freedom 1 is equal to n1 minus 1. So 11 minus 1. So 10. Degree of freedom is n2 minus 1. It will be 51 minus 1. So 50. So far with me, guys? Now they're telling that definitely it is going to be two-tail test because they're telling whether they're equal or not. So two-tail test, and let's say we take alpha 0.05, right? So now we will get into the table for alpha equal to 0.05. So I'll click on this and I need two-tailed, hold on guys, F table for 0.05. This is a good table. Why do you need the table? I'm giving the table in the chat and you can, I have already shared the link here in here. So when the notes will come, when who you can take it, but if you want, you are insisting, I can share, not a problem. But you don't need the table. Yeah, guys, now come here. This is for alpha 0.05, degree of freedom 1. Degree of freedom 1 is how much? 10. Degree of freedom 2 is how much? 50. So we don't have 50, so we'll try and convert in between 40 and 60. Okay, so depends on it, right? You will not get everything what you need. Okay, but if you're solving the question, they should give you, but it's okay. So where they are going to cut, if you draw that line, somewhere here or here, right? So you don't see a much of a difference, right? Between 40 and 60, it's all in the 2 range, right? So I can say F critical is how much, my dear? Equal to, let's take 2 now. And what is the F stat? We have calculated 4. Tell me, 4 is greater than 2, so you will reject the null hypothesis. Now you're feeling it, right? Rejecting, accepting, you are like dealing like a boss. Are you guys feeling the same or it's only me? And you see, it's so easy, right? Once you have gotten the hang of it. It's not that difficult, trust me on that. The real value as per my solution is 2.026, right? For the F critical, this is 4. So what is our observation? Observation is that definitely their motor insurances are varying. Simple. In which direction we need to see. But definitely the variance is significant. And the C of the company, what he is wondering is correct, right? His hypothesis is proven true. So if the premium paid by either of the insurance segment is varying a lot. And as a matter of fact, right, I think last week only I did an health insurance. I paid 25,000 for 1 year, a year. I'm giving real data. This I took in SDFC. This is a disclaimer. I'm not promoting any insurance company. Don't get me wrong. And I also did a motor insurance. I paid something, 1,060 a year. And this I did with Echo. So I think our CEO is right. The CEO is not right. CEO is not wrong, right? It does vary, guys. And this is real data I'm giving. Okay. And even if you take a normal, so this is like a little premium one, but even if you take a normal health insurance, 8 to 10K you have to pay. Mine is a little expensive one, I agree, but even a normal one will do. It will vary. So coming back to the question, it will vary. Okay. Good, but I hope you are liking my examples. You're able to make sense out of it. I want to do one more question, guys. Another good question. So the bank has a head office. I'll help you with the data. The bank has a head office in Delhi and Mumbai. Has a head office in Delhi and a branch in Mumbai. Okay, head office in Delhi, branch in Mumbai. There are long customer queues. So a lot of queues are there at one office, while customer queues are shorter at other. The operation manager of the bank wonders if the customer at one branch are more variable than the number of customers at another, right? And then he does some research. So what he has done, the variance of Delhi head office customer is 31, and that for the Mumbai branch is 20. The sample size is 11 and 21. Carry out a two-tailed F test with a level of significance 10%. Okay. What I'm saying, guys, again, you know the hypothesis. I'll not get into it. So you know that you have this Delhi head office, HO, and the Mumbai branch. Okay. You have the variance in here 31 and in here 20. Sample size in here it is 11 and in here it is 21. Now guys, quickly tell me. So this is your table which I have generated for you after reading the question. What is the answer? I know there will be a obvious mistake people will make. I'm damn sure about it. See, always remember that the high variance will go on the numerator, right? Remember, I have given the line somewhere. Larger sample variance will go on the top. Now, out of these two, which one is larger? Larger sample variance, not large sample, larger sample variance. So 31 is on the numerator. Very good. I think that's correct. So you are right on the right direction. Sigma 1 square, sigma 2. This is your F. So 31 by 20, it comes out to be 1.55, right? What is N1? Sorry, what is degree of freedom? 1. N1 minus 1, so 11 minus 1, so 10. Degree of freedom 2, N2 minus 1, 21 minus 1, 20. And now alpha is what? 0.10, right? 2-tail test, 0.10. I think I have given that. So degree of freedom is 10 and 20, right? So we can look at this table. This is alpha 0.10. So degree of freedom 1 is 10. So you can look at here 10 and 20. So you can just do this cross. What is that? 2.20. Guys, please pay attention. 2.20074, right? So your F critical is 2.20. And your F statistics is, it is 1.55. So definitely you can see that F statistics is lesser than F critical. F stats is less than F critical. So you are not going to reject. So null hypothesis accepted. There's no change. So the line, the queues are not varying, as maybe the operation manager is wondering. So it is accepted. There is no variation in the number of queues, right? That's what we conclude. Okay. So not every time it will be like what you think is correct, right? They're telling that if the customer at one branch are more variable than the number of customers, no. More or less, the number of customer coming to the branches, whether it is head office in Delhi or a branch in Mumbai, they are more or less same. So you cannot just only look at 31 and 20. You have to also normalize this with the sample size. That's where this is coming. Okay.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
So I hope you can see the screen. So let me put the heading ANOVA. So ANOVA is another statistical test, guys. Any idea what is ANOVA? Any idea, guys? Samina is telling more than 2 samples. But what do you compare in ANOVA, Samina? Mean. Okay, very good. That's correct. Very good, Samina. So let me share this and talk through. So ANOVA, also known as analysis of variance. See, till now we were only compare means variance between two groups, right? Either you were doing one sample or you were doing 2 sample. Let's say if I ask that if I want to compare between more than two or more groups, and I want to compare the mean, what method I should go with? Because these will not allow me, right? So that's where ANOVA comes into the picture. Although the name is analysis of variance, but it tries to compare the mean of different groups to understand that, how one group is significantly different from the other group. Clear? Again, then we have certain assumptions that samples needs to be independent, right? Another one is very important, that all population should have common variance, right? Homozygosity. And samples are drawn from the normally distributed population. Okay. So ANOVA, there are different types of ANOVA, but the one which is we are going to cover in the syllabus is, let's say, one-way ANOVA. So one-way ANOVA is basically an extension of t-test, right? An extension of two independent sample to handle more than two populations. So for example, you have population 1, population 2, and you can go till end population K, 1, 2, up to population K. So you will observe that you have how many groups? You have total K groups. So here the idea is that, if I want to find the difference between the means, right? I'll follow an approach which will help us to, find the variation among the sample means. So everyone will have a sample coming out of it. Sample 1, sample 2, and sample 2K. So just for the three groups, right? Let's say for K equal to 3, I can show you one diagram. See that if that makes sense. So look at here. So this is how the different populations are running. But do you notice one thing? That all these guys are having similar variance, right? The length of this arrow. So the first thing you should observe that the three populations have the same variance, the common variance. You guys agree? Can you see that? Although their mean are significantly different from each other, but if you compare the means between these two guys, sorry for the very blurred photo, but it is very helpful. That's why I'm using it. So if you look at this, can you quickly see that there's not much difference between these two? So mu1 and mu2 are look closer. However, they are significantly different from mu3. Can I say that, guys? Keep following. So there are three population, 1, 2, 3, having three different means, and you're trying to compare it. So far with me, guys? Any question till now? Okay. So once you have a fair idea about that, what it does, why don't we get into the calculation, the approach, how do you do it? Okay. So let me give you the F statistics for this. So how they calculate, guys, they will use F and they'll try to find variation among sample means and normalize it with the natural variation, or you can just write variation within groups. Variation within groups. Okay. So, or you can write, mean sum of squares between the groups, mean square of errors, which is MSC, and mean sum of square between the groups is known as MSP. So finally, it boils down to, MSP by MSC. Just keep that in head. And we are going to deep dive on this. So let's understand first thing first, what is MSP? So as the nomenclature suggests, that it is mean square between groups. Okay. So how do we calculate it, guys? There's a formula called SSB K minus 1. Suppose you have K population, we'll do K minus 1. Okay. There's a formula, you can't do anything, you have to keep that in your head. But I'll explain it later. So you actually write xj minus x bar whole square. You will not understand much here, guys. I'm telling you, you just note down the formula and then here you write nj. Okay, that's your MSP, which is SSB by k minus 1. We have another one called MSE, mean square of errors. I'm going to explain, but first let me give you the formula. So this is going to be SSE, sum of square error, n minus k. So basically it is sigma nj minus 1, nj minus 1, then another sigma x minus xj bar whole square, okay, n minus k. So it comes to sigma nj minus 1, and this comes to sj square n minus k. So basically this n, which is you are seeing, is known as total number of observations throughout k groups. This is like the big total. So let's get into an example, okay? Because we need to calculate this in the, in a very simple step-by-step approach. Ideally, end of this exercise, you will be trying to create this table, which I call ANOVA table, source of variation. Some of the things you have not gotten yet, I know that, so please don't worry, just follow through. I'll explain with the example. Between groups, this is your error, and this is your total. The three segment, if you see. Now, number one thing, we have to calculate sum of squares. So you already know you have to calculate SSB between groups. Error will be SSE. So this is something you know, it is NJ. SSB on the top I have written XJ bar minus X bar whole square. Okay. NJ XJ bar. Guys, I missed the bar here. XJ bar minus X bar whole square. Okay. XJ bar minus X bar whole square. Okay. SSE is double sigma X minus XJ bar whole square. Total is SST, which is SSB plus SSC. Then you need a degree of freedom. So number one is DF1, K minus 1, DF2, N minus K, DF3, N minus 1. Okay. Mean squares. So MSB equal to SSB K minus 1, MSE, SSC by N minus K. Okay. Then finally we'll calculate F value, which is the ratio. MSP by MSE. Okay. So I know this is a little overwhelming, I think, but let me try to explain you by taking an example, and I think you will get it. I don't see any reason that you will not get it. So I'm sharing my screen, guys. I hope you will see the Excel, because Excel is going to be easy for us to calculate. Later on, anyway, we will do in Python later on. But let's see if you can see my Excel, guys. Can someone please confirm? So let's say I have a table which says that times required by 3 workers to perform an assembly line. So they are working in an industry assembly line task were recorded on 5 selected occasions. So let's say we are the people. So this is first worker is me, second worker is let's say Dilip, third is Pratika. Okay, let's say I'm just picking names from the chat. So now let's say these are the numbers, guys. 8, 8, 10. Okay. 10, 9, 9, 9, 9, 10. Okay. 11, 8, 11, 10, 10, 9. Yeah. So these are the 5 days on the 5 selected occasion. 1, 2, 3, 4, 5. So far with me with the data, guys. And this is all in hours, okay? So let's say 8 hours, 10 hours, 9 hours, 11 hours, like that. Hello? So now tell me, and you have to tell me, there are 3 groups. Maybe I can give you 3 colors. Okay? That's why I'm coming to Excel. You like it, the way I teach this. The 3 population, 3 sample, right? So far with me, guys. If I ask you what is the sample average? What is the sample average? So I think you know, right? What you will write quickly? Average of what? Each of these kinds? 9.6. You'll find sample for Dilip, we'll do 8.8 and Vertica is 9. This is your sample average. What is sample variance? So you know that it will be variance and this will be S for sample. See 1.3, 0.7 and 0.7. Okay. So far with me, guys, come on. Not done any rocket science here. Nothing I have done. Give me a go ahead, guys. Yeah. Now there can be overall average also. And that will be what? Average of not across the population. It is going to be the average of the whole guy across the total N, right? So how much is that value? 9.4. So far with me, guys, come on. Now also tell me what is the value of N and what is the value of K. N is to like what? How many total? 50. And how many groups are there? 3. Good. Guys, come on, yes, sir. Now we need to calculate sum of square between the groups. How will you find sum of square between the groups? So guys, what is the formula says for sum of square between the groups? It says that you will use Nj, and let me write, and the beauty about Excel is that I can write also. So maybe I can write here. Nice. Doesn't disappoint me. What is SSB? SSB is equal to sigma Nj xj bar minus x bar xj bar minus x bar whole square. This is the same formula I've given. Yeah. Okay. So guys, let's understand that. What is the meaning of Nj? Nj is number of data points within each sample, which I had not written there. Now I'm writing. Nj is what? Number of data points within each sample. I'll share the Excel also, don't worry about it, with formula. Okay, what about xj? This is your sample mean. And what is this x bar? There is no j means overall mean, right? You can say just sample mean. Sorry, my bad. We'll say this as overall mean. And you know the numbers also, right? So sample mean is how much? This is what going to be the sample average. So I'm giving the arrow because I like giving it. Sample average and overall mean is this number, guys. Good. Now SSB we can calculate. So first thing first, how many number of, it is 5 into, now you have to write nj minus, so this, oh my god, yeah, 5 into sample mean 9.6 minus overall mean, right, whole square. I hope you know a little bit of Excel. Please don't say no. Plus you will do the same thing again, you'll write 5 into, come on, what is it, 8 point, you know why it is happening? Because of this idiocy I have done. I don't want this also. Sometimes arrow is not good. Yeah, let me write now fast. So 5 into 9.6 minus 9.4 whole square plus 5 into, not unusual, the next group, this a minus 9.4 whole square plus 5 into 9.8 minus 9.4 whole square, and that will give me the value of sample mean. Sum of square between that. Right, guys? So far with me. So this is your sum of square within the groups. That's why you're doing, right? 9.4, 9.4 all the time. So far with me, guys. Come on. So this is known as variation. This is known as variation between the groups. Interesting. Now I need to find sum of square error, which is actually within the group itself. So for that, what is my approach? Approach is very simple. I'll do n minus k, right? Sorry, nj minus 1. So it is going to be, right? Remember the formula, nj minus 1. Let me write the formula. What is sum of square error? It is sigma nj minus 1 into sj square, so variance, divided by, divided I will do later. No? That's it. For now, you have to follow this. Okay. So now what's happening, guys? This nj, which I've written, yeah. So let's calculate this equal to nj minus 1. So each group has equal number of sample. This is a very simple case. So we'll do 5 minus 1 into C12. What is C12, guys? For me, it is variance, right? I have calculated it now. What is SJ square, guys? Your individual variance plus 5 minus 1. Then I'll do this variant, 5 minus 1. Are you guys following with me? Then you are doing this variance. Done. 10.8. So you have the variance already calculated within sample variance, right? Remember, what is this SJ square? This is your within sample variance, right? Guys, give me a go ahead if you are able to follow this. So that gives you SSE. So what is your SST? Some of these guys, So what is it? You will sum it up 10.8 plus 2.8, 13.6. That's your total. Okay. This is SSB, SSC, SST. This is not your MSB. So to get into MSB, remember I had given a formula. To get into MSB and MSE, you have to use a formula. And let me show you what is that. You have to divide it by k minus 1 in 1, and 1 you have to divide by n minus k. So ideally, MSB and MSE will calculate by the division. Remember, what is the division? You will take this SSB and divide by, come on, help me out here. What you are going to divide by? K minus 1. What is K? 3 minus 1. So how much is that? 1.4. SSB is what? This divided by what? N minus K. 15 minus K. Remember? That gives you, what did I do? I7. Let me rewrite. Sorry, guys, something I missed. This value at 7 divided by n minus k. Right? Perfect. This is cool. Now you tell me now, what is the value of f? It is the ratio of MSB by MSC. 1.556. Wow. Guys, isn't it easy? Now, once you have the F statistics value, right, what we will do? We need to find something, right? So what we will do? Let me share back my OneNote. I hope you can see. I'll take the screenshot of this example. Don't worry about it. Can you guys see the OneNote? Now you tell me, you have F statistics. What is going to be your F critical? Calculate it now. F critical. So F critical is going to be calculated. So this is what you have calculated is known as F statistics. Remember? And that is coming 1.555, whatever, 1.55. It should be stop here. F critical is what you will find, and that's going to be a question mark for us. Now you have to use a certain rule. So first number alpha is 0.05. One of the degree of freedom is k minus 1. Another of the degree freedom is n minus k. So this is equal to 3 minus 1, our case 2, and this is equal to n. N is 15 minus 3 is 12, right? And you will be looking at a table. And this is what I have to show to you. Maybe I'll write here. Wow, this is good. So guys, tell me degree of freedom. So this is between the groups. So it will come here, right? And one is it will come here. And then you will draw a line and compare. Where are you able to circle it up, guys? Here, 3.89. This is the F table for the degree of freedom for the significant alpha level 0.05. Guys, are you seeing that? So now you tell me your F stat is what? Less than the F critical. What do you do in this case? Accept the, nothing changes. Accept the null hypothesis. So, and what was the null hypothesis? That your means are not significantly different. So, what means that the means are more or less close. And let's see that. One of the mean is 9.6, one of the mean is 8.8 and 9.8. So, it's not significantly different. You might be wondering, is there a way that you can show that the other case? So, why don't I move on to the same example? Right? What I'll do now, guys, I'll just copy paste the whole thing. And that's the beauty about Excel. You can just replicate in nanoseconds. See, you have to just update it that, okay, Akash is very hardworking, as you know, right? I'll just put some weird numbers like he's working 18 hours in 24 hours, right? So definitely I'm in line to beat Narendra Modi, our PM. Can you see that, guys? My F statistic is 21 point something. I hope you can see my Excel. Right, guys? Come on. Now, definitely I'll go back to my sheet, OneNote. Now, if you see, tell me, again, get back. So, what is the value of critical? Critical will not change now, because it depends on the alpha and blah, 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 right? So, what is the value of F critical? It is, what was that, 3.89. What is the F stat? What do you see? So, you see that F stat is more than F critical. So, what? Reject. Reject means you will say that the difference in the mean, in the sample means, is significant. Are you feeling it, guys? So what I have made you learn today, and now I can see that you can understand, and give me a word if you are with me, that looking at, so for, when I gave you those mathematical sigma and all, I know a lot of people are from non-mathematical background. So for me, it's like back of my hand. I can do like this. But for you, it can be tricky. That's where I, strategically weighted you, put you on hold that, okay, come to this table and then you suddenly understand. Wasn't it easy, guys, getting sample average, sample variance, overall average, using into the formula, right? How was my approach? You guys agree that rather than talking too much into the mathematics, why don't I show an example and then you'll say, wow, this is easy. I mean, I feel that it works, but I don't know. That's, you have to confirm. And let me put this Excel save as before it gets crashed. So yours is 11th October, right? 11th October. And I will say ANOVA example so that you know. And date is December 8. Let me share this file first. But did you get ANOVA, guys? I think so, right? Yeah, a lot of people already commented. Thank you. This is good. Take the Excel, guys. Please confirm. It's not letting me share it. Wow. Now I want to give a question. If you have no question, and I hope you like it. Shall we do it? Yeah. Suman. So K is number of sample group. Yes. In this question, it was 3. Suman, is it possible to share Excel sheet? I just did it now. Okay. This is a literally a very good question and we love it. Okay. And here you go. No, I'm just formatting. I was just formatting the question so that it looks good. Can you see the question, guys? A pharmaceutical company conducts experiment to test the effect of new cholesterol medication. Very much required. It's a real pharma question. The company selects 15 subjects randomly from a larger population. Each subject is randomly assigned to one of the 3 treatment groups. Within each treatment group, subject receive a different dose of new medication. In group, whatever they have given, 0 mg per day, 50 mg second day, and 100 mg per day. So actually they're telling, my dear, is this, that first group 0 mg, group 2 50 mg, group 3 100 mg, medication difference. After 30 days, doctor measures the cholesterol level of each subject and the results for 15 subjects appear in this table, right? Definitely these are cholesterol values, okay? In conducting this experiment, the experiment had 2 research questions. Does doses level have a significant effect on cholesterol? It's a very obvious question, guys, right? Second, how strong is the effect of doses level on cholesterol? So about significance and the degree of strong. So guys, take your time. I think it will take some time. So, but you have to do this. This is the only one exercise which I feel that you should do it. So take your time and do it. You can use my Excel sheet. That's what I've given. You don't need to do manually writing formula. I hope you are thinking on that line, right? Be smart. Yes, right? You can use my Excel sheet now, update the data. Because I'm going to do the same. It will not take them more than 2 minutes. If someone asks me questions in the Q&A, I can try sharing. or if you are in Discord, you can get it from there. I have just pasted it there, but it will be taken as an image because you have to write. I think it will not take much time. Pratik, good. Indrani has gotten F equal to 4.146. That's not correct. Something you missed. Anybody else? I hope you guys are doing it. Okay. Let me know once you are ready. Okay. So you guys are getting 4.16. Okay. Let me also try. Maybe you guys are right. My answer is not correct. And share my Excel again, which I have shared with you. So the number are 210. I'm going to update 240. Guys, can you see the Excel? Right, 210, 240. What is that? 270, 270, 300, right? I think I can copy this. No, it did not work. What about this? Yeah, it did work. Right, guys? So now you tell me what is the, obviously the color formatting has gone, but you can only say you need to text. And we can quickly color so that you can see that it's different. 3 groups. And here you go, right? So you can clearly see that the average is what? 258. I'm just making sure that N is 15, K is 3. Overall average looks correct, right? So it's coming 4.16. Okay. You guys are good. The answer key was showing something else. I'm just checking the formula, guys. Just hold on. Okay. So we have F equal to 4.16. And we know that F critical is what? Let me put this back in the OneNote and sharing back the OneNote. Again, we have already calculated that 3.89 at 0.05. So we know the maths. What is it? F statistics comes out to be 4.16. F critical is 3.8. It was no 3.89. So definitely F statistic is more than F critical. So it is going to be reject the null hypothesis, right? Definitely it looks meaningful that, right, the different doses will have different impact on the cholesterol level, right? Can you see that? So they differ. See, different mg will impact on the cholesterol level differently. And look at the sample average. It looks that 210 is little better. So 100 mg medicine is making your cholesterol level little lower, guys, isn't it? Means we have a view, right? 260 and 210. Definitely there is quite a difference. You cannot say these. See, you can say more or less these are similar range, but it does impact. So if I have to put a visual, so I can say that, hello, you have 0 mg, you have, what do you mean by 0 mg? 50 mg, 100 mg. So you have cholesterol level 258. You come here, you have a cholesterol level 238, and that's 246. And then you come here, you see that your cholesterol level has come down to 210. And this is like, guys, not from 0. This is like, let's say 150 range 2. Can you see that you have a downward trend coming down? Not like drastically, but it does come down. I have done this so that you can feel this coming down slightly, but it is coming down. So guys, we are going to import certain libraries, like, import NumPy as NP, import Pandas as PD. These are standard ones. Import operating system for working directory. Import Matplotlib dot pyplot HPLD, import Seaborn as SNS, right? Cool. It should work. Yeah. These are the libraries, guys. Please type in so that you have it ready. Now we will start with first test, which is our Z test. Maybe I think this is okay. Z test is good one. Let's do it. Okay. So from SciPy import stats. So SciPy is science file. So I'll ask you to install this, means call, not install. So guys, let's start with one sample Z test. Okay. So you know that one sample Z test, if I can give you a point, you know that what it does, checks whether the sample comes from a known population, right? Remember, where population mean and standard deviation sigma should be known, right? Standard deviation sigma should be known, right? So I need to find certain data to do this. Just wondering which one to take. Okay, guys, please pay attention. So do you recall, right? One sample Z test we do to do what? Just to give you a flashback. So let's say you have let us say that you have a sample data and you want to test. I'm writing in plain English. You want to test if the sample mean is significantly. You don't need to type. I type fast because I do it all the time. Different from the population mean. That's why do we do this? That's the reason for you doing it, right, guys? Come on. So what I'm going to do, I'm going to just create a sample data, like you just type in a list. So sample, I can give number 3, 4, 5, 6, 4, 6, 4, comma 6, comma 5, comma 4, 6, comma 3, comma 5. Okay. And let's say the population mean and standard deviation I assume is this. Follow me. So I say that population mean is pop mean 4.5 and population SD standard deviation is 1.2. Okay, there are two variables I have created, guys. Now I'm going to perform one sample Z test. So for that, what I'll do, I'll write Z statistics. So there are two multivariable I'm creating, guys, and P value. And then I'm going to use my function stats dot Z test. Did I run this? Yeah. Sample is my sample. Then I need to give value. In this, it has no attribute called Z test. Really? Import SciPy as stats. Maybe this is another one we should use. So guys, it's also in SciPy only. SciPy little big one, right? SciPy stats as stats. Okay, let's run it. Now I think you should get interesting. Hold on. Stats dot Z. Okay. They have updated jet statistics, they're called. But this is not the jet statistic. This is to my variable name now. Jet score. Hold on, guys. I'm missing the, what to say? I'm missing the formula. Is it jet score or not? Because I don't want to keep breaking my head. Let me just refresh my memory. SciPy, Z test. Let me get into the, I think it will be Z score there. But then I have to put in array and all. I don't want to do that. That's why, see, I'm not going to use SciPy. SciPy is like, how to say, like not good. I don't like it. Okay. So the Z test one, which I was trying to do, guys, it seems that it's not working out for us. Okay. So guys, the reason is that I was not importing maybe the right libraries. So we have to import from stats, the models, stats, that's why it's missing. Maybe let's see that. Wait, stats, import Z test. Wow. Now it will work, guys. So we have to call. So I'm giving two values, to be honest, Z score and P value, and I'll say just Z test. Simply, right? Yeah, it picked up sample, and value will be equal to population mean, pop mean, and pop standard deviation. Okay. And let's see. Did it do anything? Oh, I missed one thing, na? My bad. Sigma is equal to pop. Now see. Oh, sigma is not there. What is it? Value alternative 0 use variance pooled. Showing different. Suddenly all the older ones, it doesn't work. That's it. Like it's a very simple one. I don't know why it's not giving the right answer. Did I run this, guys? But how can we? It's 0. Alternative fraction. No, guys. Let me do one thing. I'll do away from this because this approach, this library is not helping me anything. Okay, here. So what I'm going to do, I'm going to install another library. You guys also do it. It's not a very good one, which I was trying to do. So it is known as BioInfoKit. Okay, let me put in the chat. You also install. This is not going to be there for you. Oh, for me it is already installed. Can you guys try it out? Sorry guys, let's not go there. Using this Z test from SciPy, it's not giving me satisfactory answer. Please try installing this, guys, and let me know once you're done. We'll use this library for all the statistics. Can you guys confirm once you're done? Okay, perfect. Now what you have to do, you have to call this bioinfokit dot analyst import. This is to get data. So you can also get some data which is inbuilt data for doing Z sample, one sample Z test. So to give you some background about this data, forget about the data I was looking at, because that's anyway some mocked up data. Now let's come to this data. So guys, this is to get sample data for understanding the statistical test. Okay. Now let's say I have a data get it from this function, get data. So this is the function you're calling, get data, and there you will call Z1 sample. You have to write Z1 sample. So, and you have to say data. This is the way you get data, guys. Okay. Wow, perfect. This works, right? So it's a data frame, right? And if you see it is a series, right? It is only one column, it's a series. What is the key to install? You have to do pip install. I have written in the chat. See, Suman. I did not get your question. Are you asking how to install? You have to do pip install by InfoKit. Now this data is, guys, it's a factory data. Let me talk about a little bit more about the data. So I can give a factory produces. I have it, guys. Why to type? So this data talks about a factory produces. A factory produces, the tennis balls of diameter of 5 centimeter. But due to manufacturing condition, every ball may not have exactly the same diameter. Maybe I can put it into, Then the standard deviation they are telling of the balls is 0.4. Now the quality officer would like to test whether the ball diameter is significantly different from 5 centimeter in a sample of 50 balls randomly taken from the manufacturing line. So did you understand the problem, guys? There is a factory which manufactures the tennis balls, right? The ideal size is 5 meter. So they have taken a sample from the population, right? So let's say you have a lot of tennis balls. You have taken a sample which is of size 50, right? And these samples you are going to use for the one sample Z test, because your sample size is greater than 30, and you are going to say that, okay, whether your sample size uh, mean is equal to 5 or not. That's a sample Z test you will do. Okay, I'll take a pause with this. Are you clear with this data and question, everybody? This is more interesting, and this library has everything. I am not doing anything from my side. So now, guys, once you have the data, what you can do, you're going to use the Z-test function available in the BioInfoKit library. So to do that, you have to import from bioinfokit.analyst import stat. So first you imported the data, now you're importing the function. And then you will call the function using, right, rest. You can put some, result, res result dot z-test. Now z-test needs, a data frame number 1. Suppose you have your own data, you can also run it, right? So you have to give a data frame x equal to your column name. What is the name of the column? Just go on the top and read sizes. So you'll put the sizes there. And then you have a mu. So what is the population mean you want to compare against? 5. And what is your x underscore standard deviation? That is 0.4. And test type is equal to 1. One sample is test type 1. Let me show you the documentation. The documentation issue is that it's a library somebody has written, right? But I can give you the documentation screenshot because it's written by people like us. So see, Pandas data frame containing X group. X is the column name for the X group. Mu is your, hypothesized or known population mean. Standard deviation for the group. Alpha you can also set, and type of Z-test, use 1 for one sample Z-test. The moment you run this now, you are done. And then you can print the result summary by using the function result summary. And you will be happy to see the output. And if you look at the output given by SciPy library, right? Let's say, for example, I show you one sample Z-test SciPy stats output. Let me show you this. If it is in the image. No, one sample Z-test SciPy stats. Let's see. right? So they calculate the Z-score, guys. I don't know if they've given some example, but look at that. No, this is not the Z-test. One sample, yeah, it seems to be this one is Z-test. It's a T-test. First of all, finding the Z-test has become like something, I don't know why they are not able to do. But anyway, but if you say this is the T-test they're doing, and if you look at the output, can you see the result? Look at that. This result is like very lame. Hello? See, Z-test, T-test, same now. So T-test result, look at that. The result we get in our function, look at this. So structured. You can take a screenshot and you go. So first thing first, it shows sample size 50. Mean 5.0176. Z value is 0.317. And now they're giving p-value for one tail, two tail, lower, upper, everything. Now you tell me what is the interpretation of this? Soumya, tell me. Is the p-value significant? What is the concept? Concept says if your p-value is less than alpha, you reject. Less than equal to alpha, you reject. What? Null. If your p-value, don't forget the basics, is greater than alpha, accept. Remember that? Now tell me, for alpha 0.05, which is our standard, what is the p-value you are getting? 0.75. Even one tail is 0.37. So it is p is greater than alpha. So are you going to accept the null hypothesis or reject? Accept, right? So what is the interpretation, my dear? What is the interpretation? So interpretation is, I'll write p-value obtained from the one sample Z-test. One sample Z-test is not significant. And you can write Z value, since p-value is more than alpha, right guys? And therefore, we conclude, what do you conclude? That the mean diameter of the balls in a random sample is drawn from the same population. I hope you understand. Are we good, guys? Okay, so I think we'll continue from here, but this is how we are going to use this library going further as well. So the jet test we will do. So we'll go sequentially, hypothesis testing, everything we'll do what we have done hands-on on the manual or manually we have calculated. Okay. But do you think it's an important tool for the quality managers? Think about it. Is it practical for any quality manager that, okay, you open every tennis boxes ball and try to check, right? It's impossible. So what they do, they take the batches of production and they will take sample and they will run a Z test, right? And if they are statistically they are getting this, what we have gotten, they'll say, okay, pass. They are not going to check each and every ball, right? They will just, obviously they'll check each and every ball in the sample, not in the population, and then try to quickly, estimate against the population and say that, okay, it is not significantly different from the ball sizes which I need to produce. So I'm more than happy to pass your batch. So that's the whole cycle goes through here, right? Okay. They have updated so I'm not using SciPy stats library. I'm not used for long. I always taught inferential by using this library. But let me ask you guys, did you install this? Everybody, give me a go ahead on this. Were you able to install pip install bioinfo kit? It's very important. You love it. You love this library. You will forget about SciPy stats. SciPy is also famous for other, like SciPy has a lot of, you see, SciPy has quite a lot of functions. It's not only one. Look at that. But you will love the bioinfo kit a lot because it has good example, it has data itself to learn. So I really liked it for inferential statistics. So I found this library and then I started teaching using this library. And that's where I'm not using stats. And it seems they have updated few things. That's why I was not able to use that function, but you can take a shot. Soumya, Prava, you guys can see that you can do it, try doing it using SciPy as well, using SciPy stats. I'm missing it, but I can also spend time to refresh. Something I'm missing, I'm damn sure. Okay. Okay, so Indrani library installed kernel restarted with getting this error. Okay, so let me give you this. Can you put exactly? So that's what I was trying to do. I thought you can just put me saying asking this. I'll put in Q&A. You just copy and paste because if you make one mistake in the spelling, even one character you forget, it will not work. So I can give you this. I think Vinay is asking. So this is the library you should use. But Vinay, don't forget to install it first. To install, you have to use pip install. So why not I should give this also. Okay.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
Now we can move on to do the two sample jet test, right? Okay. Who can tell me that what do we do in two sample jet test and how is it different from one sample? Anyone? Two samples from two population. Okay. And then, so guys, what you do here is this. The two sample unpaired or independent jet test calculates if the means of two independent groups are equal or significantly different from each other, right? Make sense? Now here, what is your assumption? Assumption is that your population standard deviation, sigma 1 and sigma 2 should be known, right? And then you are also aware that your null hypothesis will be two group means are equal. I think I can write that as well. So that's your null hypothesis. Alternate hypothesis will be two group means are different. Okay. I'll just make, yeah. Let's take the example. Okay. So it's the same example I'm going to take. Now, this time in this example, we started with a factory population. We started with a factory which manufactured the tennis balls, and then we were comparing with the certain parameter in the one sample. What you will do here? Here you will have two factories. So here you have two factories in two cities, and here we are saying that there are factories A and B in cities. Sorry, a factory in cities A and B produces balls of different balls of a diameter of 5 centimeter. The defect is reported in the B factory, which is known to cause a change in ball size. So if you observe this line, there's some defect in the B factory, and that is leading to some change in the ball size. Standard deviation of the balls is 0.1. The factory quality officer randomly select 50 balls from both the factories to test whether the ball diameter is significantly different from each other, right? So if I can show that visually, it looks this. Correct? Factory A, you selected 50 balls, factory B selected 50 balls. Both the factory have standard deviation equal to 0.1, and then you're going to compare it. Okay, this is the premise of the problem. What you're going to compare here? You're going to compare that the two sample means. Which are the two sample means, guys? You have two samples. You're going to have two sample means. Are you going to compare these two? Let me highlight and you can say yes, no. Yeah. So this sample and this sample will have some sample mean, right? You're going to compare that whether these two are equal or whether these two are unequal. Right, guys? Come on. Remember? Let's do that. So again, you have to, I think everybody has this library by InfoKit. And from here, you need to get the data first, remember? So take get the data, that's the command, get data, and you will say Z underscore to sample. See, this is my data. Looks nice, okay. So there are two factory A and factory B, and you have the tennis ball sizes there. Now I have to call my function stat, okay, and I'll say result z test, and data is my data frame, okay. X will become my factory A, Y will become your factory B. So you're giving the column names, guys, and see these are here, factory A and factory B. Shiva, you are raising your hand. Is it by mistake or you have something to discuss? Standard deviation. Although in this case, standard deviation is same for both of the guys. And test type will be 2 because you're doing 2 sample test. Okay, guys? And this syntax is something very intuitive, right? Obviously, if you're comparing two sample, you need two columns. So you're going to put x equal to and y equal to something here. X and y standard deviation, you can put it here. Alpha is by default 0.05, but you can set it to some other alpha like 0.01, 0.10, all that. Okay. And print result dot summary. It's so simple, means if you look at that syntax, it's intuitive, yet the results come very nice, right? Look at that. Sample size for X 50 count, sample size for Y 50 count, mean of X 5.01, mean for Y 5.99. You can clearly see that they have some difference, but let's see. P-value for P-value for one tail and two tail is 0, 0. What do you say? P-value, whether you are doing one tail test or two tail test, it is 0. So what is the interpretation, guys? Z value is what? Minus 48.86. So if you have minus 48.86 and the p-value is this 0, right? Now, I think if you remember the concept I had given, if p-value is less than equal to alpha, what you do? Reject or accept? Reject. So null hypothesis you will reject. So you will say x1, x2 is equal. You will say no, means h1 will be accepted, means there is some defect in that, right? So can I write the commentary, guys? P-value obtained from the two samples. Z-test is highly significant. My throat is not good, guys, so bear with me. Highly significant, and you can write in bracket Z, P-value is less than alpha. And then you can also write, which is 0.0. 0 is definitely less than 0.05. This indicates that there is a significant difference in the ball size produced in factories A and B. A and B. So can we conclude there is defect in the machine for ball production in B? So we can hence conclude, hence we can come to a conclusion that there is indeed a defect in the machine for a ball production in factory B. Okay, this is it. And that concludes our two sample jet test. Shall we go ahead? What is next in the sequence? We'll do t-test, right? Student t-test, because I think we just did the z test only, right? Okay, so let's do the t-test. T-test. Guys, t-test is also known as student's t-test. I don't know why they have mentioned that as a name. So t-test is similar to z-test, to be honest. The only difference is that z-test follows a certain rules. So z-test says that n has to be greater than 30 sample size. T-test is for the small sample size. Okay, specially developed for the small sample size. So I can write as a point the t-test. Let me write is specially developed for the small sample size. You don't need to type, guys, ignore this. So where we say data has to be n less than equal to 30. N less than equal to 30. Now, guys, there are similar to one sample t-test, one sample z-test, we have one sample t-test. So let's do that. It's similar to what we have done for z-test. So I'll write one sample t-test. Okay. So it is similar to what you have done for the z-test. You are going to, it is used for comparing the sample mean with the specific value. Okay. Generally it is known as mean of the population value, right? That's what we compare with. Second thing, just to recall, in the t-test for you, the population variance, which is sigma square, is unknown. Population variance, I need the symbol. Sigma square is unknown as compared to z-test. Z-test says that you need to have population variances, which means, so basically they're interested in the population standard deviation. Here, population sigma square variance is not known, and hence it is estimated from the sample variance S. Okay. Okay, cool. So again, we'll start with the one example. So here I'm going to, load the data as data frame, pandas data frame, get data, and you have the data t_, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 1 one sample. Okay. And this is the data looks like. These are the symbols which you have to keep handy. So you can either write sigma square in English. Right? How can I see that, right? Now, if you compare this, then you say, oh, the sample size is more than 50, right? I think this is not a good data for us. By the way, guys, it doesn't harm you to do the t-test, okay, first of all. So even you can see this data is only for one sample, and this is for t-test only. But if you observe and if you're with me, it is like 50 records. But still, nobody's stopping you from running the t-test. But it's not the other way around. If your sample size is less than 30, then it cannot run the z-test. But if the sample size is more than 30, you can either run the z-test or t-test. However, just to make a point here, that t-test is specially designed for n less than equal to 30. But let it be what it is. I can run this on this t-test. So I will again, similar syntax called res equal to stat. So that's your function. Then you will call t-test. Data frame is data frame. Test type is 1. This is equal to size. That's your column name. If I recall correctly, yeah, size of the balls, right? And here you want to compare it with mu equal to 5. Now, if you let me take you back to the one sample jet test. See, isn't it a similar? Yeah. If you see here the syntax wise, see x equal to size is mu equal to 5, something like that, right? So syntax is pretty much similar. You can just run this and print the result summary and you can use it. Now here in the syntax, df equal to data frame, test type 1 means one sample t-test. What are we doing? One sample. 1 means, okay, Shubhangi is asking also. 1 means Shubhangi, one sample t-test. Size is your column name and mu is your population name. Are we clear? Now, what is the value? See, degree of freedom, it is calculating nice. N minus 1, very good. 50, average is this. T value critical is 0.36. And then you have a comparable value as well, right? So now here you can see that you have a P value and you have a critical value, correct? So either you do the critical value comparison with the, with the alpha value, or you can always use the P value as the base. So now you tell me here, P value here, and doesn't matter. I think in this case, you can use two tail. Two tail is 0.71, is less than 0.05. No, it's more than. So definitely it is not significant, right? Come on, Janta. This is 0.36. Even if you put this and you have a T critical for the P value, so lower is 4, hold on, 5.33, 4.77. Now you are saying that your T value is 0.36. Okay, so according to that, you will find the value here or here. So you will see that if this is in the critical region, you will reject it. But if you're saying it is 0.36, means you know that end of the day, this value can be compared against the critical value. So what I'm trying to say, hold on, T value calculator. Can you see my screen? Yeah, I think you can see that. So now what is the degree of freedom? You tell me. 49? Calculate. So what is your T value? It is plus minus 2 or 1.67. Depends on the one tail or two tail, right guys? And by default, your alpha is 0.05. Let me show you. Again, what is alpha by default, my dear? 0.05, right? So now you tell me if the T value is like where? 1.67 and 2.09. So your T critical, which you have gotten, is where? So you do to take mod. So your T value is how much? 0.36789. And then if you remember, I had taught. And what is the concept? I'm giving the screenshot. Hold on. Give me a sec. Can you read it, guys? So what we are saying that if the T critical is greater than the calculated value, right? You will accept the null hypothesis. Focus this. This is coming from your notes only, guys. If you are not able to recall it, right, you're definitely missing it then. This you remember, I had given that either you can compare the P value, again, I'm telling you again and again. So if T is greater than the critical value, less than critical calculated value, critical less than calculated value, we reject the null hypothesis. So which one we will do here? You tell me. What is the calculated value of T? 0.36. What is the critical value we just saw? You take any one of it, 1.67 or 2, depends on our test. Let's take 2. If you take the mod of this and then say, is it less than or greater than? It is less than. No? So it satisfies what? T critical is, so T critical is 2. It is greater than the 0.36. So you will accept the null hypothesis, guys. Which one is calculated? This one, which is coming out of the distribution, right? The test. So this is your T coming from your test. Critical is fixed, which is 2, right? Plus minus 2.09. So I'm taking mod of it and then saying that, okay, this value is definitely, T critical value is definitely more than the calculated value. So you are going to accept the null hypothesis. Other way around, you can say that if the P is greater than alpha, right? So you take the two-tail P. So this is your value, 0.71. Is it greater than 0.05? Yes. So again, you will accept the null hypothesis. Revise in your head. Okay, so Indrani, you got it? Can I move on, guys, to the next one? 2 sample t-test. So again, it's similar. It compares the means of two groups, determining whether they are equal or significantly different, right? So what it does, guys, it compares the means of two groups, okay? And in the 2 sample t-test, we compute the sample 2 means because of the reason that we don't know the population variances, right? So we need to do that, okay? So now what we are going to do, we are going to take two genotype of the plant. So in this particular example, we are going to say we have 2 plants and 2 plants have 2 genotypes. Geno is like genome types, right? And we are comparing the yield. So if you talk about, if you know anyone knows about agriculture, they would know this, that different types of crops are there. They are doing a lot of crops DNA sequencing to get a better yield. Okay, and that's they want to compare if the genome type A and genome type B have a different yield altogether, right? I'll just highlight it, this part. That's the data we are going to talk about. Okay, that's the situation. So, yeah. So I'm going to load the data set, guys. Load data set as pandas data frame. You will say df get us underscore data. T sample dot data, right? And see here. So you have 2 different genome type, right? And you have the yield. Now the issue with this data is that the genotype A and B both are in the same column, right, guys? Can you see that? So we have to do a little bit of data manipulation. So what we will do, now this data is coming from the library itself in running. Well, I think you were present in the last class, right? This all data is coming from a library called BioInfoKit. And to do that, you have to import, I can write again, .analyst. And here you have import get data. This is what I'm running. Okay. And in case you're not able to see this command, you have to pip install by it. Clear? I'll not do that. Okay. So this is my data. So maybe I will convert this by using df.log, and I'll say df genotype. And what I'm doing, guys, here, I'm saying that I'll take the A genotype and the yield for it and convert into NumPy. So this is, you might be seeing for the first time, but it's very intuitive. You're taking the data frame and you're putting into an array. Oh, something I missed here. So you see now this is coming as an array. See, guys, it's like you are filtering in the data frame for the genotype A. What I did in this command, in this, what we have done, we have taken genotype A and we have filtered for the yield, right? And then converted into the array, right? Similarly, you can do for genotype B as well, right? So be smart, just copy paste and just say this and bingo. Now what you have to do, so you have A and B, two arrays, separate arrays. Now you can say, I'll call this st dot, so t test independent, A equal to A, B equal to B, and I will compare equal variance. But I think I'm missing something. Here, I think this is I'm doing using SciPy's library. Okay. This is just to showcase you that you can also use SciPy library, right? And so from SciPy import stats, yep, as st, and there you will say st equal variance true, and to get the output, so this will get you the result. See, very poor result, to be honest, but you can use it. You can say that, okay, p value is what? P is what? 0.0029. So you can round it to 0.003. Is definitely less than 0.05, right? So you're going to reject the null hypothesis, right? That's one way of looking at. And I want to also do it by using BioInfoKit, which generally I have done so far. So that is very much simple, to be honest. So what you have to do, guys, you have to just call the result stat, and you need to do nothing in terms of data manipulation. You can just write data frame equal to data frame, and you can say X factor because you have two genome type. You will use the column. Remember that you don't need to convert into array. You know that this is like a factor data because it has two levels. So you'll just write the column name genotype. You will say result equal to yield, and test type will be 2 because you're doing 2 sample t-test. And you will say print result dot summary. Everybody is comfortable with this. What I'm doing, guys, now that's a way of showing that this doesn't even need any data preparation. You can use the column which has different levels, you can use the other column called yield. Test type is 2, means 2 sample t-test. By default, alpha is 0.05. Let me show you that in the syntax. You can do this and see alpha is 0.05, right? And look at the result. So detailed result. Look at the result this guys get. One line, just read and understand. Here, mean difference, t-value, standard error, degree of freedom. My God, p-value. And it's not like that it's giving you some wrong answer. 0.029. Are we not getting two tail elves to the same number? But it gives you some more insights about the data. And now you know that since the p-value is less than alpha, so you can interpret that, and that I'll do it one line. Here it goes. So see, the p-value is less than 0.05, right? And therefore, we conclude that the yield of genotype A is significantly different from genotype B. I had told you, this is very easy, very easy. All these statistical tests, it just looks little awful in the beginning that what is going on. So many things are there. But again, when you come to me thinking that statistic is tough, and I say you that, oh, it's very easy, then definitely doubt at once. But then as we go into the details, you will realize that, wow, this is very simple. And you're right that exploring things and telling my students. Shubhangi is telling, is it possible to change significant level to 90? Why not? Yeah. Let me go there. So you can put here, you can call alpha. See, you can put 0.01, that's your 90%, right? 10%, 1 minus alpha is 90%, that's your confidence interval. And then you will see that, see, this value has slightly changed, but not much, to be honest. But you can clearly see that it is, no, lower is 99%. So my bad, I put something wrong. Yeah. Now see, this is your alpha, 0.1. Morning can be a little tricky. It seems I am sleepy. Yeah? Alpha equal to 0.1 is 90%, not the other way around. See, you will not see a significant difference in the values, to be honest. Let's move on. Yeah, paired, I have not done, it's not different, right? It's similar to that. If you want, I can show you if you are interested. I have not even tested for paired Z-test, but if you want, I can quickly show you. So in terms of the approach, nothing changes, to be honest. The only thing you have to be careful that it is used to compare the different means of the two samples coming from the same population Zyva, right? So it's going to be the same population, but it will be taking two samples, just like you do in exit polling. So you'll go to the constituency, which is the same population, and you keep asking different set of people. Okay. Okay. So it's not a bit different thing. Some of the things I leave up to the students to explore. So if you're cool, I'll take it up. But for now, I want to get into ANOVA. Okay. ANOVA, let me ask who remembers. So what is ANOVA does for what it does for us? How is it different from anybody else? Remember, this method, ANOVA definitely is a statistical method. But how is it different, guys? It compares analyzing the differences, not variance. Differences in means, but in 3 or more groups. That's the difference. Till now, you were doing only two groups, right? Now ANOVA comes and says, what if you want to compare the means in 3 or more groups, right? And then I had taught you one-way ANOVA. So which is in one-way ANOVA, there's one independent variable and two or more groups, or it can be levels also. Let me show you this. You know that null hypothesis will be all the means are equal, and alternate hypothesis will be they are not equal, right? See? Clear? So what we are going to do, we are going to take an example, and there are 4 treatment groups for ANOVA analysis. So if I can show you the data, this is the data, guys. So there are 4 treatment groups, A, B, C, D, and all these treatments are independent variables. And since there are 4 treatment groups, so there are 4 treatment levels as well, the factor. Now we have to compare it. Okay. So now I think we need the data also. So what I'm going to do, I'm going to read the data from this website. Okay. So everybody, I hope you have imported pandas as PD. Cool. I'm going to read this data, pd.read_CSP. And I'm going to put this website link, right? And you will see that the data is there. But I can see that there is a separator called tab. So I'll also put that. Ta-da. Now it will look nice. Yep. Don't worry, guys. I'm going to put this in the chat. Can somebody say hi on the Q&A? I'll put this in this line in the chat so that you can take a look at it. So you can pull the data like this. Okay. No need to copy paste. Because you cannot copy paste if it's an image. So you have to actually get the data. That way you can learn that you can also read data from websites. See? Let me know once you have it. Done? Okay, cool. Everybody with me, give me a go ahead. I see some of the guys are okay. Now, if you talk about this data, so before you can do one-way ANOVA, you need to do some data transformation. So basically, I mean to say that you have to reshape the data frame, or if you are trying to do it by data frame DF, in case we want to use SciPy stats, right? But see, that's the reason. If we keep need to changing the data frame, we'll not use it. So what we'll rather do, so let us use the bioinfo kit. Okay. Spelling is correct now. File not got. Can you check in the Q&A, Dilip? So what I'll do, guys, but I think I'm just wondering that do we have to do the melting of the data in this case as well? Because that's what it seems to me. Got it? Okay. So let's melt it. Okay, fine. So what I'll do, we are going to melt the data. So let us melt the data. Okay. So I'll show you there's a function called melt, pd.melt. That's an advanced pandas function. So what you will do, you will take your data frame, reset index, and then you want to meld it under the variables index. Let me do it and I'll explain the code, and then value will be this, and then put A, we'll put B, C, we'll put D. If you see, guys, what I've done, you'll realize that I have taken the whole data frame. So I've taken the whole data frame, this whole guy, and I've taken each of the columns, guys, each of the columns, and put it into one row. Can you see that? So you have variable or ABCD, just opposite of what you were seeing in genome, right? Remember? All the levels are coming in one column. It's opposite, ulta of what you have seen there, right? Now you are going to replace the column names. You can say TF melt. You rename it. You can say that it is, I've taught you this index, treatments, and value. So now your data frame has been renamed also, the headers. Guys, give me a go ahead. Are you clear with this df underscore melt data frame, how I've created? Everybody? So now you will see that only ABC has come. D is gone. It's lost. So if you want to filter the data for certain levels, you can also play with this, right? So you have to try these things, guys. Once you have it now, so why don't we understand that all these treatment levels have some difference or not? Remember, I can create box plot. So we can quickly plot or plot the box plot. You know the visualization I have taught you. To understand the distribution by treatments. Okay. So for that, what I'll do, I'll import maybe Seaborn as SNS. Remember? Import Matplotlib PLT. And then we can say SNS dot box plot. Right? X can be treatments. Y can be data frame. Value. Bingo. Could not interpret what? Now, you forget about it. SNS box plot. Yeah. DF underscore melt treatments, right? DF underscore melt and value. Okay. Yeah. See, guys, what happened? It was not able to interpret the column name directly, so I have to give the names like this. Clear? And you can say plt.show. I'm not beautifying the chart, guys, okay? Can you see there is indeed some difference in the level of treatment, guys? It's quite visible. Distributions are not same, guys. Are you feeling there? So what I'm gonna do, I'm gonna run the, again I use this only. Okay. That, and we use data frame as df melt value equal to value ANOVA model equal to value T of treatments, and I'll say ANOVA dot ANOVA summary, and here you go. Right, guys? So this syntax is little weird. I also forget all the time. So I keep it noted somewhere because this is a little tricky, but this is how it is. Okay. But can you see that the p-value, look at the, we don't need to worry too much into it, but you have the degree of freedom, you have sum of square, mean square, right? Everything you have. You have the f value, right? And then you have the p-value. Isn't it the p, excuse me, isn't the p-value is less than alpha? Guys, 0.05 by default is the alpha. So you tell me whether it is less than alpha, 0.05 or not. Yes, right? So can I say that there are, the difference is very much significant here? Can I say that the p-value is significant? I'm just making it here bold. And then we can conclude that there are significant differences among treatments, and that we can highlight here. The only difference here is that ANOVA never tells you that which one is, which treatment groups are, which treatments are significantly different from each other. It just says that all these treatments are not the same. So what you have to do later, you have to go from 4 groups to 2 groups at a time, or you can do t-test or z-test to get into better shape, right? Makes sense? So if you compare 4 means, right, then you come to a conclusion that yes, the treatment groups are different, they're statistically significant. Then which one is different from which one? To do that, you have to get into 2 at a time. So you can start selecting that, okay, first let's pick these 2 guys and then understand. Then pick these 2 guys, then understand. Then pick these 2 guys and understand. Or you can visualize it like I have done in a box plot, and you can clearly see that maybe the impact on the treatment is highest in the D, as you can see, right, guys? Use the graph. Look at the median is on the higher side, followed by the orange, then comes your green, then comes your blue. So at least visually you can make some sense, and then by statistical test you can make more sense, and from there you can get it. Are we clear? Next is chi-square test, but we'll do it chi-square. A lot of people say chi-square. Can you explain the code in line 57? Why not? See what we have done. So this is your ANOVA package or library. So this is your library, and within the library you're calling this function, right? Now this is your data you're using. So remember, this data is your melted data. Okay. Now you will put the value as the column here. So this is your column value. And now you have to give ANOVA model, and that's how they configure, right? So if you see a little bit into the documentation, you realize, see, ANOVA model, you have to give something. So now if it is going to be one-way ANOVA, that's where you have to read. Well, there's no documentation available here, but let me get. You see, this is someone has written, it's not me. But this is one-way ANOVA, and you have to put it like this. So what you're doing, you are actually forming an equation. And if you're able to see, so what we are doing here, that you are taking y as a function of your x, right? So treatments is going to be the input. So let's say you treat A, B, C, D, different groups. Then how is your outcome mapped to the ANOVA? Clear? Those who have done a little bit of R, they will be knowing this a lot, because that's how you put a model in the Y. In the linear regression model in R. Let me show you. Ta-da. R is another programming language. So see, I told you, no? So this is the formula. Obviously, I'm not promoting any. It's just that I'm promoting myself, but I want to show you this. So R is another programming language, guys. Can you see that it is equivalent to what you have written here? Data is here, age and height. Here, data is df underscore that. Okay. To chi-square, or chi-square or chi-square, how do you pronounce? But chi-square test is another important statistical test. So let's understand chi-square test a bit. So chi-square test is also known as Pearson chi-square test. Is a non-parametric test, or I would say non-parametric method to be correct with respect to English, used for comparing the relationship between the two categorical variables in a contingency table. Chi-square is very important for anybody who is in, research, or you want to, take some conclusion out of your research. So for example, if I can show you one table and you will understand, it's a contingency table. Contingency table is more like a pivot table So you will put something in row, you will put something in column, and the values will come in the middle. You have done the Excel pivot, right? So this is known as contingency table. Now, this can be as simple as that, in this case, we are saying that uh, are we going to have some dependency or independence behavior while determining the treatments related to the treatment outcome. So you have treatments, you have treatment outcomes. So you are treating some person. If he gets cured, so those are 16 people. If you're treating some of the guys and they are not getting cured, those are 10. Some of the guys are non-treated and they are getting cured and they're not cured. So some of the guys say, how can you be non-treated and still get cured? Immunity, guys, immunity, right? The body also has antibiotics. Body also, detox. Body has a lot of healing powers. I know I sound like more like a Insta influencer, but that's true, right? I hope you know. So earlier, those with immunity or the immune system was really working very well in the ancient time. Trust me on that. Uh, with the advent of a lot of medical support, a lot of medicines. So it's like I can give a very good example. I always take this example. So global warming is what? Suppose you have a sun, right? It's really hot. Those who are going to live in Gujarat and Rajasthan, they know that. I have lived in Rajasthan, Kota for quite a lot. So that's where you feel the real hot weather. So people put what? People will put an AC, right? They'll say, okay, let's have an AC in the room, right? Tada. Then this AC will do carbon emission, right? Definitely all those gases will go out. And it is a chain reaction, you understand? So it will keep increasing. People will keep adding AC to their rooms, right? 1 ton, 1.5 ton, right? So the same thing has happened with your, medical system, to be honest. So now the way we eat, now the way uh, the whole things have, I'm just making a commentary about the kind of food we eat, the kind of medicines we eat. A lot of things we take, a lot of things are having side effects. Uh, I think I was reading one article and there they mentioned that now in metro cities, to be honest, there's not a single vegetable without having something not good for your body. You guys agree with me? So when I say metro cities like big cities, tier 2 cities is okay, tier 3 villages are the best. But still, if you realize that even the villages are not, now they are in the safe bet. So why is it that so? Because we use a lot of pesticides and just to, cope up with the population's demand, everybody needs to eat and we need to, produce more and more and more. That is taking huge toll on the body in the long term, right? That's why if you observe the number of cancer cases, number of heart attacks, everything have increased in the recent time. The recent time when I see, I think not that like 20 years back, but I have seen the change in a decade. In the last 1 decade, I can totally feel that uh, this is becoming very common. Then we have medicines as well. So we have the healthcare, treating those different diseases that has impact on the body. But somehow it's like the same situation, which I gave an example. You're putting AC to cool down. Unknowingly, you are increasing, knowingly, not so unknowingly, unknowingly, you are increasing the overall global temperature, right? AC is one of the key reasons. That's why I'm taking that. And then again, you'll need more ACs and more ACs, and it will keep go like this. At least I am contributing a lot to the environment of Bangalore. So I live in Bangalore. I don't have a car. I don't have any AC in my house, right? So at least I'm doing my bit and I always try to communicate everybody. So if you don't need an AC, you can manage. No need to buy AC, just you can buy. I hope you guys agree that I could buy a car, right? At least a small car, but I don't have a car because anybody who lives in Bangalore here, they'll know that putting a car on Bangalore road is like you have done some sin. You have done some crime. That's at least I feel. So I cannot do it unless until it's very important for me, right? Because buying a car seems very cool, But if you are putting some logic to it, doesn't make sense. Okay, so that's my 2 cents on it. But that's where at least you have a, you have a subject to do, chi-square test. At least you have treatments and the treatment outcomes. You can do some chi-square test. So chi-square test is what we are going to do in this data. With the help of this data, we are going to determine, let me write and talk, to determine whether treatments are related to treatment outcomes or not. Ideally, it seems so, right? Means if you are treating somebody, you would expect that they are related. And for that, people use chi-square to the test for independence. So chi-squared, guys, it's chi-squared in this T. I just realized it's not chi-square or chi-square. It's D, chi-squared test for independence. Independence on 2 variables. And what are those 2 variables? Treatment and treatment's outcomes. So what we can do, we can again bring our bioinfo kit, load the example data set. We'll say df get data plug data dot data. So this is your data. It's the same thing what I'm showing in the image. Okay. Now I'm going to run the chi-square test. Chi-square test for independence. So you have to call the function. You have to call the chi-square. It's very easy. And bingo. Then you will say print result dot summary. See? Now if you observe, you have a p-value. Now it gives you 2 p-values. So there are 2 methods to do chi-square. What I was deliberating was what? It is more of a Pearson method, but it also gives you log likelihood method. So there are 2 methods to calculate it. But if you look, they are very much close, 0.26, 242. So not a big difference. But you can clearly see that if you want to interpret it, right, that p-value, if I can write a point, p-value obtained, concept remains the same, obtained from chi-square test for independence is significant. As you can see, it is less than 0.05, and therefore we can conclude, what we can conclude, guys, if they are significant, you will reject the null hypothesis. Generally, the null hypothesis is what? Right? There is no association. It's independent. But here we can conclude that there is a significant association between the treatments and treatment outcomes. It will come nice, don't worry. So it's significant. I'll just highlight it. Let me do this. As p is less than 0.05, and there is a significant association between the treatment and the treatment outcomes. And that concludes our chi-square test. By looking at this, you might say, okay, I am treating, I'm getting most of the guys cured. I'm not treating, I'm getting 25 guys not cured. But you get a little bit confused looking at this, that 30 guys are the ones whom I'm not treating, but still they got killed, right? So you get a little confusion. And that's where you need to say, okay, whether the treatments and the treatment outcomes are related or they are independent. In this, guys, generally, you always keep in mind, hypothesis is very simple. Oh, I missed to write. Let me write. So hypothesis is very simple. It analyzes, so the null hypothesis says that, what is the null hypothesis, guys? So null hypothesis, sorry, I missed to write, is no association between the two categorical variables. An alternate hypothesis, it says there is an association. Okay. Okay, guys, so that's all we had to do in inferential statistics. Let me share the notebook. But I hope you got a hang of it, right? You got a flavor of inferential statistics, right? Now you can at least start thinking that how to use it in one of your analysis, right? So that gives you a little bit of confidence also and a view to it, okay? And sometimes in machine learning, you might have to do some hypothesis testing, like generally in linear regression also, before you can come to a conclusion, okay? So idea is that you don't jump to a conclusion by looking at the data, right? The whole idea here is that you do some test, get some sense out of it, and then you come to a conclusion, okay? So I always believe that if you have the data, let the data talk. You don't talk. Let the data talk, right? If you try to say anything, then it means that you're trying to go beyond the data. We should never do that, being a data scientist. First of all, never ever jump to a conclusion in life, in data science.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with iHub IIT Roorkee. Through this course, you'll get to learn data analytics from industry experts and IIT faculty in depth. You'll learn tools like Excel, SQL, Power BI, Python, and K9. This data analytics course is praised by our learners, and their user testimonials are available on our Intellipaat Achievers channel. You can check them out. The link is available in the description below. So if you are really interested in learning data analytics, this is your opportunity. Click on that apply now button right away and get started in your data analytics career journey.
Search for Power BI desktop download. That's it. Now, here is an option called download. You can click on advanced download options and hit download. It will ask you this 64-bit. Okay. Now, as you install any mobile application, just go ahead and install Power BI desktop also. Once you install it, you should be able to see a screen like this that you'll see on my screen now. Okay, you should be seeing the screen like mine once you complete the installation. Here the examples that you see, that it will be blank for you, but the interface will look like this. Some people will say that I have installed Power BI 2 months back, 3 months back, 1 year back. Please upgrade it. Those who have used Power BI before and you have older versions, then please upgrade, guys. It's good always to have the latest version of the software when you are learning it. Okay. Now, you know that in order to work on Power BI, we need data, right? Without data, we can't work on Power BI, correct? Okay. We have seen that in the BI infrastructure or architecture diagram, understanding the business is really very important for a data analyst, for a business analyst in order to work, correct? Understanding the business is very important. What is the end result you are expecting is very important, because without that, it's like shooting an arrow in the dark. Where it goes, where it hits, I don't know. Understanding the data is very, very important. So now, what is global superstore data? So global superstore data is a sales database, sales, which sells various products across multiple countries across the world. And the company is in function from the year 2016 till 2019. I have the data of 4 years and has presence of in various countries, around 140 countries, and have a customer base of a small customer base. I would say it is like 1600 customers, and revenue so far generated is 12.64 million. Now guys, I know that from what duration, what to what duration the company is active, how many countries I have business in, and what is the revenue, and I have various categories of products. Now, what analysis that I want to do here? I have various tables in that Excel file, which is sales, which is customer, you have people, and you have return. Now, by connecting all these data sources, you will see a data model that you will see how we'll create that in Power BI. Now, what are some analysis that you can do from this data set? I can definitely analyze sales by time, which could be sales by year, sales by month, sales by quarter, production cost, profit, percentage of profit, year over year analysis, month over month analysis. That means time based every analysis that I can do that will help my business know across the board, across the time, how my sales is varying. That will help me understand during what part of the year my sales is better and during what part of the year my sales needs to be improved. Definitely that is a point where my business should take some decisions. Yes, Arif, that's nice. We can do that time based analysis. Customers. Which are the customers which are giving me sales regularly? Which are the customers who are not giving me enough sales? Which are the products which are being sold more compared to the others? Which country I'm getting more demand? Which country I'm not getting the more demand? So all these insights, if I can build, then definitely my business owners, they can go back and work where my company is lacking. Do you agree with this? So that's the whole idea about these sessions, where we'll be using the data set of global superstore, and we'll be doing a lot of data transformations. We will be doing data cleaning, we'll be doing visualizations, and then delivering that to the end user in a presentable manner to be consumed for their decision making. Please make a note of this. Okay, guys. So now we know the destination, we have the vehicle ready, and we have the fuel. So let's start the journey. Fantastic. Okay, now if I click on new report here, see, if I click on new report here, the window will change. You'll see a window like this. Everyone, are you seeing the same window? If you just click on new, perfect. Now, if I ask you to break this BI process, guys, if I ask you to break this BI process into 3 different segments, what would be those segment look like? First one would be data collection, or model. Second would be data transformation or sorting or cleaning. Third one would be the visualization and sharing. Correct? Will these be 3 major segment of this entire diagram? Data collection, data model, data transformation, and visualization. Come to Power BI. The same steps I have written here. But Arif, I always write 1, 2, 3 from bottom to top to bottom. Why you have written from bottom to top? There is a separate menu given for every step. That's the reason I have written from bottom to up. Can you see those icons also? There is one more icon, DAX, which has been recently introduced. So don't worry about that for now. You will learn that in future. Do everyone see that 3 icons? One which has a shape like a model, one have a shape like a table, and one have a shape like a chart. And now that represents each fundamental block of BI. Not, I would not say fundamental, I would say like broad level block of BI. So now you have to always start with step 1. You have to always start with step 1. You have to go here. You have to connect to your data sources. pull the data. Once you do that, next you have to come to your data source, do some data cleaning. Once you do the data cleaning, then only you can build your visualization. Making sense? Okay. Next, as we know that, which are the three major steps? Let's go and see our first tab, which is model view. Currently it's blank. Why is it blank? Arif, you have not loaded anything. There is a reason it's blank. Go ahead, load. On the home menu, you have get data option. If I click on get data, I will see some sample data source to which I can connect and get the data. But I'll click on more to show you the possibilities of Power BI. I'll show you the possibilities of Power BI. If you see here, I keep on scrolling down, 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 down. The data source connections are not coming to an end. Yes, guys, these are the various data sources that I can connect. As Power BI is a BI tool, if you see in the diagram, operation system. Operation system can be anything, right? Operation system could be an web data, it could be Excel file, it could be CSV file. That means an ideal BI tool should be able to connect to as many as data sources which are available in the real world. And that is what Power BI is trying to do. Power BI is trying to help with so many different types of data connectivity options. That's nice. You have to pick one from this. Now people will say, Arif, I have a server. Okay, go ahead. You have SQL server, you have Oracle server, you have IBM server, you have MySQL server, you have Postgres server, you have SAP server, you have Teradata. You have so many different servers which are available. In our session also, you'll be learning how to connect to servers. Then files. You have Excel file, you have CSV file, you have JSON file, SharePoint folder file. You have many things. Some web services. You have data from web services also. Can get. But where is our data currently? Microsoft Excel. My Excel workbook. I'll click on that. It will ask me, Arif, tell me where is your file? Your file is in this folder. It will not do live data, but you can get the data from APIs and you can store that here. Next, I'll select the file and I'll click on open. So you should be getting the interface like mine. Okay. Now, this is an interface where you are given an option to check whether your data is in right shape or row. If I click on orders table, I see initial glance of the data that it is in right shape. Headers are populating correctly. If I move towards right, all the headers are populated correctly and I see the data also looks good initial glance. Similarly, I'll check for customer table. The data looks good at the initial glance. But do you see the people table data looks good on the initial glance? Headers are incorrect. Correct? Headers are not populated correctly. Column names are treated here below as a data point. Column names are treated as a data rows rather than showing that as a column name, it is showing as a data row, which is incorrect. So now I will not load these tables now. If this is a scenario, you have to click on transform data. It will open Power Query for me, which we will be exploring in future sessions. Okay. But for the orders table and customer table, I need not click on Power Query. I can just click on load data because I see the data shape is good. Data is in the good shape. Then I need not go to Power Query here. I can just go to load and load that in Power BI. I'll select only one table. Don't select multiple tables. I have selected only one table for now because what analysis I want to do is all information is available in one table. I'll select the orders table and click on load. Now what that is doing, it is pulling all the lines of the Excel file and it is loading that into one table and showing that into Power BI for me. Click on load, only one table, orders. So I have successfully imported all the records from that table into Power BI. It's so simple. Arif, connecting to the source and bringing that into Power BI, it's so simple. I did that. It's not a warning. Ignore it. Now it is showing. Now is it showing the warning? No, right? So don't worry about it. It has a different purpose. Whenever you do some transformation in Power Query and then move to Power BI, at that time that comes. Initially that will show. So you need not worry. So this is the way that I import a data table. I'll come to that point. Why summation? Why blank? You will see that now. Now, this is my table. And on the right hand side, properties will be there about this table. If I click on this, it will show me various properties of this table. Okay, what is the name of the table? If you want to give some description for the table, you can give it. You want to hide the table, you can hide it. Now, all these columns, you can see here on the right hand side, if you expand this, like, see, I'm expanding that table. Now I will see all the columns available in this table on the right hand side. And now people are asking that, Arif, why some places it is summation, some places it is blank, and some places it is a different symbol? Why? It's the data type. What kind of data is there in that specific column? You don't worry about it. You have to select the table, then it will show. You are not in the first step. Those who are not seeing this data model, they are in the wrong step. You should be in this step only to see this table and to see this interface. So you have to select this table, then you will see properties. Without selecting the tables, you will not see properties. Once you select the table and then expand this icon here, you will see all the columns and you will see the data type. What do you mean by data type? What do you mean by data type? In data, type of data. It could be character data, it could be number data, it could be date data, it could be binary data. Okay, I'm not going to deal with that row label option. You can ignore that. What is important? We will see that. You will see all those things in future. But what is important for now is this. Okay, now step 1 is this much only. We'll be bringing in more tables here. Like we'll bring customer table, we'll bring people table, we'll be importing that. But for now, we need only this table. Because why? Because I want to do time-based analysis. And all my time-based columns are available here. Order date is here, sales is here, profit is here, quantity is here. To do time-based analysis, I have my date field also, and I have my metric fields also. So I'm good with that now for now. Next is what? Next step is what? Second step, go and check whether my data is in right shape and right data is available or no. Now transform clean. Now people will ask here, Arif, how do I understand if your data is clean? What do you mean by data cleaning? How can I say my data is clean and it does not need any transformation? What do you mean by transformation? Transformation means adding a new column, removing a column from the table, changing the data type, changing the format, calculating the null values, all those things. Correct? Null values, duplicate records, all those things will be there. Now, there might be scenario where your data is already clean. Guys, there can be, right? There can be situations where data is already clean. Some cases, the data is not clean. Some cases, the data might be already cleaned. At least the columns which I want to analyze, those are clean. Example, order date, I can see it's in date format. See, as soon as I click the header, as soon as I click on the header, the column tools menu updated on the top. It is now showing the data type, which I can see from here. Also. I can see the format. I can see the column name and other aspects of that particular column. I see this column is in right shape. Then I see my sales is in right shape. I see my quantity is in right shape. I can see my profit, discount, shipping cost is in right shape. Now people will say, Arif, your PIN code, postal code. Arif, see, postal code is null. Some values are null and some values are not null. That is not in clean. But do I really care at this point of time? Do I really care about postal code at this point of time? Because I want to do time-based analysis. So that means data is never clean. Write a note of this. Data is never completely clean. Data is always just clean enough. Arif, does it make statement make sense? You might be thinking now. I'll repeat my statement one more time. Data is not completely clean, is never completely clean. It is just always clean enough to analyze required information. As per the need, we can clean whenever you want. For now, what I want to analyze, the information is already there. Then do I really need to worry about data cleaning at this point of time? If the information which I require is already there, but any point of time, I can come back and do data cleaning for sure. Hmm? So now there are two ways to do data cleaning. I'll tell you. One is using DAX, data analysis expressions, and another is Power Query. One is graphical method and one is a expression method, coding method. DAX is definitely a expression method, functional language it is, where you write your formulas by yourself. Power Query is where you can do graphical method. You can remove the columns. I'll show you that now. How you can remove the columns and how you can add new columns, that will be seen. For example, some data which is not relevant to my analysis, then people will say, why should I keep that in my table? At the time you can remove. So now what initial checks you can do on your data set is you can check your data type. For example, this row ID, it's a number now. If you think the row ID should be a character, select the column, drop down, and you can change this data type to any of these data type. It's whole number now. I can change it to text also. It has changed the data type. See, it has changed the data type. If people say that order date, I don't like the format. I like the format DDMMYYYY. I'll not change the data type. Data type, let it be same, but I will go and change the format from here. I'll select YYYYMMDD. So it will show me year first, month second, and date last, or the other way around. Some people say that if postal code is not required, right click on that column and you can delete it. These are all basic cleaning, right? These are all very basic cleaning, very basic cleaning that I do. So does delete the column will delete the column in the origin. Whatever you do in Power BI will not affect your original file. Whatever you do, adding a new column also will not affect. Deleting a column also will not affect. It will not affect in any manner. So these are all basic cleaning. What if I have duplicate records? What if I have null values? What if I want to split the columns? What if I want to merge the columns? All those things we will learn. Now we will go through the third step. What is this? Third step, visualization. I still have the interface of the data section, which is carry forwarded from step 1, step 2, and step 3. Now, this is where I create my charts. What do we call this as? You can call this as a page or canvas. Now, how will you create the charts? You have big list of charts available here. You have horizontal bar chart, you have vertical bar chart, you have horizontal clustered chart, vertical clustered chart. Many different types of charts are available, and you have the data. So how you create the chart is you select any chart, it will show up here. Once it show up there, then you have to bring right fields and add in the right areas. Step 1, step 2, then your chart will populate. Step 1 is just click on any of the chart, then bring the right fields and add in the right areas. That will populate your chart. Now, if I click on this chart here, it showed up here. See, observe. I clicked on the first chart here in the list, and then I can see this view here. Now, if I select this, I will see x-axis, y-axis, legend, everything, correct? I can see various areas which will help me to populate this chart. Let's build a chart for sales by year. And if you told that 16, 17, 18, 19 is the sales years that you have, okay, let's build a chart for sales by year. I want to see each year how much sales I'm doing. I will go into order date. It's a date field. Expand. Date hierarchy will be there. Further expand. You will see year. Bring this year and add it in the y-axis, because horizontal chart, y-axis is my dimension and x-axis is my sales. I got my first Power BI chart created, simple as that. Okay. Now people will say that, if I don't like the horizontal bar chart, I want to create a vertical bar chart. So people will then delete the chart and they recreate the chart. Don't delete. Select this chart and click on the vertical chart. It will convert that to that kind of chart. Click on a line chart, it will convert it. Click on the pie chart, it will convert it. Click on the tree map, it will convert it. Click on the funnel chart, it will convert it. Click on the waterfall chart, it will convert it. Correct, guys? That means you always create a basic chart, either bar chart or a table. Then anytime you can check which is the best chart which is giving good look and feel. Correct? You can always do that. So you can change the chart type from one type to other type always. Are you able to see the chart getting converted from one type to other type? That's nice. And now people will say, I want to create a different chart, another chart. I want to fix this chart and I want to create another chart. Okay. You went into focus mode here. There will be a back to report option. You have to click on back to report, it will come there. Okay, I want to create new charts also. Okay, click somewhere on the blank space. Now this time I want to see sales by quarter. I'll click on the pie chart, it showed up. I'll bring and keep it here, and I will add quarter in the legend and sales in the values. I got my pie chart also. Now you can clearly see that quarter 1 is giving 15% of the total sales. Quarter 2 I'm getting 22.7% of the total sales. Quarter 3 I'm getting 27% of the total sales. And in quarter 4, which is highest, I'm getting 34% of my total sales. So across the years also I can see, individual quarter also I can see. So just see the magic. If you want to see which year it is, click on that particular year, you will see the changes in your pie chart automatically. Isn't it nice? Charts are connected. In Power BI, charts are connected. Click on 2018, you'll see only that year values. Click on 2017, you'll see only that year values. Click on 2016, you'll see only that year values. Correct, guys? Values and this one. Now people will say, Arif, is it possible reverse way? People will ask, is it possible reverse way? Click on any quarter, your bar chart also will reflect. See how much composition of sales is coming in quarter 1. How much composition of sales is coming in each quarter of the year. See, I can see that. That means charts are connected to each other. Last chart I will create, which is line chart. I'll create a line chart. I'll keep this here and I will add month in the x-axis and sales in the y-axis. And now you can see your line chart also. And your line chart also will change if you select a particular year. See, the shape of the line chart is changing. Now I can clearly see 2017 sales, which quarter is giving more sales, and if it is giving less sales, then why, in which month. Or if that's so nice, I can see that year, quarter and month in the same view. Means the data are connected. Yeah, click somewhere on the blank space inside the chart because that will check your clicks. So for the bar line chart, what I did, I added x-axis as the month from order date and sales from the table. Then it populated Jan to December. Okay, now let's save our work file. I'm just clicking on save here so that it will ask me save my project with some name. So guys, please save your work. Otherwise, you have to come and do it again. Don't let that happen. Just save your work with some name. I'll say that Intellipaat Superstore B28. I'm giving mine any name as per my understanding. You give any name that you want. And the extension with which it will get saved is PBIX. And then I'll save it. Superstore. Thank you. Puja. Okay. And then save it. And now your work is saved. Now, when you come to the next, you will open exactly the same point where we have stopped. I'll just click on save here or file and save. It will save your work. We know that, guys. How to save any file, we know that. In Excel, Microsoft Word, we have seen that. It's same. Okay. So how do we create a chart? I have the data set on the right hand side. I will select any chart of my choice here. For example, first chart I'll select. I will add the fields that is asked here. I will add the sales in the x-axis because x-axis is the height of the bar. And then year from the order date will go into the y-axis. Yes, this is how I create my chart. And then people say that if I don't like horizontal bar chart, I want to create a vertical bar chart. So people will sometimes they'll delete this chart and they'll redo it. Don't delete it. You can just directly click on this chart and you can change the chart type. See, whatever chart type you want, you can convert that chart type into, so that you can check which look and feel is suitable as per your need. Okay. Then after that, once you have this chart, you have various other features here, like you have legend. Okay, what do you mean by legend? As it's a stacked bar chart, as it is a stacked bar chart, you can further divide your year into a particular dimension, any particular field. Like I want to see this year split by quarter. Bring quarter in the legend. You'll see 4 different colors. The height of the bar is still the same. Did the height of the bar change here, friends? The height of the bar didn't change, but you got further segregation of the values. Now, people say, should I write quarter only? No, you can add a month also here. See, 12 months. You can add months also. Month in the legend. See, any field. So the people will say, and if I want to see based on category also, okay, add category. So any field that you add here, it will divide your chart based on that. That is the legend. People will say, Arif, okay, Arif, I'm okay with the bar chart. Let's go and create some other chart. Okay, pie chart. Formatting, I'm not doing it now. I'll do the formatting after we learn how to create the charts. And now I'll add quarter in the legend for the pie chart and sales in the values. Numbers are showing here, but why numbers are not showing here? All that is doable. All that is doable that we will do in few minutes. Now, final chart is the line chart. Not final, we'll be creating one more. Line chart. I want to see a month in the x-axis and sales in the y-axis. Now, line charts are very powerful. See, they have two other options. Not only legend, they have secondary y-axis also. First, let's see what is legend. Same as the bar graph, the legend could be, see, year. Now, when I add year in the legend, rather than giving a single line for each all the years together, now it is giving 4 separate lines. Now it is giving 4 separate lines. Then what is secondary y-axis? Sometimes people will ask, Arif, this is sales, but along with this, I want to see my profit also. Okay, bring profit and add in secondary y-axis. Now you'll see 2 separate lines. Here you can compare 2 metrics. Based on my sales, does my profit also varying like that? I can do relative analysis. For example, all the years, the profit and sales patterns were good, all the months. But in October, if you see, guys, don't you see? Even though the sales are relatively less, the profit is not that much low. That kind of analysis we can do if we have 2 metrics together. Means how closely 2 metrics are to each other and in what scenarios it is falling apart. So either you can add a legend or you can add a secondary y-axis. Both together are not possible. Now, last chart, before we go for formatting, that doesn't mean that it's the last chart. We'll be learning all the charts here. Now, coming to the map chart, I'll pick up the map chart here. I want to add the fields here. I will add country in the location and legend. All I need not write, need not add any field. I'll just add sales in the size of the bubble. Can you see that? The bubble size is changing based on the sales amount. Taken this map chart here and location will have country and bubble size will have sales amount. Can you see on the right hand side? I have added the fields in this area. Now people will say, if the map chart is populating correctly now, then what is the use of latitudes and longitudes? Sometimes what in your data set, you will not have exact location names. Rather than that, you have latitudes and longitudes. So if you have that, then also you can populate the map chart. It's not like compulsorily you should need a location field only. Without that location field, if you have the latitudes and longitudes, then also your chart will work. And the most beautiful part of dashboarding we have seen is if I click on any of the countries here, the other charts will show only that relevant information. See? Good. People will get map chart as error. Now click on file. Click on file. People who are getting error on the map chart, follow these steps. Click on file. Go to options and settings. Under options and settings, go to options. There, under the security, map and field map visuals, it will be unchecked. Check it and then click on OK and recreate your map chart. It will work. Which file? The data source file? Map error. Just now I did file, options and settings, options and security. And check this. It should be enabled. So you're not picking up the right chart. Which chart you're? There are two types of map chart. One is field area map chart and one is a bubble area map chart. You should be checking the bubble map chart, just map chart. See, field map and just map. So you might have taken field map. Then you have to recreate your chart. After you do the settings there, you have to recreate your chart. No, right? What is missing on the dashboard? Formatting, details, filter, title, logos, many things are missing. So basically, the charts what I wanted are there, but it's not in the way that I want to present. That means formatting is not there. Right format is not there. So if you see here, currently I'm in this menu. Like you have three menus here, you have three menus here also. First is the visual, build visual. Second one is the format visual. See, under the format visual menu I am. So every visual or a chart will have its format menu. See, this chart also will have its own format menu. Line chart will have its own format menu. Map chart will have its own format menu. And also, even the background of the dashboard will have its own format menu. That means you have to format individually each and every item on a dashboard. You have to format individually each and every item on your dashboard. Let's learn about it. So first I want to format my canvas. I'll just go to my formatting option here. And now under the formatting option for the canvas, you will see page information, canvas settings, canvas background, wallpaper, these things. So what is page information? In page information, you will see page name you can set. You can set it here also directly. Need not be that you have to set it here only. See, I'll set it as a sales dashboard. The same name will reflect here. Next, you can set up the canvas size. You can set up what ratio you want. If you want a custom size, you can set up a custom size also. For the custom, you can get that. Now, canvas background. Okay, do you want to see any background, white background? You don't like it? Okay, change the background to any of this color. For the learning purpose, I'll just select some dark color. Even if I select it, nothing is happening. Why? Because transparency is 100%. Reduce the transparency and see, it came up. And now background is done. Similarly, you can go and add a wallpaper as an image. If you have a company background image, you can add that here. All that you can do for canvas. So basically, what is important in canvas formatting is size and background color. Apart from that, it's totally fine. So you can add image as well. Now, formatting of the visual is done. Here is a map chart. Map visual. Now, my canvas background is done. Now I have to format my individual charts also. What all options are there to format the individual charts? Let me select the chart here and see formatting options have changed to chart level formatting. For chart level formatting, it has changed. Now you can do x-axis formatting, y-axis formatting, grid line, zoom slider, columns, ribbons, many other things. But before that, people will confuse and they ask, What is the difference between visual formatting and general formatting? Both are same. I feel both are same, but there is a difference. I'll tell you how to identify that. Where to go for formatting, whether it's general or visual. So now, is this my visual area in the chart? The one which I have highlighted, do you call it the visual area? Anything outside that is general formatting. Anything inside that area is visual formatting. Outside means borders, title, shading, all those things. Internal, that means inside the visual is visual formatting. So it's like basically interior and exterior. Interior formatting is visual formatting. Exterior formatting is general formatting. Can we remember like this? Interior and exterior? It will be easy to remember. Parallelly doing with me. So whenever I am doing any concept, select the chart, select chart, format. And then general formatting, we can do exterior formatting here. Now, if I select general formatting for this chart, I have a title, sum of sales by year. No Arif, let's make it as a meaningful title. Drop down, then I can say sales by year. Okay. Now, if you want to increase the size of this, increase it. If you want to place it in center, place it in center. Then next is you can go to effects. In effects also you have three menus: option background, visual border, and shadow. I'll turn off the background because I want to match the background of my screen. See, you can add a background or you can remove the background. Once the background is removed, I will add a visual border, means border to my chart in the white color. And I will make a little bit round the edge so that it looks round at the corners. Then I will turn on the shading part and I'll give shading as white. Don't you think your chart looks like a 3D view, which is a little bit elevated from the canvas? So you should go select your chart, go to format. Under general, you have all the options. Under the effects, you will see that all options available. And now the title of the chart went black. I know where to change it. Title, change the color to white. So once you do general formatting, let's go to visual formatting. How to come inside and do other formatting. I'll go to visual formatting. And now I have x-axis, y-axis, grid lines, zoom slider, everything available. First, I'll go with top to bottom. First, x-axis. If you see 16, 17, 18, 19 years and the year, this you can format. I'll go to x-axis. I have range, values, and title. Okay, range, whatever range you can select. Values is what important for me. I'll just change the values to white in color. It has turned white, and I can increase the size to 10, whatever size you want. Then similarly for title also, I can change the title to white. It has changed. The same you have x-axis, you will have y-axis also. Values, change it to white. And then title, I can change it to white. The options that what I'm showing now, everyone may be able to do everything, or some people like only minimal formatting. So I'm showing you which are the best practices. Some people may do more than this and some people may do less than this in the formatting, because formatting is an individual choice. How much we want to format, what color we want to put, whether we want to add a background, whether we don't want to add a background, or we want to keep a border, if you don't want to keep a border. It's based on the business, how they wants to see the chart. Okay. So formatting will differ from business to business or personal preference also. Formatting is something that everyone will have their own ideas. I'll go to y-axis. If I don't want the sum of sales like a y-axis here, people will say, Arif, sum of sale doesn't make sense. Can you just make it as sales? I can just make it as sales. You can add values and title also for the y-axis. Now y-axis is done. People will say, Arif, I don't like the grid lines. Which one you don't like? X-axis grid line or y-axis grid line? I don't like the y-axis grid line. Vertical. X-axis, let it be. It gives me a reference. Otherwise, it will be difficult for me to see which particular year has crossed what values mark. Okay, if you want to make it as a solid line, you can keep the pointer minimum to 1. That's about the grid lines. If you want to keep it as a dotted line only, okay, keep it as a dotted line. You can. Then after the grid line, zoom slider. Zoom slider will be used when you have lot of items on the x-axis that you will see when you learn about the different chart. Columns. When I go to columns, you will see colors. Oh, Arif, this is what I wanted. Colors. I can change the colors. I can change the color, whatever color I want. You want to give individual colors? We'll see how to do individual colors based on the formula in some time. But for now, single color. Next, borders for the what? Borders for the labels? No, I don't need that. Columns for borders? I don't need the column borders. Now, I'll go to the data labels. Turn on the data labels. The numbers started showing up here. That is called data labels. Now, in data labels, you have many options: title, values. Important part for me is where you want to place it. Currently, it's in the top. You can place it vertically, change the orientation, or you can move it in the top, middle, or bottom. See, inside center, you can go to inside base based on what you prefer. Now, I'll make it as outside end only. And after I do the positioning, then I'll go to the values. Black color, I don't like. White. Numbers are very small. Increase the size. Units 2.3 millions doesn't make sense. I want thousands. Display units, change it to thousands. 2 decimal points? No, I want only 1 decimal point. Reduce it to 1 decimal point or 0 decimal points. Once you complete this formatting of this chart, if I ask you to format the other charts also, you will think formatting one chart only took so much of time. If I ask you to format all the other charts also like that, you will think, okay, I can't do that because it's so much time consuming and I may end up formatting it differently also. Correct? Out of 10-15 options, 1 or 2 options definitely you may make mistakes and it will start showing differently. Have a look. I'll show some magic trick. Select this chart. Under home menu, format painter, select it. Icon got changed. Your cursor icon got changed. Drop it in the destination chart. Done. Select the chart. Under home menu, format painter, drop it on the destination chart. Done. This trick will save a lot of your time. First, create one chart based on what requirement is. Then you can just format paint the chart. Now, I can see almost everything got copied. Just the title. Okay, title formatting got copied, but the title name will not get copied, right? Or if that makes sense, title name will not get copied. It's about only the formatting. Whichever options match between the two charts, that will get copied. Now, it's up to me. I have to go and change it under the home menu. Now, I'll go into the general and I'll change the title. Sales by quarter, sales by month, sales by country. When you're going to format menu, you have to select a chart, then you have to go to format menu. For every formatting option, you should select the chart, then you should go. And now people will say, Arif, in this chart, the legend is taking more space. Okay, go to this chart. Under the formatting, legend you turn off. But Arif, if I turn off the legend, which year for which quarter, how will I hover over it? You'll get to know. But I want to display that. Okay, details label, you change it to all details. Now you'll see quarter also. So like this minor tweaking, you should learn. What if I do? What changes? It will reflect all those things. So the formatting got copied. 90% of the formatting got copied. 10% because of the chart differences, it will not get copied like color or other things. But that will save a lot of my time. First, I will format my first chart perfectly till the what we need. And then we will just format, copy paste. I know people will be trying to catch up the things, but yes, do it. Select your chart. Under the home menu, you will see format painter. Select it, drop it on the destination chart. See, the icon got changed, right? Parijat? Do you see my cursor icon got changed? Yes, that means I have copied the formatting. And then whichever chart you click, it will paste the formatting there. Select the chart, go to formatting, there will be legend option there. You can turn it off. In x-axis, you have title. In x-axis, you have range, values, and title. You can change the title color here. It's there only. Only thing you have to see. See, if I change it, it will change the color. It has changed. So yes, you have to search. Then only you'll get it. That is the reason I'm giving you so much of time just for formatting, because it will consume some time to search the option. So now slowly my dashboard is taking shape now. If I add some titles, some logos, some slicers, some buttons, then my dashboard will be ready to go. So what is the next thing in my chart, in my dashboard? What is missing? Title. And if you don't have a title, you don't have a logo to display what dashboard it is, what information it is, you will see that. You can change the title to dynamic. You'll see that in future. Based on what fields you add in the chart, you can dynamically change your title. Hmm? When you will learn DAX at that time, we will see that. What is FX? If I go into insert menu on the top, can you all see this elements, text, button, shape, image, button, shape, image? In order to add a title, which element I should take? Definitely text box. If I click on text box, it will show up a text box here. I can move it. I can keep here as I want. I can now define my title. Sales, global, sales, dashboard. I'll just select the text and I'll increase the size to whatever size you want. I'll change it to 28 and then I'll make it a different style, whichever style that you want. For the font, it's possible. I'll change the color of the font to white. Now, you can even add a subtitle also below that in small letters. You can display that. And then I'll go to the formatting menu of this chart again. Under the effects, I'll turn off the background. Similarly, I can add a logo also. How to add a logo? Which element I should take? Image. Select the image. Whichever image that you have on your machine, and you can download any logo from the internet, whichever logo you like. I have taken a logo of this. And now I will reduce the size of this. It will dynamically adjust my logo and bring your logo and keep it here. See, I'll move the title a little bit more and then keep my logo. Is it difficult or easy? How to add text as a title or the logos on the dashboard? Easy, right? Not that difficult. So you have to manually align them. Jay. See, whenever you move a chart, like in PPTs, you'll get the guidelines. Or see, red color lines are coming. Nice. Whenever I try to move a chart, red color guidelines will come. So that will help you to align your chart based on the other charts. To align the objects one beside the other, one above the other. So it's similar. Now people will say, if this space is empty, can we add some like numbers there? Like overall sales, I can see sales in the bar graph. But if I want to see sales, cost, and my orders on the numbers on the top, can we do that? If yes, which object? We can do that. Say you have a card. In the list of charts, do you see card chart? Do you see the card chart on which I have highlighted? If I select that chart will show up here. And I will add just sales to that card. I'll see sales. And I can place it wherever I want in my chart. See, I can place it like this, but the size is very big of the numbers inside it. The legend also is not, I'm not happy with that. So let's format it a little bit. First of all, I'll go to formatting. I'll go to general. I don't want the background. Once you turn on the background, I'll come back to my visual. The callout value, I'll change that color to white. And then size, I don't want 45, it's too big. I'll make it as 30. I'll make it as 30 numlock. 30. 30 is too small. Okay, make it as 36 or 35. Then I don't want the sum of sales at the bottom. There is a category label. See the bottom, what you see, it's called category label. I'll turn it off. If you want to remove that from the bottom and add it on the top, change it here and add a title. Add sales as the title. Make it as center aligned. Change the color of that to white. Does it look good now? My card compared to the initial card, this number is looking good now. Presentable. But if I want multiple of this kind, okay, the shortcut method is select that card, Control plus C, Control plus V, or copy paste. I'm copy pasting the visual from the home menu. Select that, copy, and then paste. I created 3 different copies of my chart. Now this one, I'll change under formatting to, in the field I'll remove this sales and I'll add a profit. Background you remove. And then title, you change it to profit. Similarly, for last one, remove the title, change it to quantity, and the field, you remove the sum of sales and add quantity. Isn't it nice? But people will say that if there are too close, okay, add borders. If you feel they are too close, then add borders. See, they are not even aligned. So you can just align them properly how you want. Example, I'll select this and I'll try to move it. So it will ask me, Arif, align it properly like this. And then I'll just move it. It will say properly align like this. When you move a chart, is it that the red lines helping you? Okay, how much offset I'm leaving from the other charts, up and down, right and left? Check that. That will be really of a great help to align your charts. Just compare to where we started with this dashboard and now is it looking in a really good shape where I can share with my users? Some things I can still add that we will be learning now, like filters, buttons, all those things we'll be adding now. But before that, reach till this point in the dashboard. You have to select the text. Before you resize the text in the header, see here in the title, you have to select the text before you change the size. Many times people, what they do, they'll just click inside and they'll try to change the size. Which part of the text you want to change the size, you have to select it. If you have to delete the entire thing, just click on these 3 dots and then remove option will be there. You can remove it. Go to format. Everything related to background, title, everything on formatting. See, formatting you have it. Effects, background, everything is there. It should show. It might got have hidden between the charts. See, if I select this chart, the 3 dots will get hidden behind it. Sometimes that happens. You have to move the chart and just check where the 3 dots are there. It's just about layout and formatting. It's just about layout. What options I'm getting, even you also should get the same because we are using the latest version of Power BI. What options I'm getting, you also should get the same options on the dashboard. Select the card. Inside the card, you have to add sales first. Then you'll, so just type as done if you have reached till this point. The more the responses, it's better for us to move to the next step. Okay, so now, what else do we need on this dashboard? So now if someone comes and asks you, Arif, I want to see this dashboard for the categories, various categories. Okay, I want to see this dashboard only for particular segment. So now that I don't have anywhere in the chart, right? If someone asks me show this chart for a particular year, I'll select this. It will filter the entire dashboard. Okay, now I can see the values. Okay, if they ask for a particular country, I can click on this. But sometimes that we do analysis is not on the visuals. At that time, we have to take help of slicers. What do you mean by a slicer? These are interactive filters. Have a look. There is a slicer option here. If I click on this slicer, wide guard, delete, dashboard. Now, here is a slicer. And in this slicer, I can add my region. See, I'll select region and I'll add the region here. Now it will show all the 13 regions which are available. Now I can select any region and see your entire dashboard will filter only for that region. Isn't it a really nice way to analyze your data and slice and dice your information? The map chart also is getting filtered. The other information also is getting filtered. If I select Central Asia, I'll see. If I select East, I'll see these countries. EME, I'll see these countries. North, I'll see countries like that. Isn't it nice? I can use it to slice and dice information so that people can see what information they want. Now, if you want to select multiple items, you will not be able to select multiple items here. But how can you make it select multiple items? In the slicer settings, you will see selections. Currently, it's multi-select with control. Okay, that means control to select, multi-select. Okay, Arif, that's nice. But with control key, you want to select multiple values or you want to select without control key? You decided. You want to select it with control key, enable this. If you don't want with control key, just disable this. Now you can select without the control key also. Sometimes some slicer, you want it to be a single select. Make it a single select. It will turn to be a radio button. Try whether the slicer is working or no. Okay. So this is a slicer. This is a slicer. Select that slicer. That slicer will come here. Slicer should have a field, whichever field you want to play with. In this slicer, I have added region. You have to go to formatting, slicer settings, and selections, and just play with these three options. You're not getting checkbox because you are not disabling multi-select with control. Under the selections, slicer settings, visual formatting, you should be getting it. You should be getting is an option available there. If you are using older version of Power BI, then it will be difficult. Have you recently installed Power BI? What if I want the name of the countries? The region that you selected here, Central Asia, see, in the map chart, it will get reflected. Zoom in, it will show India, Pakistan, Afghanistan, Myanmar. This is one slicer that I have added, but you can add multiple slicers. You can add a slicer for country also. For example, I'll just move this slicer a little bit up and then I'll add a country slicer here below. But place is very congested, right? Okay, let me do one thing. I'll go to formatting and I'll just change slicer setting from vertical list to drop down. That will save a lot of my space and I can accommodate more slicers. I'll add this slicer here. I'll take another slicer just below that. I'll add country in it. And now I see country names also. Visual, slicer settings, drop down. Now someone asked, I want to see the countries falling in that particular region. Now currently I'll see all the countries here. Just go and select which region you want. I'll select Central Asia. Now see, only those countries will be visible in the other slicers. So that means what? The slicers will have cascading effect. What do we mean by cascading effect? Means if you select one slicer, a value, the other slicers also will show only that information to you. So it will be very helpful for your analysis. I have only one slicer. Which is the other slicer? Is there? It's a table. This is a matrix. This is only one slicer. It's only one slicer. There are no multiple slicers. Which one? This one? This is the beta option that recently they have added. That is what? Recently they have added the beta option in the recent release. I have not seen that. Can we increase the background window size? No, it is fixed. Canvas settings, you can change it from here, but it is limited to your window screen of your computer. Your computer screen resolution is what? Based on that, it will be fixed. If you want to change that to custom, you can change it. I'll click on the insert menu, buttons. Buttons, now we have seen text, we have seen image, now I'm taking buttons. In buttons, specifically, I'll take Q&A button. Q&A button. I'll bring this Q&A button and I'll keep it here. Now, Arif, what that Q&A button does? Have a look. Press Ctrl and hold on your keyboard and then click on this button. It will open this feature where you can generate charts just by typing the questions. Have a look. Sales by country. If I type it, just select this. It is profiling your data and then it will generate the chart dynamically for you just by typing the question in the real natural language. Can you see that? And now as I have selected only central, in all the versions are there. As I've selected only the Central Asia region, it was showing only 5 countries. If I erase this slicer, now I have all the information here. Now if I click on this Q&A button and now type the same question, see it will show the entire globe. I'm doing it one more time. Sales by country. It will generate the chart and you can see that chart here. And now what type of chart you want? I want that to be a map chart. Just type map. It will generate the map chart for you on the fly. Isn't it nice? It shall take the data from an entire data model. Q&A button. People who are not seeing it, you might not be using the latest version of Power BI. It should be available. Under the buttons Q&A. Now, I can type any question here. For example, people want to see sales by sales and profit by order month. Now see, it will generate that chart for you by profiling your data. If I am able to do, then even you should be able to do, guys. It will take some time to process these statements because it has to fetch the data from data model. It is taking some time for me to generate and it has generated now. Now chart name also you can write it. By default, you can write the chart name also like combo chart. You want to see bar and line both together? I can write the chart name, pie chart, donut chart, map chart, like that. You write the chart name, it will display that information in that. See? And the field names should match based on your data. If it is sales here in the data, it should be sales only you have to type. The name should be same to use this feature. If you're building a dashboard, and in that dashboard, it's not possible for you to add every chart, right? Definitely it's not possible for me to show many charts. Sometimes I will show only the most used charts in the dashboard. But if the user wants to see something more which is not available in the dashboard, he can just click on this. Have a look. Again, I'm showing people who are telling not able to write. Press Ctrl and click on it. It will open this and this type of interface it will show. You have to type your question there. How did I take the button? I went into the elements, drop down, buttons, Q&A button. A quick yes on the chat window. If you guys are able to see that Q&A button, Q&A feature will be really very handy to explore the data. So you can use this in your dashboard if you want users to explore their data by themselves. Type the question correctly, it will show. Might be you're not typing the question correctly. See? SALE. Yes, sales by country. Country also is there. I have sales by profit. Come on. What do you mean by sales by profit? What do you mean by sales by profit? that will show number. You want a measure and you want a dimension to populate a chart. If you just type one metric or two metrics, it will show only that. By profit, they will categorize. No, that will not work. In order to populate any chart in Power BI, you should get a dimension and a measure. Guys, can you build a chart just by using measures, or you need a dimension also to build a chart? We need a dimension also to build a chart. Dimension means a categorical field also you need to build a chart. Exactly. So when you take sales by profit, both are measures. It will show number only. Try, just explore Q&A. Is it working? Q&A. Now have a look. You can use this Q&A to create the charts also directly in the dashboard. Now people will say, is this available just for the users to just see the chart, or I can even create the charts using that? Have a look. If I go to a new page, if I want to create the chart, create the standard charts also, just double click on the canvas. It will open the Q&A feature. Same Q&A, but now to create standard charts. Sales by order year. When I say sales by order year, it will create a chart for me on the canvas, which I can translate to any chart here. See, translate to this chart. Done. I'm just typing a question and selecting what type of chart I want. I'm not adding any field there. Double click. Sales by order quarter pie chart. It will generate a pie chart that I can convert that to a standard visual again. Isn't it nice how we can dynamically generate the chart using Q&A for the user to explore the data, as well as for the developers to create the dashboards? Both. Yes or no? Guys, it has generated. Convert it to a standard visual. Have a look. I'm doing it. Double click. Type sales by order month. Order month. It will show what chart? Convert that to a standard visual. Q&A feature is helpful not only for the end users, for the developers also. So now, similarly to Q&A, you can add other buttons as well. For example, sometimes you want to let users to click on an hyperlink, correct? A website. If you want a user to click on a link and a website should open, I'll click on buttons and I'll take information button here. I'll take info button and I'll keep on this button here. See, this icon I can keep. And then I'll configure the action here. Can you see? For every button, there will be an action. For Q&A button also, there is an action. Action, you can change it. For this button also, you'll have an action. So I'll just change this to an action, turn on, and then different types of actions you can add. You can add bookmark action, drill through action, page navigation action, Q&A action, different actions. I will add web URL action for this. When you say web URL, give a link here. Okay. For example, I'll just take this link, copy this link. Just for example, I'll just close this window and now I will paste this link here. Now what will happen? See, if someone clicks on this, that link will open on the browser. So that has opened on the other screen for me. See, it has opened here. Isn't it a very nice way to give some information to the end user with the help of icons, from guide, how to use the dashboard, some guide about your business process, all those things? It's so helpful. So you can take the button here, any button you can take, only the difference will be action. If I take information button, that button will show up here and you can just go and format it to the right action. Now I can further format this to make it look good like a general button. See, I can just go to the shape. What shape of the button you want? I'll make the shape as a pill shape, and then I'll go and make this in the style. All these are formatting. Whatever you want to format, however you want to format, you can format it. Say you want to add some text, you can add a text. Say info, make it as white. Then you can increase the size of that text if you want. Icon, the icon that you have added, you can change even the icon also, whichever icon you want. And then icon color also you can change. You can add fill option so that it can fill the color, and then you can select any color of your choice for that button. The text, if you want, you can place it in the center. All these formattings you can do for your button to make it look. This will make definitely your buttons look stand out from the other visuals. Do you think so? And what I'm doing, it's just formatting. What you have learned so far, formatting, it's a formatting only. Where we need to give URL? Under the actions. Under the actions, select the web URL and then paste the entire URL, which will start from HTTPS. Don't just add from www dot. You need to give full URL with the protocol as well. And then press Control and click. Then the URL will trigger a web page. Format your buttons, format your actions, and then test it if it is working. Is it working for you? Buttons. Similarly, you can create navigation button also, which will move from page to page. You can create clear slicer button also, which will clear any slices that you have on your dashboard. So all these things will make your dashboard more interactive in nature. Conditional formatting. What do you mean by conditional formatting? On the conditional colors. On a particular chart, how to add conditional colors we will see. How many of us still doing? I'm still doing buttons. Press Control and click. That just clicking will not work. Press Control and hold and then click. And ensure that your link is having the protocol of HTTPS also in front of it. Otherwise, it will not work. So first you open that link on the browser, then copy that entire link, then it will work. See, it's working now. So if you hover over that button, it will give you that message also. Control plus click here to follow link. Recently they have done the changes, but earlier it used to not work without the, but I usually add full protocol link with protocol also.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with iHub IIT Roorkee. Through this course, you'll get to learn data analytics from industry experts and IIT faculty in depth. You'll learn tools like Excel, SQL, Power BI, Python, and K9. This data analytics course is praised by our learners, and their user testimonials are available on our Intellipaat Achievers channel. You can check them out. The link is available in the description below. So if you are really interested in learning data analytics, this is your opportunity. Click on that apply now button right away and get started in your data analytics career journey.